Hey, welcome to Django and Kubernetes. In this one, I'm going to show you step-by-step how to deploy a Django project into production onto a Kubernetes cluster. Now, I partnered with DigitalOcean on this one to use their Kubernetes service to radically simplify this process. Now, part of it is that we actually want our Django project to run on a robust service. The other part is we want to isolate our Django project into what's called a container, a Docker container. And then we want multiple instances of this container to run and then have something to load balance the traffic across these instances. Now, this is what Kubernetes does, and it does it really, really well, among many other things. Like, let's say, for instance, we're going to roll out a new version of our Django project, and we want to test it not on our primary domain. Kubernetes can do this, and it can do it really, really simply and quickly. Then we can promote that project into being our primary service, which is fantastic. And we can do all of this just within Kubernetes. We don't need to rely on other services. So that also means that I can deploy a bunch of microservices as well. Let's say, for instance, you have an AI application that you only want your Django project to have access to. You can do that with Kubernetes. It's really, really cool. The thing is, we're not going to get into that much depth, but we want to see exactly how to build a project, a real project, using Django, Docker, and Kubernetes. Now, if you're already familiar with Docker and Docker Compose, you can probably skip to part 14 where we jump right into Kubernetes. Otherwise, we're going to go ahead and go step by step in getting all of this set up, including on our local environment, getting Docker, the container, Docker Compose, all of that stuff up and running so that we can be as successful as possible in this series. Now, Kubernetes is vast. There's a lot of things that you can do with it. So we're really kind of scratching the surface here, but we're doing it in a really practical way by deploying a Django project. So if that excites you like it does me, let's go ahead and jump right in. Thanks for watching. All right, so let's go ahead and talk about some of the requirements and recommendations to get these things correct within this project. Now, first and foremost, we're going to be using Django, which is written in the Python programming language. You don't have to download Django at this point. You just need to have Python installed. Now, depending on your system, you're going to go into python.org/downloads. You're going to look for your actual system. Now, in my case, I would actually click on this link here for my system, not just download Python 3.10. You could probably use 3.10, but I'm going to recommend that you use at least 3.9, potentially even 3.8. So I'm on a Mac. I'm going to go ahead and click on Mac, and I'm going to look for the 3.9 version that has an installer here. I'm on an Intel machine, as I've mentioned before, which you can see inside of your about preferences on whether or not it's Intel or it's a Apple Silicon. If it's Apple Silicon, just do the universal installer. That probably works for both of them. But the general idea is there is an installer. Now, if you're on Windows, very similar to this, you're going to go ahead and look for the Windows installer based off of your machine, 64-bit, 32-bit, and so on. Now, one of the things about Windows that we want to do is when you are running the installation process, you're going to want to store your version of Python right here. So typically speaking, if you were to install Python 3.9, you would store it in your C drive at the root at Python 39 so that you can execute it from here. This will become incredibly important when we create a virtual environment with this. Now, if you're already comfortable with virtual environments in Python, by all means, skip that recommendation. If you're on a Mac or Linux, once you install Python 3.9, you can just run Python 3.9 and all of that. Now, the Kubernetes command line tool is something we'll install. I actually have two separate videos, both for Mac and Windows, on how to install this. The Linux guide on the Kubernetes is actually really, really easy to do. So you can just follow along with that. I assume that if you're using Linux, you probably already have somewhat of an idea of following some of those guides. So if you're on macOS, go ahead and install Homebrew. If you're on Windows, go ahead and install Chocolatey. Those will be the tools we'll use to install Kubernetes. Next, of course, I kind of recommend that you install Docker Desktop. I'll talk about this more in general, but install it for your local machine so you can actually run Docker commands, because we will be using Docker throughout. Now, I also recommend that if you are really unfamiliar with Docker and you're not really ready to just jump into Docker stuff, check out my series called Docker and Docker Compose. That goes into a lot more depth than what we'll do throughout here. I'll remind you about that when we get there as well. Next, of course, is actually eventually we're going to install the doctl or the DigitalOcean command line tool. We'll use this for a number of things in the future as well. So be sure to install that too at some point. So those will be installed. The only thing you really need installed right now is Python 3.9 on your local machine, because I have a video or a whole section for Mac or Windows on kubectl itself that also mentions Docker Desktop. Now, if you're not familiar with Python at all, if you're not familiar with Django at all, I recommend that you take 30 days of Python for newbies in Python, or try Django 3.2 if you've never actually done anything in Django. And you could probably do up to the first like 30 lessons or so, or you could also do this concurrently. What we're doing here is actually really fundamental, basic Django stuff to get it into production. That's really it. There's not going to be a whole lot of in-depth Django on this series. It's all about preparing a really simple Django project to get that into production in a meaningful manner. So that's pretty much it for the recommendations and requirements. Again, Python is required because we're building a Python application. If you weren't building a Python application, well, I would probably just recommend that you do our Docker and Docker Compose series and then install Kubernetes. But of course, we are actually building a Python application, and I want to show you exactly how to do that. So regardless of your background, you'll be able to actually deploy a robust Django application into production, even if you only know a little bit about Django, which I think is really, really cool. So if you have any questions on this stuff, please let me know in the comments. I'm sure I will reiterate a lot of these things throughout this series because, well, some of them are necessary, and I tend to repeat myself on some of those basics. So forgive me for that if it does cause a little bit of a, hey, you already said this in your mind. Anyways, so now let's go ahead and take a look at how we actually can install Kubernetes CTL or kubectl on our local machine. Now we're going to go ahead and install the Kubernetes command line tool called kubectl using Homebrew. If you have Homebrew installed, the command is simple. It's either brew install kubernetes-cli or brew install kubectl. Kubectl is the actual command that we'll be using inside a terminal, VS Code, wherever, to actually manage our Kubernetes cluster. Now, I will mention what we're installing here is not a Kubernetes cluster. We're not creating a cluster on our local machine. Instead, we are installing a tool to manage the cluster itself. So that means that we actually don't have to have Kubernetes running locally. In fact, I recommend as you're learning, you do not have it running locally because it can muddy up your machine quite a bit. And it also adds a layer of complexity of installation that we just don't want to go through. We're going to be using DigitalOcean's services for all of that. Now, if you have Kubernetes already installed and you already have Docker installed, feel free to skip the rest of this video. But I want to mention that you also should probably install Docker Desktop on your local machine. Now, I have an Intel chip currently, but at some point I'll probably have an Apple chip. To know the difference between those two, just click on this Apple here, go to About This Mac, and what you will see is the kind of chip that you have right next to that processor. It should say the Apple or Intel, depending on what you have. Really simple way to do that. So installing Docker, what this ends up doing is it allows you to run the Docker PS command. So assuming that Docker is installed, you'll see something like this, or you'll just see this top line here. You won't necessarily see things running. And so the reason that I recommend that you install Docker is because that's what Kubernetes does. It actually manages our Docker containers for us. Kubernetes is a container orchestration tool. So having Docker installed and understanding at least some of the fundamentals of Docker is actually important. I'm going to go through all of those fundamentals in order for this project to work with Kubernetes. It's pretty straightforward. It's not really that complicated because in the case for us, what we're using with Docker is really just like, hey, this is what needs to be installed on the machine that's going to run our web application. Essentially, it's like installation requirements beyond the actual web application itself, right? So if you need Python installed, for example, you need to tell Docker that. That's a good example of that. So that is getting kubectl going. So let's go ahead and take a look at this install command. I run brew install kubectl. It might take a moment. And of course, if you don't have Homebrew installed, just go to brew.sh, copy this command in. That will install Homebrew for you. Notice that I have the Kubernetes CLI 1.23.3 or 1.23. That's the one that we need, right? And so in my case, it says it's not linked. The only reason for this is because I have multiple users. So I'm going to go ahead and just clear this out and run kubectl version -- client, hit enter, and there we go. So we now see that version is running, and I don't have an error like if I accidentally spelled this incorrectly and typed out version, client. It's going to give me this error. That's obviously not what I want to see. I want to see this as it's being installed. So a really cool pro tip that you might want to have is K as the shortcut or the alias to calling Kubernetes, right? And so to do this, you will really just add in inside. So you would go to sudo ~/.zshrc. Notice that I have Z shell running here. That's the default on Macs now. We'll go to inside of there, and actually it'll be sudo nano, and we'll put in our super user password. And notice that I have this alias right here for kubectl for K. You'll see that often, especially on Macs, that being the alias for running Kubernetes CTL or kubectl. So by all means, do that alias if you like. Obviously, you don't have to, and I'm probably not going to even mention it again or even use K to not confuse anybody, but it's a nice little shortcut that I like to use on my Mac and Linux machines. So next up, what we're going to end up doing is we're actually going to configure our VS Code. Once we actually deploy our Kubernetes cluster, we will configure VS Code so that we can actually run, kubectl git pods, something along those lines. But instead of it not being connecting, I'm going to be able to do it with different projects. Like I'll be able to have multiple versions of Kubernetes clusters running and leveraging VS Code to actually manage switching between those projects. It's actually pretty straightforward on how it's done. I just wanted to mention it now because it's kind of a teaser for what we'll do a little bit later. But before we do any of that, we actually need to get our fundamental project running. We need our Django project actually running, and then we actually need to start mapping it to actual Docker-based services so that we can see how to actually develop locally before we bring it into production on Kubernetes. All right, so now we're going to go ahead and install kubectl. That is the Kubernetes command line tool called kubectl. It's going to allow us to control our Kubernetes clusters. Now, in our case, our cluster is not going to be on our local machine. It's going to be on a remote machine. We'll talk about that a little bit more in just a moment. We're going to install it using Chocolatey. This is a package management tool or software management tool that really just allows you to run commands like this: Choco or Coco install Kubernetes-CLI. So if you already have Chocolatey installed, just run this and you'll have kubectl installed, and then you can skip the remainder of this video. Now, I also recommend that you have Docker Desktop installed. And in the past, you had to have Windows 10 Pro. It looks like Windows 10 Home is now available for Docker Desktop. That has not been my experience. So if you have Windows 10 Home and you are able to install Docker Desktop, and then you're able to open up a PowerShell and do something like Docker PS and see something like this, that's great. That means Docker's actually running and installed. Now, we don't have to have Docker installed on our machine to use Kubernetes, as I just mentioned. However, this series, I'm going to be using Docker to show you how to actually build containers because Kubernetes manages a bunch of containers. So we still need to use Docker Desktop and Docker when we use Kubernetes. Now, that might not be always clear when you hear Kubernetes, but it's definitely the case. We'll see a lot more of that as we go through this series, so just take my word for it for now. So what we're going to want to do is install the Chocolatey software, right? So if you go to chocolatey.org or just search for Chocolatey, you're going to want to install this. Now, notice there's a few different ways on how you can actually install Chocolatey. Just go for the individual way or the generic way, but most likely the individual way because you're most likely working on your own machine and you're going to run through this installation process, right? I think it's fairly straightforward on how you do it. So just go ahead and do that now. It's really just running this code right here and inside of PowerShell. And then once you have that installed, you'll be able to open up a PowerShell and run it as an admin. When you run it as an admin, it'll ask you to verify this, and then you should be able to do Choco or Coco and do something like that. So you can see that Chocolatey is actually installed. And then again, like I mentioned in the beginning, we're going to do Choco or Coco install Kubernetes -CLI. Okay. And you run that. And in my case, I already have Kubernetes installed. Notice that I have Kubernetes 1.23. You want to have at least 1.23. If you don't have 1.23, then you're going to want to upgrade your Kubernetes to verify that you have kubectl or kubectl installed. Of course, you just run kubectl, and then we can do version -- client. This will actually show me the version that I have if I spelled kubectl correctly. And version -- client, hit enter, and there we go. So this first command, which is nice, it shows me that it's not actually installed. Of course, I spelled it incorrectly, but if you type out it correctly and you don't see something like this, but rather you see this, that of course is because you didn't install it correctly. It's certainly possible that when you run Choco, that you might have to actually restart your system. That probably won't happen, but it is possible. I can't rule that out every time. But anyways, so now that we've got this, we can actually do pretty much anything we need to do with kubectl, such as like git pods. Now in my case, it's not actually going to work. I don't actually have a Kubernetes cluster set up. Your case will probably be the same. So what's going to happen now is going forward, we will actually configure a Kubernetes cluster at some point in this series, and then we'll use kubectl to make that happen. Now, I'm going to be running all of this stuff on a Mac. So if you have a Linux, it's going to be almost the identical commands. If you have a Windows, it should be almost identical commands. They should be basically the same things, but unfortunately, it's not, right? So PowerShell and Terminal, PowerShell, of course, is on Windows, Terminal is on Mac and Linux, have minor differences in commands. They are minor. Just trust me that they're minor. But we're also going to be using VS Code, which actually helps make this a lot easier so that the command differences pretty much go away. But the nice thing about kubectl it is cross-platform. So most of the kubectl commands are identical. So if there are minor changes that I miss and you either don't know the answer or do know the answer, just ask a question or help somebody else figure this out too, because we're not going to be recording two versions of this for Windows and Mac because kubectl is almost identical with the exception of the installation process, which is why this video exists. So if you have any questions on this, let me know in the comments. And of course, if you're having any issues with Docker, then you might have to skip some of those sections, or you could always provision a actual virtual machine, a Linux virtual machine, install Kubernetes and Docker on that, and then you can actually run all of these commands through that Linux virtual machine. So let me know if you want to see how to create a remote Linux virtual machine so you can actually run those commands through your Windows. There also is the Linux subsystem on Windows, which is something else that you could use. But again, I didn't want to make everything a little too complicated. I just wanted to mention all of the different tools on how you could use kubectl on Windows. And if I missed anything, let me know in the comments. Now we can keep going and actually start provisioning our cluster. So now we're going to go ahead and jump into creating a virtual environment. Now, if you're on a Windows, hopefully your Python 3.9 is in this location, like I mentioned in the recommended installations portion. If it's not in this location, navigate to where it is so you can actually execute Python 3.9, and then you can run -v like I have. If you're on a Mac or Linux and you also have 3.9 installed, you should be able to just run -V and get that Python 3.9 is there. Versus if I did 3. Some weird number, it's going to give me this error. And of course, in my case on a actual Mac, it's also going to give me that error But if you're on a Windows, you're going to call that and do -v just like that. Okay. So the next thing is I also want to make sure that I have Docker installed. In my case, I do. And then I want to do kubectl version -- client. These are just verifying, hey, I've got some of the fundamental things that I needed installed to go. If you don't have these things installed, go back and watch what I did before. Okay, so I'm going to be creating a virtual environment now for my project. Now, what I want to do is I want to store my entire project inside of a folder called Django-K8 inside of my dev folder. Okay, so this dev folder is something that I created a while ago. So I'm going to go ahead and just do make dir -p. If it doesn't work on Windows, just do make dir and then dev and then /Django/K8. So in other words, I'm making a dev folder and then another folder called Django-K8. And if you're on Mac or Linux, you can just do make dir -p dev Django-K8. This -p, it actually will create all parent directories if they do not exist. Okay, so now I'm going to go ahead and cd in here and we'll list things out, and I have nothing in here currently, right? Not that big of a surprise. So what I want to do is I'm going to create a virtual environment for this entire project. So I don't actually have to create a virtual environment for my entire project if I add new services to my Kubernetes cluster. I'm only going to be creating a Django service in this case, which we'll see. That might not make a whole lot of sense right now, but the general idea is I'm just creating a single virtual environment for this whole project. So I'm going to go ahead and do Python 3.9 or whichever path to actually execute this version of Python. And then we'll do -m venv and then venv. So all this is doing is initializing a virtual environment in a folder called venv. Me personally, I don't always do it this method, but I wanted to make it as simple and straightforward for everyone to run a virtual environment. Okay, so now inside of this folder, all I have is this venv folder. Now, if you do it like I've done it in the past, where it's venv period, that's going to create a different kind of setup where it has now these other folders in here as well. Just having it in the venv folder makes it a little bit simple because then all of my virtual environment stuff is inside of there. So I'm going to go ahead and just remove these real quick. And this is really for those of you who have followed me in the past or have seen a number of my items in the past as well. So there we go. So now I just have that venv folder. So to activate this on Mac and Linux, it's source venv/bin/activate. That creates our virtual environment just like that. If you're on Windows, of course, it's going to be ./venv/scripts/activate, and that will actually activate it for you as well. And you'll know it's activated by seeing this venv in the front. And also now, if I do pip freeze, I should see nothing installed. And also if I just type out python-v, regardless of what system you're on, assuming the virtual environment's activated, it should actually give you the correct version of Python now. In other words, if you're on Windows, you don't have to have that c/python39/python.exe. And then if you're on Mac and Linux, you don't have to do Python 3.9, although you still can. You just don't need to. Okay? So that's pretty much it. That is now our virtual environment, right? It's really straightforward. The one thing I like to do with virtual environments is upgrade pip as soon as I actually initialize a virtual environment. You don't always have to do this. I still hesitate updating pip because 8 years ago, one time I updated it and it just broke everything. None of that has happened since, but it often is a good idea to upgrade pip on a regular basis. And again, that's the command right there. Pip can upgrade itself. How cool is that? Okay, so now what we're going to do is we're going to go ahead and actually create our Django project. We'll go ahead and install some requirements and create it. Now, the thing here is we could absolutely add this entire folder to a text editor, something like VS Code. I'm just not going to do that yet. If you're already really comfortable with VS Code, by all means, go ahead and do it. I'm just going to stay with the command line just for a little bit longer so we can see how to do a number of things here. For those of you who are already well familiar with Django, these are the requirements. Go ahead and install them and then just run Django-admin start project, Django_K8 period inside of that web folder so it looks like this. Also add this project to VS Code. That's for those of you who are a little bit more advanced. If you're not as advanced, let's go ahead and take a look at how to do this, well, step by step, nice and slowly too. All right, so now we're going to go ahead and install our necessary requirements and start our Django project. But unfortunately, I actually closed down my terminal and I don't have the virtual environment activated. I'm doing this for those of you who are not incredibly familiar with this. So what we want to do is we want to navigate to where our Django project was. In my case, it's in dev and Django-K8s. And there's my actual VE&V folder. Now this tilde will actually give me my user root folder. So in other words, tilde is actually showing me this. It's a shortcut to give my user root folder. That's it. And that's true on a Linux, Mac, and Windows. It just, the slash might be in a different direction, especially if you're using PowerShell, it should work in both ways. In any case, we now navigate into this folder and I need to activate this virtual environment. As a refresher, to activate on a actual Mac or Linux, it's source venv bin activate. And to activate on a actual Windows, it's /venv scripts /activate, just like that. And then you'll have this virtual environment activated. I'm not going to show that again, other than the fact that if you type out deactivate, it deactivates it, and then you need to reactivate it again in order to work inside of this Python-like isolation. That's really the key with a virtual environment. It's really just to isolate Python projects from each other, which is why I mentioned I'm only doing a Django project in the last one. So I don't have multiple Python projects in here, although I definitely could. Kubernetes excels at that, and so does Docker. In any case, we now need to create our requirements file. So what I'm going to do first, though, is I'm going to make a directory called web, and I'm going to cd into this directory called web. Now, this is actually where I'm going to have all of my stuff related to Django specifically. That's going to be our requirements. That's going to be our Dockerfile. That's going to be everything that's related to this particular project. You don't always do this. This is just something that I'm going to do. And so I can actually run these things. So now what I want to do is run pip install, and then we're going to run Django inside of quotes greater than or equal to 3.2 and then less than 4.0. Now, why am I using Django 3.2? Let's go ahead and take a look at djangoproject.com. Go into downloads, and you'll see that 4.0 is the latest version that's out. However, if you scroll down a bit, you'll see that 3.2 is a LTS, a long-term support release. I'm in the first part of 2022 here, and so in 2024, 3.2 will still be well supported because the 4.2 LTS will be out at that point. Now, you don't have to use this version of Django. You can use older versions of Django too, even 2.2. Heck, you could probably even get away with Django 1.2, although I wouldn't recommend it because we're going to be doing stuff that's specific to 3.2, and different versions might have just slight changes in here. So if you have an older version of Django that you still want to test out, by all means, go ahead and do that. But anyways, this is a nice and simple way to install the latest version of 3.2, or really whatever this package name is, inside of our virtual environment. So I'll go ahead and enter, and that's going to install that for me. So while that's running, I'm also going to now open up VS Code. So on code.visualstudio.com, you can download this free text editor. It's free, it's robust, it's powerful, it's really, really good. So I recommend that you do use this. You don't have to. You can use the terminal all you want, but I'm going to go ahead and use this. Now, I already have it installed, so if I run open period, this should open up this folder, this window right here. If you're on a Windows, it's going to be II period, and that will open up this folder. Now, another thing we can do is go back a little bit into the root of our entire project, where venv and web are, and run code.period. And what this will actually do is open up this project inside of VS Code. Now, if that didn't work for you, just go ahead and open up a VS Code and then a new window, and then you can just navigate into the Explorer here, click on Open Folder. This works on all systems exactly the same, and then you're just going to want to navigate to your dev folder into where Django K8s is, and then you'll go ahead and open that. Now, in my case, this folder is inside of my users, inside of CFE, inside of dev, and then you can see it right there. And then you just go ahead and open it just like that, which I already have it open. Next, of course, I'm going to go ahead and file, and I'm going to save this workspace as, and it's going to be just Django-K8. There we go. Cool. I will actually do some stuff with this code workspace settings a little bit later, but for now I'm going to leave it as is. And then inside of web, what I want to do is add in requirements.txt, and we're going to add in that Django greater than or equal to 3.2, comma, less than 4.0. Okay, that's so we have the correct version of Django. Then we're going to go ahead and add in gunicorn. This is a web server gateway interface that's required for production versions of Django, which we'll talk about. Then we'll go ahead and do requests. We'll also do Django-.env. We'll also run psycop g2-binary. If you use newer versions of Django, you can probably just get away with this. But the binary means that I don't have to worry about as much on the Docker side of things, which we'll talk about when we get there too. Next, of course, is going to be Django-storages and then Bodo 3. These last two I might not use. In fact, these last three I might not actually end up using, but this is like the bare minimum I do in pretty much every project that I work on inside of a production-ready Django project. Okay, so now that I've got this, I'm going to open up my terminal with Control tilde. That should be the same on Windows as well. Tilde, of course, being that, right? And so Control tilde will toggle this terminal being open. And as of now, the terminal is not activating my virtual environment by default. That's actually not fun. I would rather it activate my virtual environment by default, which is a setting I'll set up on my code workspace later. But for now, I'll go ahead and do source venv bin/activate. Okay. And then I'll navigate into my web folder, and then I'll just run pip install-r requirements.txt. Now, if you're already familiar with this process, you're probably like, dude, why are you taking so long just to explain requirements? This is for those of you who are not familiar with this method of requirements, not for those of you that are. So that's really it. And when you go into production, you want to make sure that you get even these basic things right. Otherwise, you're going to run into a lot of issues, and it's going to be incredibly frustrating. So I'm just trying to make it so it's not incredibly frustrating for the most of us. Anyways, now we're going to go ahead and start our Django project. It's really simple. Django-admin, start project, and then the name of our project. In my case, I'm keeping Django-K8 as the name of my Django project, as well as the folder for the entire Kubernetes project. I'm going to go ahead and hit period here. So it creates it inside of this web folder. And there we go. So I now have my Django project going. Of course, this will only work if I activated my virtual environment and I ran all of the installations necessary here. Next up, we need to actually declare our environment variables that are going to be run locally. Let's go ahead and do that. Now we're going to go ahead and implement some environment variables inside of our web folder here. So we're going to go ahead and add a new file and do .env. So since we just created this .env, I also want to make sure that if I do use Git, which I want to use Git as far as version control is concerned, I'm going to add a gitignore file as well and make sure that web.env is not in there at all. Now, this .env file is a very common way to declare our environment variables for any given project. A good example of this would be something like Django superuser password. We don't want this password anywhere, right? So this password is going to exist in .env on our local machine, but we definitely do not want it in Git, which is why I created that gitignore, or actually added env to the gitignore, but I still need to use these sensitive keys locally. And so that's what we're going to be doing here. And so I'm going to go ahead and copy and paste a number of these. And you can pause it now and go ahead and copy these as well. But the idea here is we want to have all of these environment variables in our project. Now you might be wondering, these things right here, these settings are only for something later inside of when we do Docker Compose and Docker related things. So you don't really have to worry about these just yet because they're not available yet. We will fix that soon. But of course, now I need my project, my actual Django project, to be able to read this .env file. But the nice thing about this, especially when working locally, is something like this debug key here. I can change it from 0 to 1. And when I do those changes, then I can actually have my settings being up to date with that. So this debug here, I can actually toggle this between 0 and 1 to make sure that my environment variables are working correctly. This is something I will change once I actually can load in these environment variables. Right now, I have no way to actually load them in. That, of course, is why we actually installed Django-dotenv in our project. So we now actually need to configure that in order for Django to actually read these environment variables. Now, I will say these don't have to just be secrets, right? Like in the case of the username being admin. Perhaps you want that a secret, perhaps not. Or perhaps that you want just something like region in here. And in my case, you can add in it as a quote, or you can just say something like Texas. That's where I am. And so you could say stuff like that where it's just something that you might toggle in your production environment, right? You might actually change this in production. Then you don't actually have to go into your code at all, make any changes. Instead, they're environment variables that you can change inside of your environment at any given time. However, environment variables are typically where people put sensitive information as well, because that will change from your local environment to your production environment, as we'll see going forward. Before I go any further, I just want to mention that I initialized Git, a version control that also has the Python git ignore from GitHub itself. Now, I have this initialized. That's why things are green in here now. And you'll see this git ignore file is in there. And so all I'm going to be doing after lessons is I'm going to do git add -- all, and then I'm going to go ahead and commit these changes. So let's say, for instance, we'll call this our initial commit, and then I'll go ahead and actually put this on GitHub. I'll probably move around with branches as well. I just wanted to mention that before we jump in, because this code will have all the references. I just won't show you when I actually save them and put them on GitHub. And also that's why things will turn green. So let's go ahead and see how we actually implement the Django.env into our project itself. It's actually pretty straightforward, especially if you've followed their documentation. So the first thing is we can go in the WSGI file. This is something I use constantly. And so we're going to go ahead and also import pathlib here. And what I want to do is get the path to where our .env file is, which in my case is in the root of my Django project where .env is, which is right next to manage.py. Now the path that I want is actually the same path as this settings right here, right? So you can totally copy that, or I can just be a little bit more explicit on this so you can really just dive in for it and say current dir or current directory is pathlib.path of this file, and then you do .parent. Now, I do encourage you, if you've never seen this before, just go into the Python shell and play around with it so you can see what happens. But in our case, I'm not going to do that. I'm going to also then say base dir is equal to the current dir parent. And as you see here, it's already identical. It's parent.parent. Now, we can't actually use .resolve. That's probably a good idea. In fact, is use .resolve here just to make sure that we're definitely getting that path correct. Okay. So why did I do this base directory? Is because I want the env file path, and that's going to be equal to that base directory /.env. This is why I really like pathlib. It makes it really simple to get paths like this. And typically this is for dividing, right, inside of Python. But in this case, it actually does it for the path. And this should work on a Mac, Linux, or Windows, all of this stuff, which is really great. So now that we have this file path, I can use .env. So I'm going to go ahead and import .env underneath these. So import .env. And then we're going to just call the .env.read_.env of the string of that path. Now, if that file doesn't actually exist, the nice thing about .env is it's not going to raise some major error in here. The WSGI file actually reading this .env is the most important one, not manage.py, which is also what I'm going to end up doing. Manage.py is really just so that when we're running locally, it actually does read that .env file. So I'm going to go ahead and import .env here. And then in this main portion here, I'll just do .env.read.env prior to the main function call here. You could also put it above this as well. But notice that you definitely want it to be executed before the settings module is set as a default. so that the settings module has access to all of those environment variables. So now that we've got this, what we could do is we could actually print out what those things are. So any given environment variable. So let's go ahead and do that region one like I've seen before, or like I said before, inside of my .env file. So let's go ahead and activate our virtual environment, source venv bin/activate. We'll change into our web folder here, and then I'll run python manage.py shell. And I'm going to import OS and then print out the os.environ.get, that region value that I have there, and hit enter. Notice that it says Texas. So that's great. So that is how we actually grab environment variables anywhere on our project, anywhere in our code. And then also, just so you know, environment variables are always in caps like this. That's pretty much how you set the standard environment variables like that. Okay, cool. So that's installing Django-env. So really simple, really useful. Now, some of you might be like, well, are we going to end up using the .env file in production? Now we can, and we also don't have to. So there are actually two different ways on how to think about this. So again, the nice thing about Django.env is if that .env file does not exist, then we won't actually have any errors, which we can try out by changing it. So I'm just going to change that file name real quick just to show you. And I'll go ahead and say .abc or something weird. And we'll exit out of here again, go into the shell. And now you'll actually see this error here, right? So it can't find it, so it doesn't read it. So now if I try to do that OS stuff, so import OS and then os.environ.get region, I should get nothing, right? Because it's just not working. So just an important thing to note with these env files, it will give us that warning. Not a big deal at all, but let's make sure that we've got all the right ones. Great. Let's keep going. Now we're going to go ahead and update our Django settings to handle our Postgres related database settings. Now these configuration items are going to be used later, as I mentioned, but I still want to update my actual settings file itself. And I'll just go ahead and do something like Postgres ready being 0 for now, in case you are wanting to test this. Now, of course, Postgres ready being 0 as opposed to 1, or just not even being there, which we'll probably remove it later. So for now, I'm going to go ahead and use all of these. So jumping into settings.py, the first thing I want to do at the very top is import OS, and then we'll navigate to the bottom, or really just after the other databases configuration here, and I'll paste those in. Right. So what I want to do, of course, is declare the roughly the same names, but now I'm going to go ahead and say db username equals to os path.environ, or rather not path, but os.environ.get, and that's going to be my Postgres username, just like that, right? And so we want to repeat this process a few more times, the next one being our database password, okay? And the only reason I have these variable names different is so that you know that they actually are different values and can be changed over time, as well as they're not going to be identical to what's the environment variable value, again, to not confuse them at all, or confuse them as little as possible. Next, of course, is going to be our DB, probably our database name, but I'll just call this DB database, which is going to be our Postgres database. And then we'll go ahead and grab the host and port as well. So host and port. There we go. And so now I've got all these different things. Let's just make sure that host and port are correct here. And so if I get rid of this, with the exception of database ready, I don't have that yet, I'm going to go ahead and also say DB is available, or just avail. And what I want to do here is I want to make sure that all of these are set. So to do that, I use the Python all here, and I'm going to go ahead and do DB name, password, the database itself, and the host and port. Okay. So of course, the reason I want these all to be set is so that I can actually configure the database as needed. The next one, I'm going to actually leave this in as Postgres ready to grab the environment variable for that. And what I want here is the string of that equaling to the string of 1. In fact, this is the same as what I want to do with debug up here. So So this time, of course, instead of being Postgres ready, it's just simply debug. And we want that to be 1 as well. As of now, I still have it in as 1. Okay, simple enough. So now that things are available, I'll go ahead and do 2 things. So if db is available and this should be avail like that. So we're going to do avail and Postgres ready. Then we're going to update our database settings. So the database settings for Postgres, I'll just go ahead and copy and paste these real quick. It's really simple. We still do the default. We just change the engine from SQLite 3 to this. And then we use our environment variables that we just set. And again, we just want to make sure that these are all the exact same. Otherwise, we'll have some issues. So when we go into production, the main thing here is that if these are not set, if the environment variables are not set, then the production database is no longer available, which I think is really important. We could also now use this parameter in our views somewhere else to see whether or not that database is actually available. And as of now, we don't have that Postgres database, so I'm just going to leave it in as Postgres ready being false, right? So inside of our environment variables, it's currently false. So we're going to just save that as is. And so if I actually wanted to review this, I could print out my database's configuration when I try to go run Django. So let's go ahead and just run Django. Just do run server. I realize there's a number of things that I haven't done in Django yet still. But there we go. We now see what our Django database is. It is the SQLite database. It is not our Postgres database, which we'll solve when we actually implement the Docker Compose related things here. So I'll close that out and that's it. Okay. So naturally now anywhere on our project, if I need to use an OS value, an environment variable value, like our Django secret here, I can do that, right? So this Django secret is not great. We want to make sure that that also changes. So os.environ.get and our Django secret key. Really simple. I'll be sure to link something in the description on how you can generate these secret keys. I'll also be sure to add that in later when we actually go into production. Because of right now, this is not a great one. And it might also warn us about that, but it also might not. So we'll go ahead and leave that as is for now. So that's simple enough on implementing these things. But now we're actually ready to start our Docker related services for a number of reasons, as we'll see going forward. All right, so now we're going to go ahead and prepare our Django project for Docker by creating a Dockerfile. Now inside of our web folder here, we're going to go ahead and create a new file called dockerignore. Now what dockerignore does is it ensures that our Dockerfile doesn't add files that we just don't need, or doesn't copy things, as we'll see. So you can literally copy our .gitignore here and just bring that entire thing in. One of them being that we probably don't want to copy is this .env file. At least we don't want to copy it here. And then we also don't want any virtual environment related stuff, which I think is also already in that gitignore file somewhere as well. So if we do a quick search, we should be able to see that env is also already in the gitignore file. So it's also in the dockerignore file too now at this point. So we don't actually have to put it there. So in any case, now that we've got this dockerignore file, again, still in web, we're going to go ahead and create a Dockerfile. Now, this is going to be an absolute minimum Dockerfile, and it's really meant to just get us going. Docker can be a lot more complex than what we're going to do here, but we could also add in additional installations that our project might need. I mentioned a little bit ago that Postgres, we're using Postgres-binary to make sure that this is just a simple way to get Docker working. This is a good example that there would be additional installations that we'd want to do inside of our Dockerfile to not use Postgres binary, but just simply the Postgres library, just like that. So in any case, let's go ahead and get this Dockerfile going. It's really simple. First and foremost, we say from. So what is it that we're trying to use here at its core? Are we trying to use Ubuntu? Well, you could be, and that's okay. Docker has a lot of Ubuntu images that you can use. Are you trying to use Nginx? Well, no, we don't want to use Nginx here. What we want to use is Python, right? So we are using the Python programming language, but the question is, what version of Python? So to answer this question, we can go to hub.docker.com. I mean, you probably already know what version of Python, but let's go ahead and just search for Python. And inside of here, going into our tags here, we can see all of the versions of Python that are available. So if I type out 3.9, I can see all of the ones that are tagged 3.9 and something, right? So here's 3.9.10-slim, right? What about our Python version? Let's take a look at our Python version before I select anything. In my case, I have 3.9.7, right? So I can absolutely use 3.9.10, but let's actually just stick with the version that we have. So 3.9.7. And notice 3.9.7 slim. You don't have to do -slim, but it makes the Docker container smaller, which is important for our local machine. Notice this compressed size here versus, let's say, the Buster, a different version, has an enormous compressed size in comparison. So we're going to go with that version. Again, there's a lot of ways to optimize Docker and to learn about Docker, and I highly recommend that you do. But for now, we're just going to go ahead and do 3.9.7-slim. And by all means, change this to the version you are using and then the one that you want to use. And you can also use the latest version if you like as well. But we want to be explicit about this and at least match our local environment most likely. If it slightly is different than your local environment, just make sure that the major version is the same. So 3.9 is the same. Now what we're going to do is we want to copy all of the code. All of this code, we want to bring it into our Docker project. And to do this, we do copy./app. So what this is going to do is it's going to copy this entire folder, that's everything in here, including subfolders, into /app. Now the reason we had that dockerignore was to make sure we don't bring in stuff like PyCache like this right here, or precompiled things as well. So that's another reason to have that dockerignore. Copy will actually respect dockerignore, which is nice. Next, we're going to change our working directory to that folder of app. So our entire project now is in app, and then as far as Docker is concerned, it just did this cd/app, if you will, for the remaining commands. So the next thing is I'm going to go ahead and actually run a virtual environment creation. So run python 3-m venv. Then we want to actually, we could do venv just like this, but typically speaking, when you create a virtual environment inside of a Docker container, you're going to put it in the OTP folder. That's just a standard place to put additional installations that you might need to do. In this case, venv is one of those. So that means then also our app itself doesn't have the virtual environment folder within that app folder itself, which is true for our web folder as well. So this web folder and the app folder are going to be the same. They don't have virtual environment in there. So we want to put it in OTP venv. This, of course, is going to be something we'll have to remember because now what we need to do is run that version of pip. So I need to do pip install and requirements.txt, right? So I definitely need to run that, or -r. But of course, the question is, what version of pip? Now, if you're not already familiar, what we can do locally, let's take a look at this and go back into here. If I want to call the virtual environments pip, I just run venv/bin/pip, and that will actually give me that virtual environments pip. This is a little bit easier when we actually run -python or /python and see that. Now this should also work on your Windows machine, just the path is probably going to be a little bit different. So just go into that folder to see that path, right? So I can go into this folder and I can see all of the actual bin scripts that are available. Notice Django-admin's in there. Hey, what do you know? Activate.ps1 is in there as well for you Windows PowerShell users. The only reason I show you this is because now I can use the OTP/venv/bin/pip. Now, everyone needs to do this because this version of Python is running on a Linux machine. It's not running on Windows, it's not running on Mac. So this is actually how we run that installation for our virtual environment. Of course, we need that because these are all the requirements our current project needs to run. Another thing that you'll probably want to do in addition to this is run, something like pip install, -pip -upgrade, like we've already seen. This is an optional step. You don't always have to do that, but I do recommend it. And then the final thing that we want to run is chomod plus x entrypoint.sh. I'll explain this in a moment. After that, we're going to actually execute that. So we'll just do /app/entrypoint.sh. Okay, so what is entrypoint.sh? Well, if you think about running things locally, let's take a look at how I can run this Django project locally. First, I'm going to cd back into web. So I'm sort of emulating what's happening in this Dockerfile here. So what I'm going to do is I'm going to do pwd. I'm going to grab the absolute path to my virtual environment. So absolute path venv. That's the absolute path to that virtual environment. And then if I go into the bin/python, I now have that version of Python. And I can run my manage.py run server. This is the long way of doing it without actually running and activating our virtual environment. That is what entrypoint.sh needs to do. In other words, I don't ever need to activate my virtual environment in here. That's hopefully what's going to clarify that. Entrypoint.sh is going to run things very similar to this, but of course it's not going to be manage.py run server because of course that is the development server. We do not want to run that in production. We want to run gunicorn. We want to run gunicorn in production because that's what it's made for. So of course we need to create that entry point file. So inside of web here, I'm going to go ahead and create entrypoint.sh. And we want to make sure we spell it correctly. So let's rename it to entrypoint.sh. This one, I'm going to go ahead and copy and paste things here. We'll explain everything for this. Okay. First and foremost, this is a bash script. So we declare that it's a bash script. It's not a Python script or something like that. It's just a bash script. And it's really just a text file. It just happens to have .sh. So this is just another way to make sure our system knows it's a bash script. Next, we have an app port. We'll explain that in a second. We also cd into /app. That's so we can reference our Django project. Okay, so there is our Django project. So we've got inside of web, the main configuration folder. That's what this is doing because it's going into app, which again, going back into the Dockerfile, that's where everything is. And then we .wsgi, that's this file here. And then it's looking for this application declaration. That's it. And then we bind it to a specific port. That port, of course, is going to default to port 8000, just like your development server. When you go into production, you might actually change that. And what this does is changes it based off of the environment variable of port. Sorry if that's confusing, but that's what you do. Oftentimes, you'll put a worker temporary directory. This is a good thing to add optionally when you need to. Next, of course, is the final thing is this OTP venv bin gunicorn. This goes back to what we just talked about when we ran the Python version of all this. Let's see where it went. That's this right here. So we're doing roughly that equivalent, but now using gunicorn in production. So if we want to see that equivalent locally, what we would do is run gunicorn here. I'm not going to do everything, but this is giving me my local absolute path to gunicorn. And then I can run Django k8.wsgi application, application. And this should actually run that. And notice the default port here is 8000. I didn't actually change it, but notice it's also bound to this host, which I want to bind it to 000. So it runs on any host without errors. Okay, cool. And so I can cancel out with Control-C. Okay, so that's our Docker file. Very, very minimal, really simple on how we ended up doing all of these things. Now, one of the things you'll often see is notice that this is 3 steps. I don't need this to be 3 steps. In fact, I also want to make sure I'm doing the right upgrade for pip here. And so I'm going to actually change it into 1 step and just do and for the command to run. Chomod plus X just means that this is executable so that Docker can actually run this accordingly. And so now what I'm going to do is have this and then the and then we'll just do a slash here, hit enter. We can tab it in now. And then again, the and slash here, hit enter. That way it's just a little bit cleaner as to what's going on here. In other words, this whole thing can run as one single step. It doesn't have to be multiple. In fact, you can also have the virtual environment as part of that step. I just like having these things separate just so I can see that, hey, this is about creating a virtual environment. This is about installing things and making sure things can run. So they're just slightly different as far as what those tasks are concerned. So that is a huge, fast primer into using Docker. I realize that, and Docker files. Granted, I haven't done anything actually for Docker yet, but I'm also leaving out a big problem that we need to solve. And that has to do with the fact that, if we actually run our Docker or our Django project here, every time I run it, I run Python manage.py, run server. It gives me this warning, unapplied migrations. So it's definitely something I still need to address as far as the migrations are concerned inside of Docker, which I'll talk about. But this is that minimum Docker file. And of course, if you're having any issues with this, check out my series that I mentioned before called Docker and Docker Compose on our website, cfe.sh. That will help clarify a lot of things with Docker, and it also takes a little bit more time to get there. But hopefully this isn't really that complicated given what we've already done. We pretty much have already done all of these steps. And this is why Docker is so powerful, is that I'm basically just saying, hey, computer, or hey, Docker, these are the steps I need to have happen for this environment so my application can actually run through Docker, which means that I can run it. If Docker can run it, I can run this application anywhere. So I don't actually have to provision that virtual machine or that server anywhere. This is the power of Docker. And then when you add in Kubernetes into the mix, then Kubernetes will decide how to redistribute a lot of that stuff, which is also pretty cool. One of the most common commands we need to run inside of a production environment with Django is python manage.py migrate. We need to make sure that our Django code, all of the models, are synced to what the database has. If they aren't synced, then we have an issue. Now, before we actually create the script to do so, I want to address why it's so important that this is done, and it has to do with the Docker container itself, right? So a Docker container or any sort of container is ephemeral. What this means really is that it's just running the code. It's not actually going to stay forever. More than likely, it's going to go away. A database, on the other hand, we want it to stay forever. We want all of that data persistent. We do not want it ephemeral. But our Django code, our web application code, should evolve. Therefore, the things that are running that code should be able to be removed. Now, this is important because if code is changing over time, that probably means our models are changing over time, and therefore our database needs to reflect what those changes are, which is exactly what this python manage.py migrate command does for us. So where can we actually run this command? Now, on one hand, you might be like, okay, well, I'm going to put it into entrypoint.sh. I'll go ahead and grab the Docker, opt venv bin python manage.py migrate, much like we did with gunicorn. And generally speaking, this is okay. It's certainly possible that you're going to want to run this command right in here. This is a nice safeguard, I would say, but it's actually not what I want to do. I will cut this out because I am going to save that path because I still want to run that path. It's roughly the exact same. And I just have this empty file that I'm not going to keep. But the general idea here is this is the migrate command I want to run. Another command that I'll probably want to run at least one time is to create a super user. I need a way to actually log into my admin. Now, you might be wondering, oh, well, what about collect static? Should I put that in there as well? Yes and no. I would say you could either make an entire script for collect static if it's necessary, or you can run this elsewhere because there's a lot of places that you can run collect static that have little to nothing to do with the database. Create super user and migrate both are directly correlated to the database. Collect static is not. Okay, so with this in mind, we want to run those two commands. So I'm going to just go ahead and move collect static up here, paste this here. So these are the two commands that we want to run. How are we going to do this? Well, inside of web, I'm going to create migrate.sh. And it's going to be very similar to what we just saw with our entry point. I'll actually explain this one though. So hashtag !bin/bash. So it's a bash script. Now we're going to go ahead and put Django super user email. And this is going to be equal to the environment variable of that, or the default, whatever defaults you want to put in here. In my case, I'm just putting hello@teamcfe.com. And that, of course, is a real email for my business. But the idea here is we have a super user email. Now for this, it's so we can actually run the create super user command. Now with this one, we would do OTP, venv, bin, and then python manage.py create super user. This email that we want to use here is going to be $ that email. $ so that we can actually run the string substitution. This is how you do it in the case of a bash script, where you can get the environment variable or another variable that's just like this and set that equal to that one. So we could also, maybe just to clarify things, we could just call this super user email. That way we don't get anything confused as far as the variables are concerned. The other part of this is we actually want to cd into our app directory. The only reason we cd into that app directory is to make sure that manage.py is there, because that, of course, is the root of where our Django project is going to be. And of course, that's because of these two lines right here. Cool. So this script now will go into that and then run this create super user. Now, one of the things about this script that will likely happen is, well, after you run it one time, it's going to fail. We want to catch that. So we can just do 2 pipes here. Those are a straight line up and down. It's right next to that slash if you're on a US keyboard, and then just say true. So now every single time this runs, this is not going to fail us out. If we didn't have this, it will fail and it'll run errors for us. Now, of course, before I can even create a super user, I need to make sure that my database is migrated correctly. And to do that, well, we already talked about it. We talked about it a lot. It's Python manage.py, migrate, and then no input. So when we actually run this and it's saying that migrations should have occurred, that is also another potential error that could happen, right? In other words, if we think about this when we run make migrations, that is saying, hey, there's changes that need to happen in the database based off of what Django sees in the code. So run make migrations. This is like to prepare Django to run migrate, to actually make all those changes. But the thing is, we don't want that to happen in a script at all. We want that to happen somewhere else to make sure that those make migration commands are running. In fact, when we actually test our code, so Python manage.py test, there is a way to ensure that we do have our migrations done. So there we go. That is our migrate script. Now you're probably wondering, when are we actually going to end up using this? Well, we're going to use it in a number of places, as we'll see. And it is basically identical to the entry point itself. And of course, this location right here is also directly correlated to this stuff right here, right? So there is a lot of overlap in these script files. And the only reason I spent so much time talking about this one is because making sure that our migrations happen in production are critical. Otherwise, we're going to have errors that are related only to Django, but it feels like Docker is not working or Kubernetes is not working, which is obviously a big problem and could stop you right in your tracks. So now we actually need to run this, and your intuition might be, oh, let's go ahead and pop it in the Dockerfile, just like what we have here. So something like chomod plus x and migrate.sh, and then running migrate.sh, or really it would be something more like bash or sh, which, shell or bash, either one works in this case. That would maybe be your intuition to just do it like this. But unfortunately, that's not how it's going to work, because remember, migrations have to have access to the actual database. When we build the Docker container in this process, we will not have access to the database, most likely. You might have access to certain environment variables, but even that you won't necessarily have access to. This brings me back to collect static and create super user, both of those commands. The actual Docker file itself most likely will not run those commands, even though there might be this like inertia to do so. Now, if there is no inertia to do so, hopefully, well, that's good. But if you're anything like me and you start using Docker a lot more, you're like, oh, wow, can I just automate everything in this Docker file? The answer, of course, is what I'm trying to iterate here is no. But now what we should see is how to actually put this Docker file into action locally with a database. So we can actually test essentially locally what we are trying to do in production. It's not the same test because we're not going to be using Kubernetes locally, but it is closer in that direction because of a tool called Docker Compose. In a moment, we're going to jump into discussing Docker Compose, actually doing some configuration so our local Django project has access to a production-like database really simply all through Docker and Docker Compose. So if you've taken my Docker and Docker Compose series, you can probably just jump to our repo here, go to the 12-in branch, that branch right there, and then go into docker-compose.yaml and actually just copy this YAML file. Now, if this already looks confusing to you, then you should probably watch this whole video. But if it doesn't look confusing to you, then you can just jump past this video and look at part 2. That one's going to be a lot more condensed. One other thing to mention is that we do make some changes to settings.py to ensure that our Django database is actually working. So you also might want to just copy these things too, assuming that you've been doing everything up until this point. So for those of you who are ready to just jump into Docker Compose, this one is a little bit longer, but it's only because we need to configure a number of things in order to them to orchestrate correctly on our local machine. So we get that much closer to using our Kubernetes environment that we will set up. So inside of the root of our entire project, right next to where web is and VE, we're going to make a new file called docker-compose.yaml. It could be YAML or just YML. I like using A for some reason. Anyways, so I am going to call it Docker Compose. This is the default name that you should use. You can use different names, but you have to remember a flag when you do so. I recommend just sticking with Docker-Compose, just like we use just simply Dockerfile. Okay, again, those things can change. First thing we want to do is declare the version, which in this case is 3.9. The version doesn't really matter that much because Docker Compose is basically the same as it's been for a long time. The first thing that I need to declare here is services. And I want to give my first service a name. So I can call this my Django web app if I wanted to, or to simplify things, I'm just going to call it web, much like it's matching the exact same folder here. Okay. Next, what I want to do is declare the build. Now, this build is referring to what container do I want to build here? So where do I build this? Well, in this case, the context is also web, as in this directory right here. Now, if I had the Docker Compose file within the web directory, the context would be a period because it'd be in that directory, but it's not. It's actually in web. We can use that sort of context too to make it a little bit cleaner of a actual context path, if you will. So the path to where I want to build this container. So also declare a Dockerfile. In my case, that Dockerfile is just simply Dockerfile, and that's it. So this will build that container image for us. Now, this is very similar to writing Docker build and then tagging it something and then, using the file. So tagging it, let's say Django-K8 and maybe even with v1 in there, and then using Dockerfile, and then again, using web. Now, in this case, maybe we'd say web like that. And this is probably not even going to work, but we would want to change in that web folder anyway. But that's just generally speaking what's happening here with this Docker Compose. Next, we're going to go ahead and declare the actual image that we want to call this. In this case, I'm going to call this Django K8, as in the image name I want to give this Docker container. So this image name is the Docker container image name, and you can definitely make it something different than this. You could call it like CFE K8 or something like that. You can give it a unique name if you'd like. I'm just naming it the same name as my Django project, roughly speaking. Then I can also tag it with, V1, V2, or 1.0.0, or whatever other additional tag you might want to have on there, much like what we saw here. That's actually what we're doing here is we are declaring this same kind of thing, but just right here. And so, in theory, if you actually push this into the Docker Hub, you could also do stuff very similar to this, which is pretty cool if you're not already aware of that. So there is our web image, okay? So what I can do here is I can actually just leave it as is. And I've got my Docker Compose file in here. Let's make sure I'm in the correct place. I do not want to be in web, but I want to be where Docker Compose is. And now I'm just going to write Docker compose up. So if you're using an older version of Docker Compose or a Linux-based version, you might have to do Docker-composed. But if you're using a newer version of the Docker desktop, you can just write out Docker compose and up. All this is going to do is bring up your services. It's going to actually build the container if it doesn't already exist, and then it's going to run it. Now, notice that it is running and it's saying listening at this part. We'll talk about that in a second. I'm going to stop it by doing Control-C, and that will actually stop this from running. Another way to stop it is to just run Docker compose down in the same directory. I'll do that next. But anyway, so I just did that. Let's go ahead and force the build. If I do -- build, this will now build that Docker container image from scratch, and it'll do it every time, right? So it's not necessarily going to download everything from scratch, but this is actually building it much like you would do with Docker anyway. It's installing everything. It's running everything we would need to see. Now, the first time you run this, it's most likely would have done this same thing too. I just have run it through my own tests, and therefore it was able to just right away go off the bat. And so what I notice here is that I've already got an improperly configured secret key setting is not there. It can't be empty. Now, why is that happening? Well, we go into our environment variables. We've got a secret key here. It says fix this later. And then, well, if we look into our Django code itself, does not have a secret key. So we actually didn't set it. This is one of my favorite things about Docker Compose is that I can then go back into Docker Compose. Let me just close down this terminal here. And I can declare something new, and that is env file. And I can actually use web-//.env. I can do this locally. Another cool thing about that as well is I can say environment, and I can give a key value pair here. So I can give a port value, and let's say, for instance, port 8020 or whatever number. It doesn't really matter there. But this now gives me two different ways of creating my environment variables, which I think is really nice. So now I go to build it again, and we'll see what ends up happening here. First off, it doesn't see the .env file, which is pretty interesting. However, it is running. The application is actually running, which we can see that it's listening also at that port. So if I actually try to open that port, it's like, hey, this isn't working. I can't access this. What's going on here? Well, by default, Docker containers are not accessible to the outside world, which means that even though it's running on my local machine, I can't actually access it unless I do a port mapping, which is by saying ports and declaring some local port, let's say, for instance, 8001, to the internal running port, like 8020. Now, if I do Docker compose down, hit enter, this is going to take this whole thing down. Right? It might take a moment. It might take more than a moment. It might take a little while because this is actually running. This container is actually running. So it will take a little bit for it to come down. But now that it does, I'm going to go ahead and run this up, build it back up again, and see what ends up happening. Notice it still says 8020, but I mapped the port 8001. So now what I'm going to do is just run localhost to 8001. What do you know? There is my Django application. Now, if you're thinking, hey, maybe this is a different Django project running, I can just bring down this Docker Compose and take a look. In a moment, eventually, it's actually going to come down. Okay, and there we go. So now it's no longer accessible. So let's go ahead and build this thing out just a little bit more. The next one is command, and we want to actually run an additional command or change the default command that's happening for our Dockerfile here. So this is going to be sh-c. So this is going to be a shell command. First, what we're going to do is chomod +x app/migrate.sh. We are making app/migrate.sh executable. Where did that happen? Oh yeah, migrate.sh. Oh yeah, Dockerfile. Oh yeah. Okay, so there we go. So this is going to allow me to make that executable. And then I can say and sh/app/migrate.sh. And then I can say and /app/entry point .sh, so the default still goes in there. And now when I run this, it's actually going to work. But of course, we still have another step that we need to take care of here. And that is before we even run these services again. And that's going to be doing PostgreSDB. So actually declaring our Postgres database. This is actually going to be matched a lot closer to what's happening here. Currently, it's not correct. We've got our PostgreSDB, which is fine. We've got our Postgres host, which is this PostgreSDB. In fact, it's the same name. Isn't that interesting? So that is actually what we want to declare this PostgreSDB service host. In other words, if I called this DB, I'd have to come back into my environment variables for Django and change that to DB. That way that they are actually matched up. Okay. And so I'll leave it in as PostgreSDB. Next, what we want to do is declare the image we're going to use for this. In this case, it's going to be just simply Postgres. The next thing I want to do here is I want to expose a port here, and that's going to be the same port that we had up here. Or I'll leave the default for a moment, actually. So we'll leave the default for now, and I'll leave expose 5432 just for now. One more thing that I need to do is I need to say volumes. I need to actually attach what's called a volume to this. Now, what this is going to allow me to do is make sure that my Postgres data stays persistent. It's like if these services go down, that database still has persistent data. That's the point of this. So we'll go ahead and declare a new volume down here. So we'll say volumes, and we'll just call it Postgres data. Which the coolest thing about this is that Docker Compose knows what's going on here. Even if you don't, Docker Compose definitely does. So the volumes that we want to use inside a Postgres database is going to be that volume, whatever we named this, and we want to map that to var lib PostgreSQL/data. Now, if you look at the Postgres image itself, like the actual documentation that they have available, you'll see, roughly speaking, these things going on right here. But there is also a few other things that we want to set, which is our environment variables for this. These are the actual Postgres environment variables. So you can say environment and then come in and give the environment variables. Now, those variables happen to correspond directly to these variables. So you can absolutely put them right here and hard code them into your Docker Compose file. But I think you're probably seeing where I'm going with this, and that is you can also just use that env file as well. Instead of hard coding them in two places, you can just use the same environment variables twice. Pretty cool. Now, both the database server itself has a default for all of these different variables, and the actual Docker Compose does as well. So we have a lot of really good stuff going on here. So now we have the proper database. How cool is this? Okay, so now let's go ahead and try this again. Now that I have the database and migrate, we have this stuff coming up. So in this case, it actually ended up running, and it seems like it ended up working. So if I scroll up a bit, I see that it does apply these migrations. But there actually is another argument that I need to add into the web here, and that is depends on. So we tab this in and do depends on. The service name is going to be the Postgres DB here. Okay, so this depends on means that this won't be built and run until this is available. Because in my case, it just happened to work, but sometimes it won't necessarily work. Okay, so now to test that everything worked correctly, including this migrate stuff, we can go into .env and look for our super user username and password, both things I'm going to work with. I'm going to refresh in this local host here. I think we should be able to have access to the local host now. And it should actually run. Let's see here. We've got our database running. Yeah, it doesn't seem like that went down. Okay, so we'll go ahead and go to localhost 8001. Again, let's verify that it is 8001 and just make sure that I can log in here. There it is. And then go to the admin. And so what's actually happening here is it's actually taken a while, which we will address in the next one. But for now, it's actually going to take a little bit of time. And that's because these actual services communicating with one another does take a little bit of time. That's just how it is, unfortunately. And so I'm going to go ahead and do this slash here at the end and go into admin. Don't worry that the styles are missing. This is just testing things out. Go ahead and log it in. And there we go. So I'm actually able to log in with the exact same credentials as I have in my environment variables for my Django admin user. Pretty cool, right? It's pretty straightforward. But there are things that you might be wondering. It's like, okay, this is, I think, the last most important part of this. And then I'll just copy and paste some Redis code in here as well. And that is the actual, port that you want to use. Okay. So if you already have Postgres on your machine, or you have a number of different projects running, you might have this port already taken. And that's true with our port up here too. That's why I flopped that around a little bit as well. So I actually really want to focus on the database though, because this is the thing that we're going to have as persistent as possible for this project. And so inside of my environment variables, let's say 5433, like I copied and pasted before. That's the port I want now. So to do this, I need expose 5433. That's one thing. But what I also need to do is I need to add in a command in here and just -p 5433. Whatever that port is that I just changed it to, that's what we need to do. And then we just bring down our running images, everything that's running, and then we'll just bring it right back up in order for all of that to run. And while those things are loading, I'll go ahead and copy and paste a Redis database here as well. And this is just for reference. I'm actually not going to be implementing this, and it's actually very similar to our Postgres database. We'll come back to these ports for Postgres a little bit later, which we can also put in a moment. But I do need to add in this Redis data here as a persistent volume also. So there we go. So that's our Redis database now. And then I will also add in the ports themselves. So we'll go ahead and do ports. And we want to map the external port to the internal one. So I want these two to be the same. And again, I'll discuss those things in just a little bit. Okay, so we brought that down. We're going to bring it right back up. I will rebuild it. It shouldn't take very long to rebuild it. But there it goes to attempt to rebuild it there. And we've got a failed port already allocated. Okay, so in my case, I already have that port running on another one, probably from my tests. So I'll go ahead and just change this all across with, 5434 all across the board, just to make sure that is working correctly. And that's why we're doing this, is because we wanted to address that prior to moving on. Okay, so now that I've got this running, it looks like everything's working okay. And it's still applied a lot of these things here. So it's still actually created the database, which gives me a little bit of concern. That is actually not surprising anymore. Okay, that has to do with the fact that we came down here and said Postgres ready being, well, not ready ever. Okay, so I'm going to can get rid of this altogether. Okay, so we're going to save that. And one last time, we'll go ahead and test this, bring it down, and then bring it back up. But something that's interesting here is Redis is already working. That's in there. We can now use Redis with the various ports that are available. And then everything else was roughly working except for that database connection. So I'll go ahead and try it again. And that only had to do with my settings inside of Django. So what I'm trying to see here is if Django cannot connect to that database, which you should simulate. You should know what that looks like just by going into .env and changing the port settings or something like that around in there and just trying to make sure that it actually isn't working, right? That's kind of the goal here. But here we go. So now it's trying to do this, and here it is. It's saying that it failed authentication. So it's possible that it actually does not have access to it. Let's refresh in here, and there we go. So we now have a failed authentication for that user. So this user is actually not working. Going back into our settings, let's make sure that all of our settings are correct. Postgres DB, there we go. Our settings were not correct. So let's go ahead and grab this password here and bring that in. I'm really glad that actually showed up because it shows you the error you would see, both in terms of right here on the command line, but also when you try to use Django, this operational error. Now, you might be wondering, why are we spending so much time on Docker Compose and all this stuff? Because these are very real errors that you can see when you bring this into Kubernetes, and it's better to solve them locally using something simple like Docker Compose than something a little bit more complicated like what we need to do for Kubernetes. So bear with me on these Docker Compose things. We still have another one to just improve this a little bit. It's not going to be that much of an improvement, but it still will improve our workflow quite a bit. And so I'm going to go ahead and run this and we'll bring it back up. Brought it down. That went fast. Bringing it back up. We really just want a successful build here for all of the things. Okay. And so one of the things that we want to address in the next one is the question that might be on your mind is like, well, am I going to have to build it every time I make a change in my code like I literally just did? Well, that's what we want to address with the next part of this. Okay, so now after running this, after building it, what we see is, of course, it's applying all the migrations. That's okay. We actually wanted that to happen at least one time with our database. And it looks like everything did happen successfully. Good. And so now if I go to the admin, I can actually try to log in again with our credentials, our really, really bad local credentials. And I'm going to go ahead and log in again, and it appears to be working. So our last real test here is to run this all over again. I shouldn't have to build it this time. I could just do up, and I want to see if it creates or runs those migrations again. It shouldn't have to run those migrations again. So let's go ahead and run up. If it does run those migrations again, that means we failed and it's actually not connected to our database. It did run those migrations as we see here, no migrations to apply. And it also gave me this command error that username is already taken. That, of course, is because we came in to migrate and we're still running this. So if this wasn't here, that whole thing would have failed and nothing would have ever come up, right? Because it would have said the username failed. So boom, there we go. Again, this was a little bit longer in terms of Docker Compose. And of course, if you already know Docker Compose, this is going to be a lot of repetitive stuff to you. But the general idea here is now we have a way to actually run our web services and all that. Now, there's also a way to connect your static files to this. So what you can do is right underneath the command here, you can just put in volumes for your static files, and you can use a external static file. So you can actually use the static files folder for that as well. So that's something that is optional for you too. This means that basically you can use a static files folder inside of your web folder here to actually declare those static files. So that's completely up to you. It's not something you need to worry about really because of what we're going to do in part 2 of Docker Compose. In the last section, we created this Docker Compose file with our web application in it. In other words, our web application was living right next to our database. And something else that you may have noticed is that if you made changes to your web application, you had to rebuild that web application in order for Docker Compose to work correctly. In other words, I had to run Docker Compose up --build every time I made changes to my Python code. This is, of course, not ideal. Instead, what we want to do is really just have our Postgres database running all the time. In fact, I want it to just run in the background. That's actually what we're going to do now. I'm going to go ahead and comment out my web service. I do not want that running at all. I'm going to do all of those things a little bit differently, as you'll see. And I really just want my Postgres database to run in the background with the same configuration that I have here, right? So that's actually kind of important. The next thing is I always want this to restart. So what I can do is say restart to always. And I can do this on my Redis database too. Looks like I already have it. But restart always, what that's going to end up doing is if my entire machine restarts, the next time that the Docker desktop runs, this Postgres database and this Redis database will run also. Pretty cool. And so I might actually want to change the ports for all of these to something that's maybe specific to this project. So like 6388 for Redis, and just changing those things as well. I already changed these ports, but if you didn't change them, be sure to change them in all of the areas on this Docker Compose. And then of course, in my .env file, if I end up using Redis itself. Again, I'm not actually configuring that. I just want you to know about it because it is nice to have it when you need it. Okay, so now that I've got a new Docker Compose file, what's going to happen? Okay, so let's take a look here. First off, I need to make sure that I run Docker Compose and up. This time I can do -d. That puts it into detached mode. That means that it's running in the background. If I do Docker PS, this will show me all of the things that are running in the background. I happen to have two different, almost identical background services running because I tested both of them, right? So what we should see here is the actual images that we are wanting to use. That's our Django K8's Postgres database -1, Django K8's Redis database -1. These obviously correspond to, well, the folder that it's in, and then the service name, and then the count that they have. So in this case, the service name is PostgresDB, and there it is. And what we also see, let me just get rid of that. What we also see is a local port mapped here, right? So I have this right here. This is the actual local host port. That means that any, thing on my computer, any service, any Django project, any Python project, anything that has access to Postgres can access this port, and that is because it's on our local host. This is roughly speaking how it works in production as well. But anyways, so how that's happening is because of this right here. So if I actually cut that out, saved it, did Docker Compose down, this of course is going to bring down that service, then bring it back up in detached mode. Look how fast all of that is. Pretty cool. And then I do Docker PS. Now I actually do not have it mapped anywhere. Just like this service down here. It's actually not externally mapped at this point through my own testing. That doesn't matter to us. Redis is mapped in this case, but our Postgres database is not. Okay, so that is why expose is one thing that is cool in the sense that these services can talk to each other when we have expose there. But if we actually want our local system to have access to it, so we would do ports and we would do that same mapping however we see fit. So in this case, it's 5434 all across the board. Okay, so now our environment variable, what is the new host? It is no longer PostgresDB, right? That service name means nothing to our local Django project. We can use localhost most likely, and we should be able to also use 0.0.0 like it's mapped to right here. I'm going to go ahead and give it a shot with localhost. When I say give it a shot, what do I mean by that? Well, I mean going into web with my virtual environment activated like that, and then running python manage.py migrate. Hit enter, and what happens is I get localhost failed at this port. So, well, maybe we have a little issue here. Let's go back and look at Docker PS, and we see, oh, hey, what do you know? I actually don't have it running there still. So let's go ahead and do Docker Compose down again, and then Docker Compose up, bring it up. Now that it's up, oops, I made another mistake. Let's close it down with Control C, Docker Compose up -d, detached mode. We don't want this running. We don't need to see it. You totally can have it as it running like that, but with my development projects, especially ones that I'm focusing a lot of time on right now, I like having it in detached mode. So now let's go ahead and run that migrate again. And what do you know? It's now working. If I do python manage.py run server, I should be able to see that server. But what's more is I should be able to actually check from my settings, my Django settings, I should be able to check that this value here. So let's take a look at that. So first off, we need to do source. We need to activate our virtual environment. So I'm just using a quick command to do so. And then I'm going to go ahead and jump into the python manage.py shell. And from here, I'm going to go ahead and run from django.conf. We're going to import settings, and I'm going to print out settings.db is avail. And what do you know? It says true, right? So now it's actually available to me because, well, that's because of these environment variables here. But I'm not getting any errors while using this, right? Down here, it's definitely using that database. And of course, there's a number of different ways on how we could go about testing that, including taking that database down. So if we exit out of here, and then do Docker compose down. Remember, whenever you need to take something down, if it's in the background or if it's just running, you can take it down right there. So when I do that and I go into my local project, which I think I put at, looks like it's at localhost 8000, and we go into the admin, now it cannot connect, right? So it actually cannot get into that project. So let's bring Docker Compose up again in detach mode again, and we can refresh in here. What do you know? It's now connected. Now I have my Django admin static files working for a number of reasons. One of them, which is it might be cached. So if you don't see your Django static files here, it's not something to worry about. It could still look ugly like it did a little bit ago when I actually had Django inside of Docker Compose. So now that it's like this, I can actually make changes on the fly and still be connected to that Postgres database. But it's also highlighting what our actual Django project is going to be like when we actually put it into Kubernetes. And that is the Postgres database itself is going to be a managed service that's outside of really our control. It's not something that we're going to have in Kubernetes. It can be done. It's just not something we're going to do at this point. So this is really the approach I work with a lot, especially when I need different kinds of databases to be running and I don't want to provision them, or maybe I don't want to actually have to have multiple different ports or multiple different users. I can just make these things on the fly with environment variables, Docker Compose, and all that. So yeah, I think it's really, really important to test these things out locally using Docker Compose, hopefully. And in this case, I no longer need those volumes either. Actually, I'll keep that commented out as well. So that's our new Docker Compose file. Granted, you could also have another Docker Compose file in here and run based off of that. I'm not going to do that because it's not something I have any interest in doing. The last section of this was really meant for those of you who have never done anything like this before. It's to some degree. But anyways, so now we've got our final Docker Compose file. It's time to actually start moving towards using Kubernetes. In a moment, we're going to go ahead and provision our Kubernetes cluster on DigitalOcean. But before we do that, I want to mention that some of you are probably jumping to this section right here because you don't want to do the other parts or for whatever reason. So be sure to clone the GitHub repo here and follow along to the cloning this repo steps. I'll update that over time, but the general idea is you want to make sure that you clone the repo correctly and have all the things necessary that GitHub doesn't necessarily have. And you'll probably also want to jump into branch 14-start because that's where we are. Okay, with that out of the way, let's go ahead and make sure that we are already signed up for DigitalOcean. If you're not, go to this link right here. You'll get a $100 credit to really learn how to use Kubernetes, which is really nice. After you do that, make sure that you log in to DigitalOcean into the Kubernetes section on DigitalOcean, just right there. And we're going to go ahead and create our first Kubernetes cluster. The version of Kubernetes that we use doesn't actually matter that much. Just go off of the recommended version. That's what I pretty much will always recommend to you as well, mainly because what we're doing here is configured, doesn't change that much version to version. At least that's been true for the last few years. Next, we're going to go ahead and choose a data center region. This is going to be the region that's closest to you as you're learning or closest to your users as you deploy it. Okay, that's just for latency, so it goes a lot faster. I'm closest to New York, so that's what I'm going to do. Next is a VPC network. Now, you can absolutely create your own VPC network inside of DigitalOcean under the networking tab. I'll just briefly mention that VPC networks are great for communicating across services on DigitalOcean. It stands for Virtual Private Cloud. So that means that our Kubernetes cluster, for example, can communicate to the database that will end up provisioning. All of this will be done through the data center itself. It won't actually go out through the internet, which is really, really nice. And a key advantage to using a VPC network is that it's just all through a private IP address, which is great, not a public IP address. So that's pretty cool. I really, really like using VPC networks. Next is our cluster capacity. So what I'm going to be doing here is I'm going to select a pool name. You can have multiple pools and you can have multiple pool names, but a node pool is really just a collection of nodes that you can target directly in Kubernetes. we're not going to go into that much depth on this one because we are just going to be using one node pool. So I'm going to go ahead and just call this my Django-K8s pool with whatever after that. In fact, I'll just leave it as just for my Django K8s pool. Okay. And then I've got basic nodes. You can actually make the nodes more advanced, as in you can vertically scale these nodes. You can make them really, really expensive, as you see, $155 a month, or even almost $2,400 a month, almost $2,500 a month. And 3 of them, you're talking a good amount of money. Now, this is vertical scaling. We don't need to do that. We can use basic nodes and horizontally scale. So I typically start with $20 a month. Now, $20 a month with, let's say, I don't know, 7 nodes, that's a lot of capacity already. We can just start with 3. You have to have a minimum of 2. Okay. Realistically, I mean, you could actually use it with 1, but it says recommended a minimum of 2. I think a minimum of 3 is actually preferred, even if it's 3 at $10 a month. Right. And I'll get into the reason in just a moment, but we'll go ahead and do $20 a month and just leave it as that. And again, if you signed up for that free credit, you get $100. So this will last you about a month and a half. Or if you actually delete your Kubernetes cluster at any time, you totally can and you totally should. What we're doing, especially one of the things that Kubernetes does really well, is we're going to write a bunch of configuration that really is just a matter of typing out a few commands and then all of our services can be back up. The only thing that really needs to remain persistent if you want it to is the database. So actually what's in the database and all of that, if you want that to remain, then you'll have that running consistently, where the Kubernetes cluster, you can spin it up and take it down every time you go to learn, which is really, really nice. And then you're just charged per hour, which in this case, it's 8 cents an hour. It's not too bad. Next, we're going to go ahead and give it a name. And again, I'll just call this Django-K8s. Obviously, they have a bunch of defaults for this just because it needs to be unique across all of your systems and stuff like that. The project doesn't matter as much. You can create a new project if you like, and you can also add tags if you like, such as like Django, K8s or something like that, or whatever tags you want to call it. I'm going to go ahead and create this cluster now. So the cool thing is, once it creates, what it's doing actually is, if we go into the droplets section, it's actually going to be creating droplets in here. So right now, it's not quite there yet, but it will be in a moment, right? So it does take a moment for this to actually spin up and to get everything working. You don't have to worry about the high availability control plane just yet. That's something that's a little bit more advanced for, like, you know, real production use cases and stuff like that. But anyway, we'll get rid of that. So it's going to provision this cluster, which really means just making all of the droplets for us on our behalf, right? So we can refresh in these droplets in a little bit. But I want to mention that what we're doing with a cluster, it's going to be multiple droplets. This is much like saying having multiple virtual machines working. In fact, it's the same thing as saying that, but it's also much like saying having 3 different computers at your local, you know, house or business that are all running too. So like 3 Raspberry Pis working together in tandem with Kubernetes is essentially what's happening here. So you can sort of think of it in those terms if you'd like. I tended to think of it that way early on to understand better, generally speaking, how these quote unquote nodes end up working. So we'll let this continue to provision. While it does that, I'm going to go into actions here on my cluster and download the configuration file. This configuration file we will actually implement in the next section, but for now we can just look at it, and there we go. There is our configuration file. It's really not that complicated of data, and I actually had another one right here too, right, just showing up because I've tested this a few times. But the general idea, that configuration file will allow kubectl to actually use that particular nodes or those nodes, or that Kubernetes cluster, the entire Kubernetes cluster that we might want to use, right? That's what that configuration file does. So we want to make sure that it is stored in a safe place, right? So in my case, I have 2 in the downloads. I'm actually going to delete both of them so I don't get confused at all, and I'll just download it again. So again, in the next section, we'll actually start to configure it and use it. But it is important to know that if somebody has access to this configuration file, they have access to your entire Kubernetes cluster. And of course, when in doubt, if you need to, if you're like, oh, I don't know about this cluster anymore. I don't know if I use it anymore. Just go ahead and destroy it. Just get used to being okay with destroying clusters and virtual machines. It's totally okay. In this case, it's nothing like a physical device. It's nothing like your Raspberry Pi at home or your computer at home. You're not taking a hammer to something. You're just deleting a resource that can be brought up back online. No problem. I've had that question asked a number of times. So for those of you who are like, why are you talking about this? I know this. Well, that's because I get it every once in a while. In any case, so now with this Kubernetes cluster being developed, what we should see hopefully at this point is actual droplets. If it's not here yet, I'm going to pause it and come back once it is. Okay, so now we have progress on our droplets themselves. As we can see, the thing I want to highlight here is the fact that it's 3 different droplets. This should also illustrate the fact that you don't necessarily have to use the managed Kubernetes version. You can actually manage Kubernetes yourself across droplets. I just think it's a lot easier to just go off of DigitalOcean's managed service to do it. It's also, well, not really expensive to do that. It's actually a pretty easy free thing that just charges you for the droplets themselves. And we can actually verify this by going in to create a new droplet, a 4 gig droplet at 80 gigs hard drive. So let's go ahead into droplets and go to basic. So we have a basic one. And what we have is looking for the 2 gig. I think it was like, well, maybe it's not actually written here. Oh, regular. There it is. So it was $20 a month per node. There it is right there. It's literally that. It's the exact same thing. And of course, you can use all of the other actual droplets themselves as a node. But all this is doing is showing you that you can actually provision droplets on your own, and you can provision Kubernetes on your own. It's just a lot easier to do it through DigitalOcean because you can also manage it. You can manage Kubernetes in here. In other words, you can actually go into one of your Kubernetes clusters and you can update your resources that you have available. Like you can actually add additional nodes to this. So resize or auto scale. Notice I can just bring this thing way up, right? Or I can add auto scaling in here too. So you can have a minimum number of nodes or a maximum number, which the cool thing about this is has to do with everything that's going on inside of your cluster. So if you have a lot of traffic going on and all your resources are just maxed out, you can add in a maximum of nodes of 7. That, of course, means it's going to hit $140 a month. But more than likely, if you're hitting that much resource demand, you probably have a robust service that's more than capable of actually paying for that service itself. Okay, so that's actually one of the coolest things about Kubernetes as well. Now, doing this on your own and managing this service without Kubernetes, it's possible, but it's a lot harder to do, and it takes a lot more work and effort on people's parts, right? It's not all automatic and stuff like that, which is also another huge advantage to using Kubernetes itself, which I think is pretty cool. So we can also see the insights, all the things that are going on with our different pools in here or our different individual resources or the entire cluster itself, which is also pretty interesting too. And of course, there's a number of other resources that you might end up looking up and trying to figure out. But the main thing here now is actually using this. So we actually need to connect to Kubernetes. Now, they have a guide here on how you can connect it. This is okay. This is fine. We actually don't have the DigitalOcean command line tool installed just yet. We will have it in. But what we're going to do instead is we're going to just go off of that downloaded configuration that I've downloaded a couple times now. I actually only need one of them, but we're going to go off of that configuration and actually do that in the next part to actually make sure that we can run in with our Kubernetes cluster. So of course, if you have questions on this, let me know. But the thing here is we just wanted to provision it and talk about it a little bit. But the general idea is Kubernetes is vast. There's a lot of things that go to it. So I recommend not trying to learn everything, but rather learn enough so you can actually get your project into production. That's the point of this series, of course. But then after you learn enough, then you're going to start to pile on what you need to know and all that. The key things to remember for Kubernetes, in my opinion, number one is it's a cluster of virtual machines, a cluster of droplets in this case. That cluster can expand or contract on how you see fit. You can add in a policy to do that, which is fantastic. You can also provision additional resources for that cluster for both vertical and horizontal scaling to just make your cluster that much more robust. And what it's going to do is it's going to manage all of your services. Those services are typically through Docker containers. So you have all of these different containers. Kubernetes just makes them all run as they need. And as respect to Kubernetes inside of DigitalOcean, we have all of it in a VPC, a virtual private cloud, so that our Kubernetes cluster can communicate to our database that we have yet to provision or any other services in our virtual private cloud or in our VPC when we need to in a secure manner without it being exposed to the public, which is really, really nice. So the Kubernetes clusters itself, now we have to learn how to connect to it for one, but then also how to start provisioning resources on this cluster so that it can actually run. Those are the key things that we'll do in the next few sections. Let's get to it. Now we're going to go ahead and connect to Kubernetes using our local kubectl and our kubeconfig file. Now that Kubernetes config file is inside of your cluster under actions and download config. And so once you download it, you'll have it in your downloads, something like this. So I actually want to show you a couple ways on how you can actually use this kubeconfig file. So the first way is just right where it's located. Now, of course, I'm going to assume that you already have kubectl installed like that. If you don't have it installed, if you're on Mac, go ahead and use Homebrew. If you're on Windows, use Chocolatey. I have a whole installation process for that earlier in this series. But what I want to do is actually use that kubeconfig file. So I'm going to go ahead and export kubeconfig equaling to ~downloads/Django k8-kubeconfig.yaml. That's literally the name right there. And I'll go ahead and hit enter. So this actually creates an environment variable on my local machine. If you're on Windows, it's going to be slightly different than that. I'll just go ahead and paste the reference here for you. That's it right there on Windows. It's roughly the same, but still just a little bit different. And so once we have that, we should be able to echo this thing out of kubeconfig, and I can see that actual path. Again, Windows users, you're going to do something more like this, where I think it's env and kubeconfig. I believe that's how you would echo that out on Windows. But in any case, we are going to go ahead and now use that path. That's really the key thing here is now I have an environment variable of kubeconfig to that path, to that file. So now when I use kubectl in this terminal and say get nodes, what will I end up seeing? I'll actually see the nodes that I just provisioned on DigitalOcean. Those are literally the ones. As we see here, we have the pool name and each node identification at the end of it, which is great. That's a simple and easy way to do that. But of course, we don't want to keep our config file inside of, the downloads folder. That's not ideal. Instead, what I want to do is I want to make a folder inside of my Django project here, right? And so I'm going to make a folder inside of here for the actual entire project, that is not just for Django, but next to venv, I'm going to make .cube. Now, .cube is a common way for kubectl, or the Kubernetes command line tool. That is a common folder here. Inside of this folder, I'm going to go ahead and bring in my kubeconfig file here. I'll bring in a copy, and I'm actually going to rename it to just simply kubeconfig. So let's go ahead and rename this here. And there we go. Okay. So now I have a new location for it. Now, granted, I could do the exact same thing where it's, very similar to this. Here, I'll just go ahead and put the two different ways, right? Very similar to this. I could do it relative to my project here, or what I could do, of course, using VS Code, is go into the code workspace. And what I'm going to do is I'm going to actually bring this in here into my settings like this. Oops, not the whole thing. Settings like that. Okay, so let me close this down a little bit. And so this gives me an environment variable option specifically for this workspace, right? So whenever I open up this project, this workspace will now reference that kubeconfig file. And so that when I do open a new terminal window, let me close this one out and open a new one. What I can do is I can actually echo that kubeconfig config file, and it'll actually show the location for it. Now, the reason I have it set up this way is notice that it has nothing to do with the fact that it's in Django-K8s, but rather that it's local to this particular project. Now, of course, if I am going to go this method inside of my git ignore here, I want to make sure that I do not check this in at all. So I do .cube there, and that is yet another way to have Kubernetes working on your machine, right? Specifically for this project and inside of VS Code. Now this works cross-platform as you see here. So I have all of the configuration on here. Of course, if you need this reference, just go to the GitHub repo and you'll have the exact reference itself, or of course you can type out these paths. This workplace folder here, or workspace folder, excuse me, that actually can reference this folder here, the root of this folder where, code-workspace is. In other words, it's usually this path right here. So it replaces it for you, and you don't have to do anything. There's a lot of cool things that you can do with VS Code that are associated to this. But unfortunately, what we actually don't want to have happen is, well, maybe you forget to do this, or maybe you're like, I don't want to work in VS Code. I want to work in here. So I do kubectl get nodes here. I've got nothing, right? And so what we do here now, and this is true across all systems, is we want to make a directory in our user's root folder called kube. In my case, it already exists. So I can actually navigate into .cube, and I can see that there's, well, a cache folder here, but there's really nothing in here that of note. So what I'm going to do is open up this folder. Actually, I'm not going to do code. I'm going to just go ahead and say open period. And of course, if you're on Windows, it's II period. And then I'm going to open this folder up, and Windows, Mac, Linux, all of you have roughly the same setup at this point. You might not have cache in there, and you might have just created that .cube file, but now I can actually bring this on over here. Now, there's a number of ways on how I can actually declare this file. I can actually use a bunch of different commands to select this file too, but I'm not going to do that. Instead, I'm just going to call this the default, and that is just simply no .yaml, just simply config, and just call it that. Now, inside of my terminal, I want to make sure that it is called just config, not config.yaml, and we'll use that as move just like that. And so I listed out, there it is, just simply config. Okay, so this now gives the entire system, it's a global system, is now called config. Of course, if you already had config in there, you could ignore this because you probably have already seen this to some degree. And so now we have a new configuration. So if I scroll up to the kubectl get nodes, I now globally can access this. Now, I don't want global access to this. I'm going to change it back from config to, let's say, to Django K8s, kube config.yaml. So now it's back. And again, if I do get nodes, it's going to be like it doesn't know. Can't find it anywhere. So there is another setting for this specifically, but I'm going to leave it just like this. I just really wanted to have my Django K8s configuration on my actual local terminal. And this is true if I shared this with you on your project. Just make sure that you add in that kubeconfig there on your project, and boom, it's going to work exactly with your cluster based off of this setup. I personally think this is a really robust way to do it locally. When you go into production, like if you have a remote server or you're using GitHub Actions, which is something that we'll probably have to look at, you're going to use the root config file probably, or the root.cube folder itself. So if you have any questions on this, let me know. But now we have the ability to do all sorts of fun things with this because we can do git nodes, which is nice. If I try to do git pods, I probably see, hey, there are no resources found in this namespace. That's what we actually want to change going forward. Now we're going to go ahead and deploy your first container on Kubernetes. We're going to go ahead and deploy Nginx to Kubernetes, and then we're going to destroy this same container. That's all we're going to do. It does take a little configuration to get there, which probably is not surprising, but it is important to get to the point where we know how to make a deployment of any kind of container. That's all we're doing, just a single deployment. Okay, so let's go ahead and jump in to our project here. I'm going to actually create a folder for all of my Kubernetes related items. So the first thing I'll do is create a folder called K8s. Inside of here, I'm going to make an Nginx folder. And then inside of there, I'm going to make deployment.yaml or deployment.yaml. So what's going to happen is the command that I'll use is kubectl-f apply k8s/nginx/deployment.yaml. Okay, so this is the command I want to run. Now, where this is located actually does not matter at all. It also doesn't matter if we accidentally delete this, which I'll show you why a little bit later, as in accidentally delete the YAML file, assuming this deployment is in production. So what I need to do is the very first step, which is declaring a deployment. So I'll go ahead and declare API version, and there's going to be apps/v1. We'll take a look at this a little bit more in detail as to where you can find these things out. But when we need to deploy a container, when we need our container to run on our Kubernetes cluster, this is what we'll do. Next, we're going to say the kind it is. In this case, it's a deployment. Next, we're going to go ahead and add in some metadata, and we're going to give this a name. The name is going to be nginx-deployment. I am giving it that name. It is my arbitrary name right here, but it's a name that I want to remember, which we'll see in the next few lessons. Next up, we're going to go ahead and declare the specification or the spec here. And so what we need to do is first off create a selector of some kind. Now this I'm going to go ahead and say match labels, and this is going to be the app of Nginx deployment. I'm going to give it the exact same name as the deployment metadata. Next, we're going to go ahead and do template, and we'll go ahead and add in some metadata for this as well. These are required. We'll do labels and app, again, Nginx deployment. Okay, so this is just stuff that you'll have to do on a regular basis for a deployment, which we'll show you the documentation for in a moment so you can see that. Okay, next up, under the template, we're going to go ahead and do spec and then containers. Okay, so in here, I can have multiple different containers. The container I am going to use, I'm going to name it as just simply Nginx. The image is going to be Nginx latest. And then we'll also go ahead and declare our ports. And I want to do a container port being 80. Okay. So all of this configuration is referenced in the Kubernetes documentation. Or it's just something that you'll use so often that you'll just know what the configuration is, or you'll just reference it from something else. Now, this image right here is pretty critical for this. So if you don't understand this part, I'll explain that in the next one as well as to how this works, but it is coming directly from Docker Hub. Okay, so I'll save that. When I say how it works, I mean literally how we would run this deployment locally. So now that we've got this, we have the file all ready to go. I'm going to go ahead and hit enter. And I actually have it written incorrectly. It should be kubectl apply-f k8s/nginx/deployment.yaml and hit enter. So what this did is it deployed based off of this file. And we can check this deployment by doing kubectl get deployments. Literally, this is a kind of deployment, so I can get those deployments. Just like I have my nodes on, the actual DigitalOcean Kubernetes cluster, I can do get nodes, same sort of thing. Now notice that it gives me a deployment here. There's actually a deployment, which is pretty cool. So that deployment is in effect. So what I can also do is I can do get deployment and grab that specific deployment just like that. And there we go. So that actually is showing me that deployment more in depth, because realistically what's going to end up happening as you grow with Kubernetes is you'll have a lot of deployments, not just this single one. But the big question is, how do I actually access this deployment from the outside world? I don't actually know how to access it. So of course, what I mean by access is I mean directly going into the container itself or having end users being able to access this container. So I'm going to actually expose this to the outside world in the next part, but to actually access the container itself takes a little bit of a different step. And this introduces the concept of pods. So if we do kubectl get pods, this will show me the running instances of this deployment. In other words, I can actually go ahead and grab one of these pods and delete it. So I can do delete pod and then that. Oops, kubectl delete pod and then that. And that actually literally deletes that running service, and it will actually provision a new one for me, as we'll see in just a moment once it finishes. So it's doing all of that at the same time. Now, let's not get bogged down by all those commands. You're not going to remember all of them right now. Just bear with me as I explain them. But notice that our pod has changed. The actual name of it has changed. Now, this is the actual deployment itself. Notice that there is only one of them. If I wanted to have more than one, if I wanted to have more deployments of the Nginx deployment, then what I would do is come back into my spec here, and I want to add in replicas and add in, let's say, however many deployments I want. As of now, the default is 1. I'm going to go ahead and add in 3. So I'm going to go ahead and now I made some changes to this deployment. I can do kubectl apply -f, again, k8/nginx/deployment.yaml and hit enter. This, of course, changes the amount of pods I have. Now, these pods are distributed across my nodes, across those virtual machines, and they're all running in as efficiently as they possibly can. What if I put 30 pods here? What would happen? Again, I just apply that change, and then I look and I see get pods. It is now literally trying to create 30 instances of this container to make it run, which is incredible. That is so cool. I could also just keep it back at 3, apply it again, and again, it's going to configure in that way. Now, of course, it's not going to happen instantaneously. It does have to terminate pods that it already created, but it will keep the ones running that are already running, or at least it'll keep 3 of them. And then over time, those will come down to just being the number that we want. Now, there's a lot of things, of course, that we could talk about this, but I did mention how can we get into one of these pods. And so we actually can just grab one and then do kubectl exe execute -it. Then we do 2 dashes and then the command that we want to execute, which is bin-bash. Now, before all of that, this spot right here, this is going to be the pod name right there. So we actually want to put the pod name in there. So that way we can actually do kubectl exe-it pod name bin/bash. And this will actually allow me to actually go into the container itself, the running container. Now, those of you who know Docker well will be like, hey, that actually looks a lot like the Docker command to go into the bash container, which is exactly what it is. Now, of course, there's a lot of things that we can do here, and we actually will end up doing a number of these things when we actually deploy our own containers, that is our Django web application. But the key thing here is to see that we can actually run a deployment really simply. So these containers are running, but we can't access them from the outside world, right? I don't have an IP address anywhere for me to see. We will cover that in the next portion for sure. But for now, what I want to do is just take down this deployment. And again, it's incredibly easy. It's just kubectl delete -f and then the file we want to delete. The file, of course, gives all of the description of that deployment, and kubectl is smart enough to know exactly what deployment it is and where to delete it. So I'll go ahead and do k8/nginx/deployment.yaml, hit enter, it's gone. And now if I do kubectl get pods, I have these pods are being destroyed. If I do get deployment or get deployments, I have no deployments any longer. So again, those pods still take a little bit of time before they go away. Now, of course, there is this thing of default namespace. That's something that we will touch on briefly. But again, Kubernetes is huge. Deployments are, I think, the fundamental aspect of them. It's like you have deployments and then you build things around these deployments. So we need to see one of those things in the next one called a service. Let's go ahead and take a look. All right, so now that we have this deployment configuration, it's time to actually expose it to the outside world. So the first thing that I want to do since we have this is just to ensure that this deployment is going, because I actually did take it down. So let's go ahead and do apply -f k8s nginx deployment.yaml. Okay, so just want to make sure that's running. So we'll do kubectl get pods and just make sure, hey, what do you know? It's up really, really fast. Cool. So now that we've got that, let's go ahead and create a new file in here and we'll call it service.yaml. And so inside of this, we're going to go ahead and declare our API version. And this time it's again v1. This time it's not apps/v1, but just simply v1. And so we're going to go ahead and declare the kind of service it is, or that it is a service rather. And then we'll also declare the metadata for the name, and it's going to be nginx-service. And then we'll declare the specification, just like we did with the deployment, which is spec. And, just like what we saw here. Next up, we're actually going to give what the type of service this is. This is going to be a load balancer. Now, some of you might know Nginx really well, like the actual service of Nginx and the tool that Nginx is. And you know that Nginx can be used as a load balancer. There's a way to configure it to be used as a load balancer. That's not what this is. This is actually going to be a DigitalOcean load balancer to distribute our traffic across our various replicas inside of our deployment, right? So directly for all of the containers that are running. Not exactly how Nginx works, but it is very close because it's distributing traffic into the term of a load balancer. That's what a load balancer does. So it is different than Nginx. I just wanted to mention that for those of you who know what Nginx is and what it does well. Next, we want to declare the actual ports that we're going to expose to the outside world. So we give it a name of some kind. I'm just going to say HTTP because that's typically what you'll start with is HTTP. You'll declare a protocol here, and we just want a TCP connection, typical protocol. And then we'll go ahead and declare the port that we're going to use. Port 80 is the standard port that you open up to the outside world, so you don't have to declare the port, which I'll explain more in a moment. Next up, we're going to do our target port. Now, what is this exactly? I'm going to go ahead and say 8,000 for the moment, and we'll just leave it as is. Next up, we're going to go ahead and do selector, and we're going to say app, and this is going to now declare our Nginx deployment, right? So part of the reason that deployment.yaml has Nginx deployment 3 times is just to simplify this right here. Now, there are other uses for these different labels, and there are sometimes cases when you want to make them different, but I, typically speaking, especially as you're learning, I just make these all the same, regardless of what the container is down here. Okay, that's just to address that. Next is this target port right here. So this port is made for, like the actual domain that you'll end up having, which is definitely not this, but let's just say that domain. And the connection again is HTTP // The default port here is going to be 80. So whenever you go to something like this, that default port will be 80 versus 1234, which is what you would maybe put here, right? And so we'll leave it in as 80, so we don't have to really think about adding a port towards the end of it. Now, in some cases, you will want that. Some services, you'll definitely want that. Now, with this target port, what is this going to be? Now, this actually is correlated directly to our deployment, to the selector app that we're using. That deployment is whatever this is, the container port. That's the port that we're letting Kubernetes know what this is running on. So the service itself is not going to verify that. We have to make sure that we know that. And so we're going to leave the target port at 80, just like our deployment has. And so now that we've got a deployment and a service, it's time to actually spin the service up. Again, let's just verify we have pods running. Those deployments are there. We can also do get deployment just to verify that deployment is up and ready. So now we're going to go ahead and do kubectl apply -f k8s nginx and service.yaml. We'll go ahead and hit enter. It has been created. So much like we have this get deployment method here, I can also do kubectl get services or just get service, and that will actually show me all the various services. Notice that this says external IP that is pending, and it also gives me those ports. Look at port 80 is there. Pretty nice, and it's 11 seconds old. So where's this load balancer being created? Well, if we go back into our DigitalOcean console and we go into networking, or well, we could also go into our Kubernetes cluster. That actually might be a good idea. Let's go into our Kubernetes cluster to see what's actually happening in here so that we can verify that this service is part of our Kubernetes cluster. So we go in here and then we click on resources. So what we'll see here is a load balancer now. So it actually has a load balancer showing up. That load balancer is directly correlated to this service.yaml file. Now, if I click on this load balancer, what it's going to do is actually take me to where the DigitalOcean load balancers exist, right? So this is actually a thing that I can implement outside of Kubernetes, right? So that's exactly what's happening here. Kubernetes is provisioning a load balancer for us inside of DigitalOcean, which is pretty cool. So, right now it's still being created, but of course, if we wanted to look at this load balancer again, or any of our load balancers, we could just go into networking and then click on load balancers, and then we would see the ones that are actually being generated, as well as the IP addresses here. So the nice thing about this in the terms of the DigitalOcean console is I can actually map a domain to that load balancer, right? To whatever the IP address ends up being. This does take a little bit of time for it to provision, so give it a moment. And if for some reason it feels like it's going slow, you could always just try and run apply again, and that might actually speed it up. Actually, probably won't do anything, but it is something that I do when I'm getting a little impatient. Is just, hey, apply this, apply this, apply this. So while it's still loading, I did want to mention, how do we actually recover if I accidentally deleted the deployment and YAML files on my local machine? Now, on one hand, hopefully you're using version control as I am, that will actually bring that back. On another hand, there's a way to export or kind of view what's actually happening in any given deployment, pod, service, any of that stuff. We can do kubectl, and I'll go ahead and say get service, right? So this gives me all the different services here. I can actually grab the service I want. So get service, that service name. Now it just hones in on that. And then we can use -o as an output. And then I can say the kind of format I want it to output in. So I can say JSON and I can say YAML. So if I do that, hey, what do you know? This is now, well, it's a lot more data than I necessarily need for the bare minimum file, but it does give me all of the stuff that I had created for this particular, service itself, right? And so what you could do then, if you are interested in making some changes to something like this, you would just put it into a new YAML file, right? So this is me sort of emulating recovering, and you can start deleting things that you just don't recognize, or you could just delete things willy-nilly. And what is going to happen, let's say, for instance, I deleted this entire thing right here, and maybe let's go ahead and delete all of this. And there we go. So I leave it just like that, right? So I deleted a bunch of stuff. And now what I'm going to do is save it as backup.yaml. We will probably not even keep this in a moment, but now I'm going to go ahead and do kubectl apply -f, and then in K8s, Nginx, and backup.yaml, hit enter. And what it will do is it gives me potential errors that might actually occur in here. And that's kind of the reason, that's kind of one of the things that you want to see when you are coming back, right? So you're going to go one by one on getting this thing back to where it was. And, this is just a trial and error situation if you need to recover. The chances are really good that you hopefully will not need to recover. Notice that metadata is empty in here, right? I want to make sure I'm using this at least. Okay, and I noticed this because the resource name was empty, as we see here. So I go ahead and run it again, and there it goes. It's actually configured something. It did seem to make a change, but I don't think it actually made any changes. So if I run that again, it says it's unchanged, but it's really just this file specifically is unchanged. So we'll just go ahead and do kubectl and get services, and we now see an external IP in here. So the recovering from a service that fell down is probably not something you'll do very often, but something you might do fairly often is actually look at what's in that service. Just really quickly, a quick glance at what's going on in any given service. That might be something that you end up doing. So that's also pretty cool. But now that we've got this exposed to the outside world, we can actually verify by going to that external IP address. We hit enter here, and what do you know? Welcome to Nginx. This is showing us that the Nginx container is running. It's also showing us that that service is running. Okay, cool. So the next thing is I'm actually going to go ahead and delete this backup here. Something that you'll see fairly often is these things being all combined. So I'm going to go ahead and do combo.yaml. You'll often see the deployment in here, and then 3 dashes. Those are to signify another configuration. And then you'll have the actual service in there as well. And then we'll go ahead and run the apply. And this is now going to be combo. And so that just handles both of those things, right? So the Nginx service looks like it changed a little bit only because I, went back to service.yaml, but if I run this again, it's actually not going to change at all. And so you'll actually see this combo a lot, especially in documentation where it's actually bringing 2 things in. Just be aware of how to spot this is these dashes here will separate them. More than likely, the API version and the kind will be different from thing to thing. So you can actually have a lot of different deployments all written out in here as well. The only reason I have it separated is to show you, well, make it really nice and simple as to what's going on in each one so you can use it as reference in the future. More than likely, when we come to Django, we'll bring this combo back in because that way it's all mapped into one single thing. Now I'm going to leave you with the challenge of bringing this service down and bringing the deployment down. Both things should be incredibly easy at this time. Now we're going to deploy a minimal FastAPI application that I have on GitHub as IAC Python, but I also have a public container for this as well at this location. The fact that it's a public container is important, and the fact that the container is already built is important. Other than that, it's pretty much the same configuration, as we'll see in just a moment. So what I'm going to do here is inside of K8, so I'm going to make a new folder and I'm going to call it apps. Inside of there, I'll go ahead and do iac-python.yaml. And what I want to do is declare basically the same thing. So I'm going to bring in, first off, the deployment. I'll do those 3 dashes, and then I'll grab a service in there as well and bring that in too. Okay, so the deployment itself is going to be my IAC Python deployment. So I'll just replace some of the Nginx stuff with simply IAC Python. The image itself is different. This is the coding for entrepreneurs image of IAC Python. So this right here is coming directly from this right here up in the URL, or more specifically in the Docker pull command, whatever that is, that's what you're going to want to do. And then whatever tags that may exist there. This one only has 1 tag at this point. So that is it. That's pretty much the difference in the deployments from the Nginx container and my custom IAC Python container. Granted, you didn't see me put this together, but it is there and it exists. Now, one of the things that is an attribute of this IAC Python is actually very similar to what we have inside of our Docker container and file, is this entry point.sh along with the app port configuration. I do this a lot for my Docker images, as you see. So the environment variable of port is something that I can actually configure. So I can actually do it right here. So env, and then we'll do name, the actual environment variable name. In this case, it's going to be port, and then the value I want to set. This value must be a string. So I'm going to do 8181, for example. Then the actual ports that we want to expose to our other services, as in our actual service here, the Nginx load balancer service, or really the IAC Python load balancer service, I want this to be exposed or mapped to that. And you also might recall down here, this target port needs to map to the same target port. Cool. And of course, I need to change this to IAC Python for the deployment. And now we have everything configured as we need it to for both the deployment and the actual production service. What's cool here is I have these environment variables. Now, this variable itself, it's okay if that one gets exposed. That's not really that big of a deal in terms of what port it's using on. Of course, that is definitely something we need to figure out, though, when we actually bring our Django project into production, because we don't want all of our environment variables in this YAML file at all. We want a more secure way than just that. But every once in a while, you'll see environment variables that make sense. And this one absolutely makes sense for this particular project. So let's go ahead and create it. Okay. So I'll do kubectl apply-f k8/apps and iac-python.yaml. Hit enter, and of course, it's going to go ahead and configure that for us, as you see there. So we can do k.get pods. This will show those pods being created if they're not already created. I did some testing, so they actually created really fast. So in other words, the image, this container image right here, was already on my Kubernetes cluster, so it actually went really, really quickly. In your case, it might take a little bit longer than that, but probably not by much. And then we can also see the deployments here. That, of course, is what's going on there. And then finally, the services. Now, the service itself is going to take a bit of time. While that's running, I'm actually going to go ahead and take a look at one of these pods. So we can actually do, again, kubectl execute-it, the pod name, and then 2 dashes, the command we want to run, which in this case is just bin/bash. So we can actually go into this application. Now, this application itself is actually not a whole lot different as far as the configuration is concerned than the Django project. We can actually verify this as well by looking at that Dockerfile. If we look in here, it has a couple of other things that you might actually end up using. But what we see here is it's actually creating a virtual environment in the same location, and then it installs the requirements in that same location as well. At least that's how it currently looks, right? It's using a different version of Python. This is possible that it could change over time, but the general idea is that we have something in here that we can reference without doing all the Django configuration. So I can actually, activate that virtual environment with source OTP venv activate, source OTP venv bin, and then activate. And that, oops, this should be source/OTP/venv bin activate. There we go. And so now if I do Python or pip freeze, I should see all of the requirements specifically for this project, which are a number of them. In this case, it's FastAPI and whatever version it is, and a few other things going in there, as well as gunicorn. The gunicorn part is the important part because of how similar the Dockerfile and the entry point are from Django and FastAPI. It's identical, essentially. FastAPI just has one extra type of thing that has to do with the uviacorn worker, but Django doesn't need that. Otherwise, it's almost identical, which is actually really cool and also shows us maybe a light at the end of the tunnel as far as, hey, we're not actually that far away from getting Django to work in Kubernetes. It's true, we're not that far away from it. We need to solve a couple things first. The first thing that we solve is making a private image, actually having a private container repository, not the public one on Docker Hub. We're going to use DigitalOcean for that. Then we need to get our environment variables correct. And then the final thing would be wrapping in our database with everything. We might need our database before some stuff, but that's the general idea as to where we're going to work from here. And hopefully at this point, the load balancer was almost done. I'm going to let it pause and then we'll come back and just see this thing actually finally working. All right, so my load balancer finished, as we see here. I can actually check out this IP address now and take a look, and yes, it's absolutely working. This is now a Kubernetes production grade FastAPI application. Of course, it's missing a database, which is a whole nother story, but the general idea here is it's totally working, and it's working directly from all of our configuration. And of course, if I exit out of that running pod and do kubectl get services, I should be able to see the external IP. That's not there yet. It's not showing up in this service, which is interesting. It probably will very soon. But anyways, so it definitely was, it did finish provisioning as far as DigitalOcean is concerned. It just doesn't have it updated on my kubectl side just yet, which is curious. But nevertheless, it does work, and it absolutely is a Python-based Docker container image that has now been deployed into production on Kubernetes. So I'm really excited to keep going and get us to the next few parts that we need in order for Django to work. In a moment, we're going to go ahead and provision our private container registry. But before we do that, I just want to mention as to why we need to have a container registry at all and why it needs to be or should be private. So if you do docker compose up -- build on your local machine and hit enter, this will actually build your container images if they need to be built. Now, in our case, we are using the public container images of Postgres and Redis, so I actually don't have to build them locally. They already exist somewhere. That somewhere my local machine can actually get. It can go into Docker Hub and download the container registry, much like what we just did with Kubernetes. It was able to access this because anyone who has access to the internet can pull this actual container and use it, right? So Kubernetes does that really well. And it does that with all of our other images as well, right? So we've got our Postgres image. That's the public one. Anyone can use that. And the Redis image, again, same thing. Now, our own application, on the other hand, we do not want it to be public, but we still need to build it. So the actual image still needs to be built and put somewhere. So that somewhere, I'm going to go ahead and close these out. That somewhere is going to have to exist. So if I do Docker images on my local machine, I see all of these different container images that already exist there, including my Django K8s one, which I created in Docker Compose a while ago. So even if you have this or not, that's not really the point. The point here is this needs to actually be stored somewhere that's private. The second part of that is Kubernetes needs to have access to grabbing a private container image. Now, that access is much easier if it's all managed by DigitalOcean, which is why I recommend that you use DigitalOcean's private container registry so that your Kubernetes, your local Kubernetes, will have access to those repos a lot easier. Notice that you can use one repo up to 500 megs, and our Django project at this point is only 278 megabytes. So you should be able to do this for free. Me personally, I use the professional one because I have a lot of different repos that I use constantly. So $20 a month, in my opinion, is not bad given what it does. It saves you a ton of time in actually storing your private repositories over something like Docker Hub, even because there's additional aspects to Docker Hub that you'd have to implement in order for it to work on DigitalOcean. If you want to see that, let me know in the comments, but we're going to go ahead and stick with this one. I'm going to go ahead and select professional. Feel free to do starter just to see if it actually ends up working for you. I think it will, just with one. Worst case scenario, you just provision basic and now you have quite a bit more storage in there. And that's only $5 a month. So I'll go ahead and do this one and I'll call this CFE K8s. And then I'm going to go ahead and create this registry. Of course, you can't actually use this registry at this point. You have to do your own custom registry. So this will provision. It'll take a little bit of time to do that. And now, of course, we need to actually connect to this registry somehow so we can actually push our container images in there. And to do this, one of the best ways is using the DigitalOcean command line tool. However, it's a little tricky to get that thing up and running on Windows. At least I've had some issues with it. So we're going to go with, in my opinion, the easier method, which is just simply the API token and logging into the registry directly. Now, when we put this into a GitHub action, we'll go back to using the DigitalOcean command line tool, or doctl, and use the registry login because we can actually expire when a registry login actually happens, which I think is cool too. So feel free to use either way. In just a moment, we'll actually go ahead and use an API token, log in, build, and push a container registry there. So let's go ahead and take a look. Now we're going to go ahead and log in to our recently created registry on DigitalOcean through Docker. So you need to make sure that your local machine has Docker on it. Now, if you don't have Docker on your local machine, we will show you how to implement this later in a GitHub action, so you don't actually have to touch Docker at all locally, but I think it's a good idea to practice this anyway. So what we want to do here is do docker login registry.digital digitalocean.com. And what we are going to put in for a username and password are the API tokens. And this, of course, is coming directly from their API dependency free, actual guide that they have is just paste API token, paste API token. Cool. So let's go ahead and create one. Now to create one, you'll just go down into API here and personal access token, generate new token. And then we'll just give it a name. In this case, I'll just do Django K8s and we'll say local token. Okay. Generate that token and there it is. I'll go ahead and copy this. Now do keep in mind that you might want to delete it or edit this, re-update it, regenerate it, do all sorts of things that you might do from time to time. Nevertheless, I'll go ahead and copy this and I'm going to put it into my username and my password. Okay, so you can't see either one. It just does the same thing. Login succeeded. Great. Okay, so now what I need to do is build my container image for my web application. So I'm going to cd into web and we will actually create it. So it's going to be Docker build, the normal Docker build, and then we need to tag it something. So the tag that we need to use is actually corresponding to our recently created registry. That's this right here. So this is the root of our tag. The next part is going to be the actual image name. In my case, I've been calling it Django-K8, right? So this is the actual image name itself, the entire thing. We need that entire thing there. And then we can tag it whatever we want, like V1 or latest or whatever. I'll leave it in just as latest. Okay, so I'm going to build it with that tag. Then, of course, I'm going to declare my Dockerfile that I want to use, which is the standard one, which, of course, this is the default anyway. And then I'm going to go ahead and use the context of this current folder, and I'll just go ahead and hit enter. Now, in my case, all of this stuff should have already been built somewhat recently, so it's not going to take that long. But if yours wasn't built somewhat recently, this might take a good amount of time for it to build up. But of course, it's also going to be running all of the Python related installations, which also takes a little bit of time. But after we build that, what we want to do is take that same tag. We don't need the :latest here, but take that same tag string, this right here. We want to actually run docker push that whole thing. And then I can do --all -tags. This will allow me to push all of the tags I might have for this built image. Now, at this point, this push doesn't matter that much in terms of multiple tags because I only have one tag. It's this one right here. But I can actually add in additional tags on this build script, and I can also tag these Docker built images later as well. Now, this push right here is going to become a lot more important once we actually put this into GitHub Actions, which we'll do later. So that actually becomes a critical piece of all of this much, much later. So in other words, I could have just pushed the single tag itself right here, and that would have been fine. But as we see here, it actually pushed a number of layers in here. This is actual storage size, as we see right there. That's exactly what's happening. And now inside of our Kubernetes repository, or really just our container registry, not only for Kubernetes, but it is our container registry, I can actually refresh in here. And what I should be able to see is some data. If I scroll down, I can see some data here, right? So there is my Django K8s, one image, 21 seconds ago with only one tag, right? And if I open this up a bit, I can see all of the other tags if I had them, as well as the actual deployments themselves. Look at it, it's actually not that big. So you should definitely be able to use this on the free tier. And so the next part of this, of course, now that I can build this, is to actually integrate it with Kubernetes. And look at this, I can actually just integrate all clusters or select the single one if I have multiple. And this will allow me to pull images from here. Now it's read-only access, but still it's allowing this to pull it. So it actually updates everything you need for this, which I think is so cool. I'm gonna go ahead and hit continue. And now I don't have to think about this stuff. Now, yes, there is a way to do all of that stuff manually, and there is a way to do it with other container registries. But if it is just that simple, why would you need to? Okay, so that's kind of the point here to me as to why you want to use the DigitalOcean container registry among all the other ones. Now, of course, if you already have a bunch of images on a different container registry and you just want to use that one, there are ways to do it with Kubernetes. So check out the Kubernetes documentation or the documentation for the private registry you might be using, because it does take a little bit of time to get there, to get to the point where you can use that. other one if you're so interested. But I'm just going to imagine most of you, this is a new look at Kubernetes for you. So things are all good there. Now, before I go any further with the Kubernetes stuff, one of the things I wanted to mention is you can actually use this image inside of App Platform. So you can actually come in here into App Platform, go to Create App, and you can navigate down to, hey, your DigitalOcean container registry, and you'll actually be able to pick that Django project. So this is actually another cool aspect of this, of using the container registry, is I can actually deploy this really quickly into App Platform just to see if my Django project's working correctly, or to test a different version, because you can see there's different tags here. There's all sorts of stuff that you might consider doing prior to promoting it to your Kubernetes cluster or anything like that, which is definitely another advantage, but just something worth mentioning. Okay, cool. So now that we have our container registry set up, I actually want to get my managed database set up next. Now we're going to go ahead and provision a managed database on DigitalOcean. Now, the first thing I'll mention is that you can absolutely provision your own database and manage your own database through Kubernetes. Although this actually saves us a ton of time and a lot of potential headache in the long run in managing databases. Of course, if you want to learn how to manage a database, it's definitely something well worth learning, but it's not something we're going to do at this point. So let's go ahead and navigate over into the database section on your DigitalOcean console. Hit create a database cluster. We're going to be using Postgres. Notice that Redis is also in here. If you need Redis, by all means, go ahead and add that as well. The machine type is going to be a basic type of $15 a month. So essentially, if you need a bunch of different databases, just at the bare minimum, it's going to be $15 a month for those production grade databases. Now, these aren't really hobby databases. This is actually made to run in production. So that's what we're going to stick with. Next, we need to choose the same data center that our Kubernetes cluster is in. Now, you might have already forgotten which cluster you selected, especially if you did like New York or San Francisco, because there's a couple options there. So if we actually open up the Kubernetes tab here, we can verify what cluster we have. In my case, it's NYC1, which of course is New York 1. So I want the same exact data center in this case. Notice that it also gives me the different droplets right there for both of them, but we're going to stick with the exact region, data center 1 or New York 1. The VPC, as we mentioned, when we actually provisioned our Kubernetes cluster, we want to use the same VPC that's there. Now, one of the ways to check this is by going into the networking tab, go into VPC, and then actually verify the VPC and the resources that are in there currently. Right now, there's our Kubernetes cluster. This we absolutely need to have as the same thing. Maybe at some point they will also add in a quick glance as far as the VPC networks are concerned. Next up, I'm going to go ahead and create a unique name for this. In this case, I'm going to call this Django-K8-DB Postgres. I don't actually need that remaining stuff at this point, but that's going to be what I'm going to do. Next, the project. This part I don't think really matters much. I'm going to leave it in as the same project as my other one. And so now I'll go ahead and create this database cluster. While that's provisioning, what we're going to do is we're going to jump back into our local project, and we're going to create a new file in here called .env.prod. Now, this, of course, is going to be our production environment variables. So I'll go ahead and copy that and paste in here, copy our original .env and paste in here. And then right away, I want to add this to my gitignore file. So .env.prod. Even if you don't have a gitignore file, it might be a good idea just to create one, just to make sure that that's in there. Also in our dockerignore file, we want to put that in there as well. Now, these the prod environment variables, the reason I have it locally is really just for my own reference and when I actually need to provision the proper secrets for Kubernetes to leverage these things. This is what we'll see in the next few. Okay, so while it's actually being created, what we want to do here is we actually can go through their getting started part, right? So add trusted sources, for example. You can add your computer's IP address as a trusted source, which is pretty cool. You can also add in various pools, the actual node, or the entire Kubernetes cluster. I'm literally going to only allow my Kubernetes cluster access to this. That's it. nothing else. Now what we've got is we can use the public network version of this, which is not something we need. We want to use the VPC network version of this, which is fantastic. We have a way to connect to this over our VPC. So of course, what we want to do here is we want to add in all of our parameters here. So the username is going to be doadmin, again, .env.prod. Next, of course, is going to be the password that's written here. And it's going to be this one right there. Next, we're going to go ahead and grab the host name. No surprise there. The port. Okay. And then the actual database itself, which is just simply default DB. And there we go. So we now have all of the parameters necessary for this to work. We also have this thing of SSL mode being required. That's something I'll actually come back to in my Django settings. It's not something I'm going to do just yet, but it will be really easy to come back to this, as we'll see. So go ahead and say continue, and there we go. So this is actually a quick way to copy your database from a pre-existing database, right? There's a bunch of different ways on how to do this. So if you are migrating this project from another database and you need that data, it's actually pretty straightforward to do, although it's outside the context of what we're doing here. So that's it as far as provisioning our database. But there are a couple other things I want to add into my .env.prod. One of them being my super user password. So what I'm going to do here is I'm going to go ahead and activate my virtual environment. So source venv bin/activate. Oops, we need to navigate back a little bit. We'll do that again. And then now I'm going to run python-c. We're going to import secrets. And then we're going to print out secrets.token URL safe and 32, just like that. And it looks like we have a syntax error, and it's from import. Okay, let's fix that real quick. And there we go. So now we have a new secret that we can use for our super user password, just for when it's generated for the first time. Then we could always change it later. The Django secret key, now we can absolutely use this exact same thing, or what we can do is use the one-off secret key or the random secret key generator that comes directly from Django itself. And that's it right there. So this command will be also in the comments below, but it's also on our blog post called Create a One-Off Django Secret Key, which I've mentioned before. But anyways, we've got this now secret key, and so we can add this in here too. These actually aren't a whole lot different. The secret key might have a few more special characters in here because it's not actually URL safe like the other one. This one can be used in a URL if need be. Okay, so now we have all of our environment variables pretty much prepped up. So we want to actually bring these into our Kubernetes prior to actually creating our Django deployment. And that's a critical piece to this, right? So we need our Django project to have access to these things. And of course, we don't want to build our Docker container with access to these things because then it's going to stay there and it's not incredibly secure. Instead, we're going to be using Kubernetes Secrets, and that's what we'll do in the next part. So when we deployed the IAC Python project, we saw that I have environment variables right inside of the deployment declaration. Now, of course, we don't actually want to do this with sensitive keys. Instead, what we want to do is use Kubernetes Secrets, and you can actually do that from an env file. So if I actually do kubectl and get and then secrets, I can actually see pre-existing secrets that are already in there. One of them is actually for our private container registry right on Kubernetes, which is really cool. So that's one thing. But the other part of this is we actually want to add a new one in for our environment variables for production. It's really, really straightforward on how to do it. So it's kubectl create secret. The secret type, in this case, it's just generic secrets. Now we're going to go ahead and say the name of it. So Django-K8-web-prod-env. That's just the name I think that makes the most sense here. It's the Django K8's entire project, right, on that cluster. And then also it's the web deployment that we'll eventually have. from this. And then it's the production environment variables, which of course is, in this case, .env.prod. So that's going to be the name of our secret. And very similar to like the actual name of the secret for the private registry that we have, this is going to be the name just for environment variables. But of course, we need to declare what's going to go in here. And it's pretty simple. We'll just do -- from -env -file, and then declare where this file is. In our case, it's in web/.env.prod. And I think I'm writing this in the root. If I am not sure about that, I can just go ahead and copy this, hit Control-C, and then list everything out. And yes, I am in the root of this project, so I'll go ahead and run that again, or actually paste it in and run it. So now it actually created that file for me. And again, I can look at all the secrets in there now, and I see this secret right here. Okay. So what we can check out is if I do get secret, that secret name, and then do the output of this as YAML, I can actually review what's actually being stored in there. And it's all of this. Notice that it is actually somewhat secure in the sense that it's not regurgitating the ROP things back to me. It's actually encoded in base 64 encoding, which is nice. So that makes it a little bit easier for me to have some confidence that even if I accidentally gave this away, it's not going to be that easy to just diagnose what the actual pass or all these keys end up being, which is cool. Okay, but now it actually exists. But one of the things you might be wondering, this is certainly one of the things I wondered right at the beginning, is what if any of these configurations change? How do we actually update this? What I end up doing is I actually delete this. So I delete this secret, and then I just run the create again. So it's really just simple as kubectl delete secret, that secret, just like that. And then I run this again. Let me just go up, and then boom, it's back. Okay. So this will make a lot more sense once we put it into deployment, and then also once it's all inside of a GitHub action. So all of this stuff is automated and also gives us reference on how to do it manually too, which is both things are win-win with the GitHub action stuff, which is still coming. But anyway, so now we have those actual secrets. So we're actually ready for designing our Django deployment. There might be a couple things that we still need to do to actually finish off the deployment, the actual deployment file and the service and all that goes with it. But generally speaking, we now have our Kubernetes cluster, of course. We have our Docker image for our Django project built and in the private container registry, which Kubernetes has access to. We also have all of the environment variables necessary for that Django project. Those environment variables also include connection, everything that we need for connecting to our Postgres, our production grade Postgres database. So yeah, that I think means that we are ready for some level of deployment. Let's go ahead and take a look. In a moment, we're going to go ahead and create our Django deployment and service. But before we do, we need to address the SSL mode in our database. Notice that it says it's required. You actually have to connect securely to this database. This isn't always true with production databases and with Django. So to actually set this up, we're going to go ahead and jump into our local.env, and we're going to add in a new one in here called db-ignore SSL equaling to just simply true. Now, the reason I have that is because my local environment is where I should revert things in some degree. And so what I'm going to do here then is inside of my Django settings underneath my databases, and I can put it in the if database is available clause, or I can just put it underneath it. I like putting it together. So I'll go ahead and say if not. Well, what I'm trying to check here is that this is not true, essentially. And the reason I'm using true is just to make it like very, very clearly, I want this to be secure all the time unless I specifically put in my environment. So we'll go ahead and look at this, and let's I do exactly this. So os.environ.get that equaling to true, right? So if this is available, then I'll go ahead and say if not that, then I will update my database. So first off, it's going to be databases and then default, the default database. Next up is going to be options. and we'll go ahead and say equals to, and this is where we put SSL mode and require. Let's keep the double quotes going here. There we go. And it's really just that simple to make sure that we have SSL mode. In our local development, we do not want that because we don't have it set up in that way at this point. Okay, so now we have that out of the way. There's one more thing I actually want to update as well, and that's inside of my container registry. So when I created this first container, I just called it Django K8s. This actually adds a little layer of complexity to some degree, or at least confusion down the line, because our Kubernetes cluster is also called Django K8s. So I just want to also update that a little bit, and I have the build and push notes right inside of the project itself. So if you need to go in and check it out, all I'm doing here is going to navigate into my web folder. I'm going to build it now with -web on there. That's it, just to make sure that it's very clearly, it's the Django K8s, Kubernetes cluster, and it's the sort of web service that we're using in there. And that's kind of how I'll address it going forward, just to make it a lot more straightforward and not conflicting in our configuration. And the only reason for this, or the main reason for this, is now when I come in here, I'll do Django K8s, and we'll just call this our web.yaml. Now I could have it as its own folder, just like I did with Nginx. The Nginx folder is mainly just to separate things so we can visualize it a little bit better. Not so much that that's how I end up using things. In fact, I end up using them much like we did with IAC Python most of the time. Anyways, so now that we have built this image, I do need to send it into my container registry with this tag or this command right here. Again, this is just sort of review as to what we've already done. And when we do add this into GitHub Actions, then we will definitely have all of those things written out a little bit more clearly as well. So in a moment, the actual repository will be available for us. Okay, so with that housekeeping out of the way, let's jump into our actual deployment. Now, a while ago, I mentioned that there is documentation on Kubernetes website, which is kubernetes.io, for all of these various features, like a deployment. So if you actually search for deployment here, what you'll actually come to see is you'll see deployments right there. And this will actually give you some examples. Hey, that looks familiar. The Nginx deployment, we actually did essentially this. It was a little bit different, maybe by a little bit, not a whole lot, but overall it was basically the same thing. So I think this is actually pretty cool because the documentation does also show this stuff. And you're like, oh, what about service? We look for a service, we click in here, and we just did that same thing. And it's also very, very similar. Obviously, I went into all of that context for you, but the Kubernetes documentation, I think, is really well thought out. And there's a lot going on to it if you sort of know what you're looking for. And if you don't know what you're looking for, it's a lot of things that you can test, which is great. Okay, so at this point, our actual container image has been pushed. So we can go into our container registry again, and there it is. So I see that container right there, and I can delete this old one, which is exactly what I'm going to do now. I do not need this old one at all, because I will not be using that one. Okay, cool. All right, so now we just have the single one. It's time to create our deployment. So like I said, with the documentation, if you went in here and did a search, we searched for deployment. This is really if you ever forget some of these things. Obviously, I have the code on my actual GitHub repo that you can use, but notice that the API version is in there with apps v1 and kind of deployment, right? So you can do that exact same thing. You would just put in API version and then apps v1 and then kind being deployment and so on, right? And so if you do come into this deployment and copy it, you can paste all this stuff in and just change it to how you see fit. In our case, I'm calling this Django K8s web deployment. And we can leave it as deployment or use both of these things. I'm going to, like I said, I like making it really easy on myself and just using the same label all across the board. except for, of course, the container image. This is going to be the new thing for us because of where it actually exists. Well, where does it exist? First off, if we go into our container repository, this is where it exists. It's right here. So we need to include the registry link here, and then we need to include our actual image name, and then which version we want to use. In this case, I'm going to default to latest. Okay, and this should actually be right here. Okay, so then the name of it, I'll just call it this. Now, by default, the deployment will not just connect to this. We have a secret to connect to it. So what is it that secret is? Like, how do we actually know what that secret is? Well, what I want to do here is I'll go ahead and say Kubernetes or kubectl get secret. Okay. And so I want to look for my container registry name, which is this right here. So I got my container registry name. Again, we can verify that just inside of our DigitalOcean account of what this is now. That automatically generated a secret for us on our Kubernetes cluster when we connected it, right? If you remember back to when we connected it, there's probably a way to connect it again or to other clusters, right? So at this point, I have it integrated to all, and that's how we connected it, right? And it actually added these secrets in for us. I don't need to do it again. But now I have that secret, which I can verify by just clicking that. And I can also do -o YAML. So I can actually look at this secret in a little bit more detail as to what's going on here, right? But unfortunately, what this secret is not showing me is how to actually use this secret inside of this container. So what actually ends up happening here is it not only creates this secret, but it also adds this secret to what's called a service account. So what that means is we can actually do kubectl get service account, and then the default service account that's automatically generated for us. And then we'll go ahead and do the out again, and we'll take a look at that. This gives us our service account. This is, again, is also connected to when we actually did our cluster there. And what we've got here is image poll secrets. This is the service account that we have by default. This deployment will use this service account by default. Inside of there, it has this thing called image poll secrets. This is the configuration we need to add into our deployment. That's it. And we're going to go ahead and do this. Put it right in there. This is actually back one. Okay. So there is the secrets. And of course it's going direct. This is actually the secret. It is named after the repository, but it's actually named for the secret, right? Or the private container repository, that is. But this one is actually referencing the secret itself. Okay. So I think that's probably a little confusing. I'm sure it is. But the general rule of thumb here is what happened when we connected our private repository is it automatically created a secret for us, and it also updated our service account. That service account is how we're able to access a variety of things. In this case, the access is going to be to specifically this image right here. Okay, but of course we're not done, right? Because we have another secret that we want to use. So let's go ahead and go back into our secrets here. We have this other secret called Django K8's web prod env. So what's cool about this is inside of our container declaration here, we can actually go ahead and say env from, and then use a secret ref, and the name, let's tab that in, the name being Django K8's web prod env. Pretty cool. I can also declare the secret name for port, and then the value being, whatever value I want to use. In this case, I'll just use 8001, and I'll put that right there as well. Okay, cool. So that is our Django deployment. Pretty straightforward on how that's done, hopefully. Maybe not completely, but it is there now. The only final thing that I really need to do is create that service account, which I'm going to go ahead and just copy and paste it because we've already done this one. a couple times now. So Django K8's web service, right? It's a load balancer. It's targeting the same port as the container port. And there it's also targeting our Django K8's deployment. Perfect. Okay, cool. So now let's go ahead and go back into the root of our project. And we'll go ahead and do kubectl and then apply -f K8's apps Django -K8's web.yaml, hit enter, and there it goes. So what we want to see now is kubectl get pods, and we'll go ahead and watch this to see the deployments being created, right? So it's absolutely creating them for us, which is super nice. And it's going to take a little bit of time, but now it looks like it's running. So I can hit Control-C to cancel the watch event here. So -W will watch these being created. And so now, like we've seen before, I can do kubectl execute -it, the pod name, any pod, --bin/bash. And let's make sure we spell kubectl correctly. Try that again. And what this will do is bring me into that Django container, into the working directory that we declared on our actual Django container, our Docker file for that Django project. And then we're going to go ahead and do source OTP venv bin activate. We want to activate that virtual environment. Now what I want to do is I can run python manage.py migrate. This, in theory, should actually bring me into there. I got an SSL mode of required being incorrect. It looks like I made a mistake here on our container image. This should be require. Little things make all the difference sometimes. So with that being said, I could absolutely then update everything. Let's go ahead and update everything in the next one because of this error. But what we'll see once we actually update it, I should be able to run that migration. Of course, it's still manual. We still need to automate it. In fact, we need to automate a lot of things, but we will be able to see how to solve this error in our code. Let's take a look. All right, so in that last one, we got this error here on our Django project, invalid SSL mode being required. That, of course, should be simply require. Now, part of the reason to show this error is twofold. Number one, we have a really severe need for continuous integration and continuous deployment methods. That way, I'm not doing a bunch of stuff manually. So there's a really, really strong case to have GitHub Actions, for example. The other side of this is seeing how to recover from something like this. So let's actually take a look at another thing with our environment. So I'm going to go ahead and do kubectl get services. So in my case, I don't have an external IP yet for this service. So there's no real way for me to access my Django project online just yet. And also if I do kubectl log, well, actually, let's go ahead and get the pods. What I want to see here is I want to see the log for any of these pods, right? I want to see what's happening there. And we can just do log and then grabbing one of those pods. So kubectl logs rather, and grab one of those pods, right? And so it's showing me that it's running at this port, which is great. So the environment variable, at least one of the environment variables is working. And the other part of this that's kind of cool is it appears that these environment variables are working as well. So if I actually jump in to the Python manage.py shell, I should be able to see these things, right? So the .env does not exist, but let's go ahead and import some of those environment variables. Let's just grab maybe the super user username. So again, the .env is not there. So are the environment variables there? Let's go ahead and print it out. So os.environ.get that username and hit enter. And what do you know? It's actually there. And so what I would challenge you to do to verify this as well is to change your environment variables. Like I mentioned, you are going to change your secret and do all that. We can also very much make sure that the secrets are being used, the Kubernetes secrets are being used by looking at something that's a little bit more specific to the production environment variables, which was our Postgres host. And sure enough, there it is. Okay, so we know that those things are working correctly, which I think is really, really cool. But of course, the actual migrate is not working correctly. And there would be no real way to see this unless we did a proper production test, which again, we will absolutely have to take a look at. And so what I want to check out right now, though, is I want to see the service itself. I want to see this thing running. So here we go. I now have my external IP address. Yours might have provisioned a little bit faster. I don't know. But anyway, so now if I go here, I get a different error. This is not on allowed hosts. Well, this is, of course, because of, well, a couple of things. Number one, with Django, especially when you're in production, you need to have a allowed host of some kind, right? So the allowed host setting right here. Okay. So I definitely am going to add that in right now. This probably should be in the environment variables actually. So let's go ahead and change it just slightly. And so we'll say allowed host equaling to that. Notice that debug is on. That is a big no-no. So let's go ahead and get rid of that. Now back into our settings, what I'll do is I'll say my allowed host now is equal to os.environ.get, whatever that allowed host is. And then if it is something, then I'll go ahead and say my allowed hosts are this one. Let's actually change this to being env allowed host. That way it's not conflicting for those of you who just want to make sure that we are not, renaming things incorrectly or put env allowed hosts plural. So let's just change this. Okay, cool. And I'll just move this down a little bit. Now, we have new env files. So what do we need to do here? How is it that we're going to solve this problem? Now, you might recall when we actually created these secrets, we went in and did kubectl delete secret, and then the Django-k8-web-prod-env. Okay. And again, I can actually look at that by just doing git secret. You don't have to remember the secret name at all. You can look at it there, or you can look at it in your actual deployment itself, right? So the deployment will also be in there, secret ref right there. Okay, cool. So I just deleted those secrets, but my connection to one of those pods is still up. Now the question here is, did that secret go away? Did the environment variable change, right? So if I import OS again, let's see, and print out, we'll do os.environ.get. And let's grab one of those secrets. Of course, it didn't change, right? It's still there. The secret itself, the deployment itself, all of this stuff, a future pod will likely not have those secrets anymore because they just don't exist. They deleted them. But the current running ones, it's not like they lost them. And if I do kubectl get pods, they should be all the same ones. They're about 10 minutes old, right? Until I actually delete one of these, then we might see something different, right? And I do encourage you to test that out. But anyway, so now I'm going to go ahead and bring back that secret. As you may recall, it's really simple. It's kubectl create secret generic. The name we want to use, of course, we want the same name that we have in our deployment. And then we are going to go ahead and declare where that env file is. And there we go. So now we have the new secrets in there. Okay. They made some changes. Now they're there. Good. My settings have changed as well. Okay. So I have require in here as well as that allowed host. So I actually have a new question. What do we do now? I changed something in my Django code. Well, eventually this will all be automated. That's definitely what we want. But you got to think about, I just changed the web code. What is it that I need to do? Well, I actually need to build this project again, the entire thing, and deploy it into the cluster itself. So I'll go ahead and cd into web. We're going to go ahead and build it again. And then we're going to go ahead and push it. Okay, so once it finishes building, we will push it again. Now, this is where tags will make all the difference. As of now, we're only using one single tag. What would be a good idea is to have multiple kinds of tags, not just the latest tag, but also previous tags. That way we can actually revert to previous images that were already built. We'll get into that when we go into GitHub Actions as well. But as of now, this is going to go ahead and build it, push it, and do all of that good stuff. And then we can actually, well, what do we do after we have created this deployment? There's a lot of different options, but I'm going to show you a fairly simple one on what we want to do with these deployment changes. That way it actually does change. And so I'll let this finish pushing. All I'm going to do here is initially, let's go ahead and change the ports all across the board on the service and the environment variables and all that. Let's see if that does anything for us. Okay, so the image is now on the container registry. So now inside of the root of my Kubernetes project, I'll do kubectl apply -f. I made some changes to this deployment. We'll go ahead and do k8/apps/django-k8/web.yaml. Before I hit enter here, I'm going to break this down. You don't have to do this part. I just want to show you what's happening on my end. I'll go ahead and do kubectl get pods and -w to watch the pods. I'm going to go ahead and apply this change. I'll hit enter and we'll see what's happening. Okay, so now it's creating a new container, at least one, but actually it's creating 3, right? So it's actually going to do all of these and it's going to take some time to do so. So the big question here that's yet to be figured out is if this image right here is actually going to be the proper latest one. Like, is it actually going to do some of those changes? Now, we definitely want to see how to enforce this for sure, even if it's not a new tag, but we also want to see if by default, it's going to pull that new image and create a brand new container for us. This is going to be pretty interesting. I'm going to let this actually finish off. I'm going to go ahead and close out those pods. Let's see how much are left. Looks like those are terminating and the new ones are running now. And the easiest way to check this too is to open this up a bit and see what the age is of these ones. So all of these are less than a minute old. So let's go ahead and go back into our project here. I refresh. This time that error goes away. And if we go into the admin, I actually shouldn't be able to log in just yet because I haven't run a very specific thing, Django migrations, right? And at this point, you might be like, wow, there's so many layers going on. How am I possibly ever going to remember all of these things while I do this? You're not going to. It's just like there's just too much going on. So what we end up wanting to do is a couple things. Number one, creating your own little notes file that does each thing step by step. Or number two, which is what we're actually going to do, is creating a GitHub workflow that will do all of this for us so we can reference it for ourselves at any time. Now, the key thing here is I have some notes for this, right? So for this particular project, this one's not going to be public, but I just want to show you the notes and just the general idea. In here, I've got my workflow and I've got this thing called do main, right? So what this is going to do is some of the main things, but I just want to mention, look at, we've got our build here, right? We've got the login, the registry login, like I mentioned before. We've got our Kubernetes cluster stuff. We've got apply, and then we have this thing called rollout, which is pretty cool. Okay, so that is pretty similar to what we're looking at here. We also have this update file, which actually will replace something with the newest, latest things, right? So again, this is not exactly what we did, but it is something we're working towards. And so it's going to build that container image for us. It's going to log us in. It's going to push the actual built image for us as well with a tag. Then we're going to go ahead and use that tag inside of our Kubernetes cluster. And again, this is stuff that we will see, which is, I think, is pretty exciting on how to do. So the final thing that we really need to do here, though, prior to moving on, is running the migrations. So I'm going to go ahead and close out this window here. And I just want to make sure that everything is working. So we'll go ahead and do kubectl get pods. And of course, we're going to use one of these pods here. We're doing this the manual way so we can see how it's done. So kubectl execute -it, the name of the pod, -- and then bin/bash. Now, I could actually run the migrate command right there, but I'm going to go ahead and go right into the container itself. So we'll go ahead and do source otp venv bin/activate. Still in the root of this, I'm going to run python manage.py migrate, hit enter, and this should actually run those migrations. Another thing that would be cool, which would be better actually, is to run the bash migrate script, because that will do the migration, but also create our super user. That, of course, is based off of the env.prod. So back into our actual IP address here, we're going to go ahead and do the admin user. And then I'm going to go ahead and grab this super user password. And we're going to go ahead and log in. And what is going to happen? Right now it's loading. It seems that maybe it's doing something. Maybe it's connected. Maybe not. Maybe we're having issues. We will see any time now. Okay, I'm actually going to just reload this page because it could be a previous session that we've got going there. And there we go. I actually have access from my production Django Kubernetes project with my production managed database. Really, really cool. Okay, so we still have a number of steps that we want to take care of. One of them is actually starting to work on our GitHub actions. Another one is maybe having our static files even show up here as well. Let's take a look. All right, so what I want to do now is develop a deployment guide, our own little guide that's going to be a markdown file, but really it's just step-by-step what we need to do from here on out. And then we can discuss all those things as they happen. So let's go ahead and get started. So in the root of our web folder here, we're going to go ahead and create deployment guide-md. You can call it whatever you'd like. You can do a txt file or skip it altogether. I'll have this in the actual repo as well, as you already know. So the very first thing that we need to do is we need to test our Django project. This is incredibly common when it comes to actually deploying any sort of Django code or any sort of Python code. You want to test it before it even moves in the deployment pipeline at all. So for example, if we do source venv bin/activate and then go into our Django project, so cd web and then python manage.py test, this test should be successful, right? If it's not successful, nothing else should happen. So that's the very first thing. And of course, the reason we're even talking about this deployment guide is because we're going to turn this into actual functional workflows that end up happening on GitHub Actions. Okay, so the next one is we want to build a container. So after it actually does test correctly, we want to go ahead and build this container. Now, this is also pretty straightforward. It's docker build-f, the Docker file itself. Then we want to use the tag of registry.digitalocean.com/ whatever your actual registry is called, right? So if you go into DigitalOcean and you go into your container registry, whatever yours is called, mine is this link right here, right? Hopefully this is all review. Then of course the image name that you want to give it. So Django K8s and web. Now we want to tag it with latest, but what I also want to do is I want to bring in another concept here with another tag. So I'm going to go ahead and say v1. Realistically, this is going to be our commit ID. So once I actually bring this into GitHub Actions, I'm going to change this to being our commit ID. But for now, I'm going to use v1 and then put a period there. So this, of course, will build our container file, and it will also actually tag it 2 times. One with v1, one with latest. So let's go ahead and run that. Of course, if you don't have Docker locally, then this is not going to work. And of course, you want to make sure that you run this command within the web folder itself. Otherwise, it's also not going to work. And so I'm just going to let that finish up running. After it does finish, we want to push this container to, DigitalOcean, or we'll just say DO, container registry. How do we do that? Docker push the root name here, so without the tag, and then just do --all -tags. That's the easiest way to push it with both of those tags, and we'll go ahead and run that. Okay, so while that's running, the next thing is going to be probably, do we need to update our secrets? So this is sort of an optional thing, and we definitely already did this, so I'm going to go ahead and copy and paste this one. First, we have to delete our secret, and then we just create a new one. Now, the reason I'm doing it now is because the next step is going to be updating our deployment. So if I make any changes to my secrets, this is the time to do it. Step 4. Next, after we update this deployment, what we want to do is we want to keep this YAML file the same in regards to putting it on to GitHub, right? So I'm actually never going to change this locally. I'm going to change it right now for a moment just so it does make the change that I want it to change. But really it's going to be we want to run kubectl apply -f, and then we can get the relative path here. And that's what we want to run it as. Now, remember how I said this might be the commit ID later. So let's go ahead and just call this commit ID just for a second, right? So this commit ID, we want that to be this deployment file here. And the deployment file itself doesn't really need to change. Latest is okay. But if we change it to the commit ID, then it will definitely change the deployment. Like you'll actually do a rollout of this new deployment. That's kind of the key here, right? So at this point, we're going to leave it like we had it. We'll go ahead and run this. And what we most likely will not see is anything being changed. Okay, let me just navigate into the root of my project again. I'll keep one open for Django. But anyways, so we run this and we'll go back here. And what we see is it'll say deployment unchanged, right? As soon as I open this up and change this to v1, save that, and run it again, deployment configured. And when that happens, if we do kubectl get pods, what's going to happen is it's going to create these containers in what's called a rollout. So this also means that I can actually wait for that rollout to happen. So I can actually do kubectl rollout status, the deployment or deployment slash. So this is a deployment right here. And then the deployment name, right? So the name that we gave it right here. We would just wait for that to finish, right? So this is a nice key way to ensure that during our deployment, we're waiting for this to finish. So we're going to say wait for rollout to finish. Okay. And so that means that the next step would just be our migrating of our database. And we'll do that in just a moment. Before we do that, there are other deployment things that I actually do want to change. So coming back into our deployment, I am going to change this back to being latest. Okay. And then I also want to add in the image policy underneath this, image poll policy, to being always. That's capital A for always. I always want to have that. So that's what I will keep. This is something I left out, but at this point, it's a good idea to always pull this. Now, the point of putting always is, it's another way of doing a rollout. So if we do kubectl get pods, we can see all of the available pods. Notice that my IAC Python is in there as well. But if we actually terminate one of these, so if I did kubectl delete any of those pods, oops, I should do delete, it's kubectl delete pod, and then the pod name. What this does is it will actually roll out a new pod. And if we have this in as always, that means it's going to pull that image when that rollout is happening, when that new pod is being created, which we can verify a number of ways we could verify it. But you're going to just have to trust me on this one, that's going to pull the image, the latest image, whatever that ends up being, versus before, where if I just kept this as latest, it will pull the latest image, but it won't necessarily roll the pods when you need them to. I will definitely reiterate that later, but the rule of thumb here is if we ever make changes to our Docker build, latest, if all of the places we reference it as latest, Kubernetes might not know that it needs to make an actual change to that deployment, right? Just because there's a new Docker container image with the same tag doesn't mean that Kubernetes knows that. And so this deployment file hasn't changed at all at this point. That's why we need to actually substitute this from latest to whatever the actual commit ID ends up being. This, I think, comes a lot more, it makes a lot more sense once we actually do it. But I just wanted to really reiterate it now so you have a better sense of all that. Okay, so now migrating the database, I have two different ways on how to migrate the database. The two different ways actually have to do with how to get one of these individual running pods. So if I do kubectl get pods again and take a look at the individual running pods, to actually run the migration, we have to do this. I'm going to go ahead and delete this terminal out just so there's only one. Let me clear this out. Git pods. There we go. So to do this, we run, to go to any pod, we do kubectl exe c and then -it. The pod name, whatever a single pod name is, not a deployment name, but actually a running container in terms of a pod, 2 dashes, and then what command we want to run. So in this case, I actually already have a command to run. That command is in migrate.sh. So this is where we're going to do that. So we'll do bash app migrate.sh. We hit enter. That will actually run our migrations on that kube file or that Kubernetes container that's running, right? Which is really, really nice. Now we also notice that there is this command error that username is already taken. That of course is because of in our migrate, when we run this, this actually is an error, right? So that user already exists based off of all of our environment variables and whatnot. So naturally, if I changed one of those environment variables, let's say we changed the super user name, what we would have to do then is, well, pretty much all of this all over again. Update the secrets, update deployment, potentially even rebuild the container so we have a new commit ID, then update the deployment, or really just make some changes to the Django K8's YAML file. The changes are going to have to be significant enough where they make sense. Like changing the port might not necessarily force a change for your running containers. Then we have to wait for the rollout to finish. Then we can actually run that command of the kubectl execute -it, and then that single pod --bash, and then app migrate.sh. Now, of course, when I said that there's 2 ways to do this, that's because of this right here, right? This is actually not what we want. We want to use this as a sort of a temporary measure to test locally, but when we actually go into production, we need a more sustainable measure, and that is by using one of these 2 commands. Okay, so what's happening here is it's setting a variable, and it's going to run a kubectl command, which is getting all of the pods related to a deployment now. So if I do it all related to a deployment, it now narrows this down quite a bit. And so we can narrow that down even more by using this next part here. So that whole thing, let me just show you, that whole kube command will give us a single name, right? This single name is what's being set to this single pod name. And this command down here is identical. It's just slightly different on how it's executed. That's all. The first one, I believe, would be the more suitable name for only Kubernetes. The second one has some Linux command line stuff that's going on here, which is why I think this is the preferred method for overall Kubernetes usage. So it's looking in all of the items that are listed out in the pods, and it's grabbing the first one and looking for the name itself. Notice it says metadata.name, which of course corresponds directly to metadata.name. Cool. So once we're able to do this, then I can just exchange this out here for $, and then that, just like that. So run the migrations. Okay. So this is roughly speaking the deployment guide. I'm gonna make some updates to it when it's actually in the repository itself. But the general idea is we need to test our Django code, of course. We ideally have this tested with a Postgres database. This is something we will do in the next one for sure. After that test finishes, then we want to build a container, push it, then update secrets if we need to, update our deployment if we need to, if there actually are major changes, which in our case, if we're actually pushing this, we're going to assume that there are major changes to start. And then we want to wait for the rollout to finish. The only reason we wait for that to finish is so that I can actually execute on one of these pods because they are available, they're ready to run, and I can just go ahead and say migrate. So it actually does take care of all of the changes that may have happened when it was built or prior to that, right? So that's the key here. So if you need to refresh on this one, this is something that you'll want to do from time to time. Now, of course, in my case, the way I quote unquote refresh on here is by using GitHub Actions. So that's what we're going to do now is we're actually going to build in something in here for GitHub Actions so that every time I deploy this code into GitHub, it does this in all of these steps in this deployment guide but I wanted to lay them out manually so that doing GitHub Actions is like, oh, wow, that's a no-brainer now because of this deployment guide here too. So let me know if you have any questions on this. Otherwise, let's keep going. In the last one, we created a deployment guide. This was meant for a reference to run various commands locally to just verify that our project's working and it's working correctly. Now what we're going to do is take this deployment guide step by step and break it apart into a continuous integration / continuous delivery, aka CI/CD pipeline. So we want to have the use of GitHub Actions. We're going to do it with that. And we're going to break this apart into each chunk that actually makes the most sense. Starting off with testing our Django code. So inside of GitHub, if you go in here, a lot of times you'll see a actual Docker or Django configuration here. And this is actually great because it gives us a starting point. Now, before you even go here, what I do recommend that you do is actually import this repository. So instead of forking it is great, absolutely, if you want some of the latest changes, which I'm not going to change this a whole lot over time. But what you should do is go in and import this repository like this, and then just change it to something different. Now, the reason for that is because then it's your repository, and then inside of settings, you can do these secrets in here. So right now would be a good time to have this as your repository and import it into your project. So then you can go into these actions here and go into configure something like Django. Now, you can absolutely write it right in here in line. I'm actually going to bring it right back into my local project. So I'm going to go ahead and copy that. And then I'm going to do .github, and then as a folder, and then a workflows. And then we're going to go ahead and do test-django.yaml, and we'll paste this in here. So it already gives us some of the core things for test, which is really nice, but it's not quite there. And the reason I know the actual directory, I've used GitHub Workflows a lot. That's one thing, but as reference, when you do go to GitHub Actions and you start one of their templates that they have for you, you can just see it just like that. Okay, so if we break down what's happening here in this workflow, is this is going to be triggered on a push, a GitHub push on your main branch, which right now I'm actually working on branch 26-in, so this won't necessarily push automatically, and also a pull request on there as well. Now, what I also like having myself is a workflow call on here, as well as a workflow dispatch. I'm going to show you both of these things as we go forward. Workflow dispatch will be something I use first. Now, the question is, do you actually want this to run every time you push this? In this case, I'm going to go ahead and say yes. Just for now, we're going to say yes. This is the one I want to run when I push this. Next, what actual virtual machine do we want this to run on, which is just a Docker image. We're going to call this we'll just use Ubuntu. That's a very common thing to use for this particular project. The next thing is the version of Python we want. Notice that I can actually have a list here. And if you have a list here, it's actually going to run this list on each one. That's actually pretty cool. So we can actually test our project on multiple versions of Python. That's great, especially if you're doing projects that need multiple versions. Ours only needs 3.9. So that's really the only one I need to test it on. I don't need to test it on previous ones, but by all means, test it on multiple. Personally, I would leave this in here just so you know that it is going to have the ability to test it on multiple. Okay, so next thing up is we need to actually change the default for our working directory. So what I'm going to do here for this is defaults, and we're going to go ahead and run, and then working-directory, and this is going to be in /web. So that working directory is this folder right here, right? So that's all I'm changing here. So I'm going to go ahead and add this in. We'll do git status. And actually what I'm going to do is check out branch main. And then I'll go ahead and do git add --all, git commit, and then add Django test workflow GitHub action. That's quite a mouthful. Now we'll go ahead and do git Django or git push, and then we'll just do --all. Okay. And so this is going to push that workflow, and it's going to run these tests for us. Now, there's one thing that's actually glaring that's not great about what's happening here. That one thing is the fact that I don't actually have a Postgres database as my test. So if I come into my actions here now, hopefully what I'll see is this GitHub action here. And also hopefully what I'll see is it's running. So notice that it actually has the potential to do multiple things, right? This potential means that if I had other versions of Python, it would also show those other versions of Python. But here we go. We've got a improper test, right? So I went run tests and it says the secret key setting must not be empty. So this is actually really cool. The nice thing about these tests is it just failed, which means that if we think back to our deployment guide, our deployment workflow here, that means that step 1 failed. Step 2 should not execute at all. That's a critical piece to all of this. Now, the reason it didn't execute, of course, is something maybe you know about, maybe not. But if we go into our Django project here, our secret key is set to an environment variable. That failure shows us that it must not be empty. Therefore, it actually doesn't have that environment variable. What do we need to do? We need to set it. And yes, we can set it inside of our actual test, the test pipeline here. And we do that by coming under here and saying env, and then we set in our environment variables. So this is a test key, not good, maybe make one better, right? It's not a good test key, but it's still test key, right? So we save this and we'll go ahead and do git status, and then I'll do git add, git commit, updated test workflow for Django, and then git push dash all. Okay. So now it's pushing that into this again, and yet again, it's going to run that workflow. It's going to run the new workflow, and it's going to run as quickly as it can. And it's usually pretty fast, right? So GitHub Actions is pretty fast across the board for all sorts of things. So if you're used to building things like this, personally myself, I don't even do this locally that often anymore. I now just use GitHub Actions in order for this to work. Like, in other words, you can actually run python manage.py test on your local machine prior to having it being pushed into GitHub at all. But I actually think it's much better and more efficient to do it all in GitHub, that entire pipeline in GitHub, which is, why we're talking about it right now. But anyway, so now the test actually went through, but we actually do have another glaring problem. And this glaring problem is the fact that I'm not using a Postgres database. Now, before we go any deeper, what I will say is I have an entire blog post on this, and it's going to be linked in the description as well. But this entire blog post shows you how to do the Django GitHub Actions. I'm sort of skipping a number of things that might be in that blog post itself and really just honing in on what we need, which was one of the big things is changing the working directory. That's not in that blog post at this time. But this next thing is actually having a Postgres database. So to do this, we have to use what's called a service. So in here, we'll go ahead and declare services, and I'm going to go ahead and say Postgres main. Now, this name here is just something I'm giving it. You could call it DB, you could call it whatever you want. Very similar to using, Docker Compose, how we name those services. In fact, the way I view it is it's almost identical to how Docker Compose works. Notice that I have Postgres right here, an actual image. So we come in here and say, what is our image? Now, in my case, I want to declare the image type that I'm using. I believe I'm using Postgres 13 in production. Let's go ahead and verify that on DigitalOcean. So let's go into our databases, because you want to match when you're running tests, you want to match your production database as much as possible. So I have Postgres 13. Awesome. So I'm just going to go ahead and try out Postgres 13. Okay. So just like with, our Docker Compose here, I was able to use environment variables to set the actual, environment variables to set all of the Postgres stuff. So all of this right here, not Postgres ready per se, but all of this stuff right here, I can actually use again in my tests. So what I do here is I can set it directly in these services, or I can put it on my entire environment variables for this entire pipeline, this workflow. This is how I prefer to do it. Just like I did with Docker Compose, it's in one place and then it's available to both my Postgres, project as well as my Django project. So there we go. We're going to put all of these things in here, and just like that. So localhost is actually the default for running inside of your actual Postgres project here. I'm actually going to navigate the Postgres port back to its default. I don't need to change it. You can change it if you want, but I don't need to change it. So I set these environment variables here. After I do that, I will redeclare them down here, because every once in a while you might have these declared differently in your Django project. right? So all I'm going to do here is we're going to say the DB. This is going to be $ curly brackets, 2 curly brackets, env.postgresdb. Okay, so this is, of course, very GitHub Actions oriented here. All it's saying is whatever your environment variables are declared up here, you can actually re-grab them here. It's really, really cool. Next, of course, we can do our user and env.postgres user. Now, I will say, going back to these environment variables, in my Django projects, I rarely put them in as Postgres. I usually do DB, stuff like this. So it's a little bit less of writing for one, but then number two, I don't always use a Postgres database. So using DB underscore makes it a little bit easier when I need to switch to database projects. And the only reason I did it here was to make it all simple for all of us. But that's another reason to have them declared here, but then also down here as well. And the only reason you're declaring them down here has to do with the fact of Postgres itself. The actual image itself is to just ensure that we're getting the correct one. Okay, so there we go. And so we add that in. Now, another thing you might end up considering, which we'll look at in later sections on GitHub Actions, is having some of these values hidden inside of this entire workflow. When you're testing it, I don't think testing a database doesn't actually matter that much as far as keeping things secret. But of course, we could actually absolutely have these values being secret and then updating those as well if we need to. Okay, so the next things are actually declaring our port here. So we'll go ahead and do ports, and this is going to be our port mapping. And I want to make sure that it's exposed just like we did with our Docker Compose. So identical. I don't think we need to make it a string like that. It should work like this, just like in Docker Compose as well. And then we'll go ahead and add in some options that we didn't necessarily need inside of the Docker Compose. And we probably wouldn't necessarily need it here, but these I've seen as best practices for GitHub Actions itself. So feel free to copy those right now. Okay, so that should be it as far as getting our Postgres database to test on our Django project. Now, any other environment variables that need to exist on your project should be in here, right? So notice that debug is missing. I did that on purpose. Debug is not there. But there might be another thing that I need to check, and that is scrolling down in my database. I got databases available, database ignore SSL. Now the big question is this actually going to work? I'm not sure if it will, so we need to test it out. Because in production, I need it to be SSL, but maybe during testing, I don't need it to be SSL. So let's leave it, because if I leave it like this, it's going to assume that I don't need SSL, or that I will need SSL. So I'll go do git status, git add, git commit, and added Postgres to Django workflow test, and then git push origin main or -- all, either one. Now we'll go back in to our workflow. Notice the last one was successful. That's great. No surprise there because it didn't have anything that complicated. So I'm going to go ahead and let this workflow run, and then we'll take a look. And my build was successful. If I look in run tests here, I have no tests to run at this point. So it probably would be a really good idea to have real tests to run at this point, but it's sort of something I'm leaving outside the context of this whole thing. But now it actually ran this workflow, and it did so testing. And actually, this workflow is very similar to how our Django pods work inside of Kubernetes, in the fact that the service of Postgres, that is an external service, but each one of these workflows runs fairly isolated from other environments, other types of things, right? So like the whole thing is a Docker container. That's what I mean by that. It's the whole thing's a Docker container, and it's running just like it would on Kubernetes itself. Now, the actual environment, the actual machines that it's running on are different, and it's also not testing it on our actual production environment, which potentially could have issues. I'm not going to say that it can't, right? It definitely could. So perhaps there's a long-term way where we need to think about having a whole nother Kubernetes cluster that is actually doing all the tests in the same region and all that stuff. I think that's a little bit overkill, and something that maybe you'd have to consider if you had, millions of users a day, not maybe like 1,000 a year or something, right? So in any case, we now have a way to fully test Django on the GitHub Actions with a Postgres database. This is something you should definitely reuse in all of your Django projects right off the bat. Now, one of the things I wanted to show you was this workflow dispatch and what I actually want to do with this test. And that is I want to get rid of the automatic version. I'm going to call this Django CI and Postgres test. Okay. And this build instead, I'm going to call it Django test. You don't have to call it build. You can call it whatever you like. The things that are required are some of the others, right? So like the jobs, runs on, defaults, all that other stuff. There's only a few places where you can kind of divert from what it's called. Anyway, so now that we've got that, let's go ahead and do git status, and I'll do git add -all, git commit, and we changed Django test execution. Okay, so we'll do git push origin main. And so now when I push it, naturally, it's no longer going to just automatically run that test. So in order for me to run it, I can either come into the workflow directly and run it this way, or what I can do is design another workflow to call this workflow itself. So this workflow call thing allows you to nest calling this workflow with another one. And there's a lot of good reasons for doing this. Testing code is one of those. Notice that I'm only using environment variables here. Everything that I need to run this test is self-contained. I don't have any repository secrets on here whatsoever, which makes this a little bit easier to run as well. But anyway, so now what we want to do is actually start the next process in our deployment guide, which would be building the container and pushing the container. Let's see how that's done. All right, so now we're going to go ahead into the next two parts of this deployment guide. That is building our container and pushing it with GitHub Actions. So inside of our workflows here, I'm going to call this build.yaml, and I'm actually going to go ahead and copy a lot of the test Django one, and we'll just change it ever so slightly. So we'll go ahead and say build Docker container and push to do registry. Okay, so the actual triggers here, I'm going to leave them in as, we'll leave it in as workflow call and dispatch, and then we'll go ahead and do push. I wanted to bring this back in of branches to main, and then pull request and branches main again. Next, of course, is going to run on this, and that's true. So I'm going to call this Docker build. Now, one of the things about this is I want this to run, well, after the test actually runs. So before this Docker build happens, I'm going to go ahead and do test Django. And this test is going to happen based off of my repository that I'm currently working with. So if I go into my repository here, I'm going to go ahead and grab the part after. So Coding for Entrepreneurs is my username here, the repository name here, /github/workflows/test-django.yaml @ main. So what this is going to do is actually run that test first, which is fantastic. That's exactly what I want to have happen. So instead of actually going through pretty much anything else, what I want to do here is I'm going to go ahead and get rid of this strategy. We don't need that anymore. I should not need the Postgres service to build my container at all. I might need environment variables, but I doubt it's these. So I'm going to go ahead and leave it like that. The working directory I no longer need because I will use that in line this time, but I'll leave this as is, and I'm just going to only use one step, and that's checking out the code. That's it. So I just want to test if this will test our Django code. So this is just another way to go through that. So let's go ahead and try this out. I'm going to clear this out and do git status, git add, git commit, and added Docker build workflow, and git push origin main. And then we'll go ahead and jump back into our project here. We go into actions. Right away, it should be running, right? So we see the name of it. It says build container and push to do registry, whereas the Django CI and Postgres test one is a little bit different. And so I'll jump into here. Notice it's going to Docker build, and notice it's actually testing our Django code. How cool is that? Okay, so what happens here is Docker build finished really, really fast. Part of the reason for that is I actually didn't specify that Docker build required test Django to finish. So to do this, I'm going to go ahead and say uses, or rather not uses, but needs, and then test _ Django. So it needs this job. So we could call this test Django job just to make sure that it's clearly not the other test Django here, but it's actually that job specifically. So now if I do this, I'm going to go ahead and add it in again. And this time we updated the Docker build workflow. And git push all. Okay, so now, of course, the tests went through just fine. Now we've got a workflow that has a job that depends on another job, right? And so now they're piped like this. So they're no longer next to each other, which they can be. They can actually run concurrently, which is fine. But in my case, I want the Docker build to be like it actually has to happen prior to actually running the next step. Now, I can absolutely do this same thing for our Kubernetes part of the Docker build. I'm actually not going to do that. Instead, I'm going to just run build, and then everything I need to do in relation to Kubernetes is going to happen in this build.yaml. I just wanted to show you that these things are available. So if you needed to separate them out, you totally can. I am not going to separate them out for a very specific reason that will start to become clear just shortly. Okay, so the first thing is the step here. I'm going to give it a name, and we'll go ahead and say checkout code. I like naming the steps. That way you have them, although you don't have to do that. The next step is going to be install the DigitalOcean command line tool. So this is going to be using a open source command line tool that DigitalOcean allows for you to interact with its services. We didn't install this at all through this project, primarily because we didn't really have to. Now, we still don't have to. There is a way around it, but using the command line tool makes the actual workflows here in GitHub a lot easier, as we'll see when we get into the Kubernetes of it all. So anyways, so we'll go ahead and install doctl. And there's going to be DigitalOcean/action-doctl at v2. So if you ever have issues with it whatsoever, just do a quick Google search for it. You'll see that there's this action here, and it's a action doctl on DigitalOcean. There might be newer versions later, as I would imagine there will be, and it's going to show you exactly how to use it. And that's what we're doing here right now. So we can actually think about it in this terms as well. So what we want to say here is with token, and now I need to add in a token, which is going to be our secrets.do API key or something along those lines. Or we can say it's our API token key, right? Notice that it says secrets though. And this is why I recommended that you imported our repository instead of forking it, so that you can go into the settings of now your copy of this repository and go into secrets, go into actions, and create a new repository secret. In this case, it's our do API key. Now I need to actually go back into my DigitalOcean console. So let me just navigate to that. And I want to go down into API here and tokens and keys. I'm going to generate a new key. This time I'm going to call it Django. I'll call this K8's prod token. Actually, we'll call K8's GitHub action prod token. It's kind of a mouthful, but that's what we'll leave it in as. I'll copy this, and we'll go back into GitHub Actions repository secrets here, and we'll paste this in. Add that secret. Okay, so now I have that secret available to me. This is the repository secret, so I can absolutely use it now in my GitHub Actions, just like this. But of course, if I need to roll this key at any time, I totally can. And if that key is no longer working, this workflow will just fail, which is also nice to see. Okay, cool. So next up, after we have that key, this essentially gives us access to the things we need it to. And so I'll go ahead and say name, log into do container registry with short-lived creds or credentials. So we'll go ahead and do run doctl registry login, and then we'll expire this after a certain amount of time. So we'll do expiry seconds, and we'll do 1200, which we probably don't need that many seconds, but let's just give it a good amount of seconds in order for this login to expire. Now this right here is the reason we're using doctl at this point. We don't necessarily have to use it always, but we're using it at this point specifically because it expires after a certain amount of time. So that means that I'm not leaving something hanging for some example, right? So when I log into the registry, I just want it to expire. And so the next part is, of course, we're going to go now build our container image. So that's the next step. We've logged into all the services we need to log into, much like we did locally. The only reason it's not in the deployment guide is because it's kind of assumed that up here, 0, log into the registry via Docker and API key like we did, right? I just don't need to do that anymore once it's already done on my local machine. But in my GitHub action, I need to do it every single time. Now I'm going to go ahead and declare the working directory right here. And this, of course, is web. And then I'm going to go ahead and run the commands I need to run. Now in here, I can actually cd into web 2. I don't necessarily have to do it right here, but I like using the built-in features that GitHub Action has. Therefore, I use this working directory command when needed. So now I'm going to go ahead and do docker build, just like we've seen before. So we'll declare the file, of course, so Dockerfile, and then we'll give a couple new lines. So the first one, going back in here, I'm actually going to go ahead and copy these lines here. We'll bring those in, and let's make sure we tab and use that slash to allow for multiple lines. Okay. And then, of course, we want that period there. Now, this is the part that I want to change, this V1 here. So what is it that I want this to look like? Well, when I actually commit using GitHub, I get a commit string, a commit value that I can actually use inside of my builds here. So I'm actually going to go ahead and use that value, and we'll do $, GitHub _SHA, just like that. No $2 You don't need that. Just $1 and 1 curly bracket, and then 2 colons now, and we'll say 7. So this is going to give me the first 7 characters of the commit, as we'll see just shortly. So that will build a container, and it'll tag it twice, one with latest and one with this commit ID. And so if we think about this too, going back into our deployment guide, in this part of updating our deployment itself, our Kubernetes deployment, this latest image, now I can actually change it to whatever the commit ID is. So after it's built, that commit ID will update. We'll see this in action in a little while, probably in the next section. But now we'll go ahead and do name and push image. And I could say to container registry or whatever. Here we're going to go ahead and now run. And I'll do docker push, and then the base of this right here. And then --all -tags, just like that. Okay, so now of course we need this to run. So I'll do git status, git add, git commit, and updated build workflow, and then git push --all. All right, so now it's going to go ahead and push into our GitHub actions, and it should be running. And I'll let this finish and we'll come back. It's still running, but I wanted to mention that there's a bunch of variables, environment variables, that GitHub Actions come with that you don't actually have to handle. So there is also one called a run ID that should be unique for each workflow, which means you could use the run ID instead of the SHA, like this right here. But the reason I use the SHA is only because then I can better reference it if I need to for the actual commit and for the build, which we'll see as well. But it gives me all sorts of really interesting things here if you needed to. And of course, if you just do a quick search for GitHub Actions environment variables, you can see all those things, right? And basically I used it in a way that is pretty common, which you just use like a key substitution with a Linux type command. Excuse me, like a string substitution, not a key substitution. And then it actually cuts it down to 7 items, so it's not super, super long. That's kind of the key thing there. But it is nice that there are built-in environment variables for GitHub Actions. This is still building because it's going to take a little time for all of this to run, which is actually a good thing, right? So we wanted to take some time to test. The build part also does make sense that it takes some time, but it's actually not that much time, right? So build container image, it took 24 seconds and it worked. It appears that it worked. So I'm going to go back into my DigitalOcean account. I'm going to go into my container registry, and we're going to go ahead and take a look at this, image. So we come in here, it says 4 images. Now we've got the latest image as well as this commit SHA. So this commit SHA is great because now if I were to update my deployment, let's do this manually just to see what it looks like. We come into K8's apps. I change this latest to my new commit SHA, and we do kubectl apply -f K8's apps and Django-K8's web.yaml. I hit enter, and then I'm going to go ahead and do kubectl git pods -w to watch them changing. And what's happening, of course, is it's going to create each one of these containers. And, going back to that deployment guide, we, of course, need to do what I just did. But also, if I have this rollout status thing, this is going to hang on. It's just going to wait there until they're all finished, which means in the terms of GitHub Actions, it's not going to do the next step until that part's done, which would be migrating that database, as we've already discussed. But it's really cool to see it, at least locally, what's going to end up happening on our GitHub project itself. So the other cool thing is if I am local and I accidentally, let's say, for instance, I keep the deployment like this, which is how I want to keep it. I want to keep it locally as latest. In fact, this is what I'll always deploy on my GitHub project itself. But now that I have it local, if I do it again, I can actually do some of those changes. It will actually change them locally, although it will be the same container image. It's just using a different tag this time. But that also, I think, is pretty cool, so that I would have some ability to still work on this locally and not have to make any changes to the actual deployment file itself locally. And again, I want to keep this just like this because of what we'll do in the next one. But at this point, we now have a pretty robust system, even just here, right? We can test it, then we can build it, and we can push that image into the container registry, our custom container registry. So yeah, I think that's pretty cool. So now, of course, we just need to bring it all together and have it running through Kubernetes. Now, of course, we're going to update our GitHub Actions to actually use our newly created image. And so I'm actually going to skip the update secrets for a moment. We'll come back to that and really focus on the deployment portion. That is actually taking our newly built image, the container image itself, this one right here, and deploy that one into production on a GitHub action. Now, in our deployment guide, I actually updated it to have 4 ways to trigger this deployment rollout. One of the ways is calling this command right here. Now, this actually works, generally speaking, especially if you have image pull policy of always on your actual deployment, like I do right here. So in other words, if I actually always tag it to being latest, the latest one it'll use is going to be updated over time, right? So if I for sure have this tag here. But the question to me is, I might not have that tag. Or the other part of this is maybe I want to know specifically which GitHub commit caused any particular issues or what deployment that is. So in my opinion, I think having some sort of identifier on the image itself is better than just simply latest. However, this does work. So the next one is the image update. We can actually call directly which image we want to change. This is the one we're going to end up using. Another way to trigger a change is to update an environment variable. It's very similar to what we did up here in the sense that it would use just latest all the time. So in that environment variable, we could actually have the commit version if we wanted to. There's a number of steps we could get to do that, but I'm not going to do that. The other thing is, of course, changing the deployment file otherwise, not necessarily the environment variables, but making other changes like actually changing the image in line. Now, doing this change inline in a GitHub action is possible. It certainly is possible, but it actually is a lot more headache than is necessary. So I'm going to go ahead and just do the simple one, or as simple as I can think of it, is by changing the image on the GitHub action. So that's what we're going to be doing, and it's going to be very much like this. Now, before we can do that, we have to actually log in to use our Kubernetes cluster. So I have to use doctl, which is another reason to have this all in one step. doctl, I actually logged in here. So I got the container registry here, and I logged in actually specifically here. This is where I can use doctl locally or in this action. So we're going to go ahead and grab our K8s cluster, and this is the kubeconfig file, and we're going to save it with short-lived creds, right? So we want this to be local so that I can use kubectl. So to do this, it's pretty simple as far as the run command is concerned. We just run our doctl kubernetes cluster kubeconfig save -- expiry seconds. This one I'm going to have it be a bit shorter, so 600 seconds. It doesn't need to be as long because we are not building an image. It can be as long, it just doesn't need to be. Next, of course, is the cluster name itself, which in our case is Django-K8s. Now, when we see stuff like this, it might be a good idea to actually say cluster name and put it into our environment variables. And then that way we actually use that instead. But that's kind of up to you, especially with how we're doing it. This one in general is we haven't made this incredibly reusable. It's actually pretty not reusable because of the names here. I could totally make it better, and that would be a way to do so. And I just wanted to mention that now. Okay, so now we've logged into that Kubernetes cluster. We can go ahead and then say update the deployment image. Okay, so what this is going to do then is it's going to run that command kubectl set image. Then we need to declare the deployment, which in our case is this right here. So back into build, it's going to be deployment / that, and then the image we want to use for the container we want to use. So notice that inside of a deployment, we can have multiple containers in here. We only have one. We have to grab the one by the name. So whatever named container we have, that's the one we're going to go ahead and grab. And in this case, mine's Django K8s web, and we want to set it equal to this value right here. Quite literally the same value. So this will update the deployment image, and it will also create a rollout. So now what I can do is say verify deployment, or let's actually add a name here, and we'll go ahead and say wait for rollout to finish. And then this is going to be simply run, and we'll go ahead and do kubectl rollout status deployment, this deployment right here. So essentially waiting for all of the rollout to happen, which Kubernetes by default is going to do one by one. It's not going to destroy all of our current containers. It's going to actually slowly roll them out. And this happens to be a lot better if we have multiple replicas. So if we don't have multiple replicas, if it's just at one, then it will actually change that single one. But if we have multiple, then it'll do a rolling update by default, which is also nice. That is another setting that you can add inside of this deployment too. So check the docs for that. So this is going to wait for that to finish, as we've seen many, many times. And then we can actually run whatever final commands that we might need to run. So in our case, we want to run our migrate database command. And this again is going to be kubectl, but the first thing I need to do is we'll go ahead and export single running pod. And this one is what we've seen before, and I actually have a note for it in our deployment guide, which was using something along these lines where we actually grab a single running pod or a single pod name and do something along these lines, right? And so that's actually what I'll end up doing as well, is just making sure it's running just like that. And so now we have a way to migrate our final application. So this would be something I would definitely want to do shortly after or right after that rollout status. Now, one of the things that we also might consider is having something like this happen sooner, or something in the deployment state is to only roll out one of these and then run that migrate and then roll out a few more. That gets things a little bit more complicated. I think this actually works pretty well overall. And the nice thing about having this GitHub commit is, or the actual SHA, is that I can actually go back to a deployment that for sure is working in the past if I need to roll back. That's not something I'm going to cover at this time. But now we got that, we'll go ahead and add this in. And we'll go ahead and say that we have our K8s deployment in GitHub Actions. and we'll go ahead and do git push origin main. Okay, and in my case, I'm going to go ahead and say force because I've made a bunch of changes. But anyways, through that testing, I've found probably the best method, the easiest method for all of us to use, which is this right here. And so one thing I still need to do, of course, according to my deployment guide as well, is going to be adding in our secrets. That's something I definitely still will do. But before I even get there, I want to make sure that all of this is working correctly on my actions itself. So if we go into our GitHub Actions, I'll just let this actually finish off, and then we'll come right back. And great, so the deployment ended up working. As we see, it actually did wait. It waited about 30 seconds, not too long, which is great. And then it ran our migrate database command. In our case, it should just say all of these things, right? That username's already taken. Of course, in app/migrate, I can probably get rid of the create super user thing now. But at the end of the day, we have all that stuff. And we can also now just describe our actual deployment. So if I look at one of these deployments, I can see what the new image is, right? So of course, it's different than our local one. And if I apply the local one, things would change, only in the sense that the name would change. It actually might create new pods for us because the actual image changed, but the actual container that's running won't be any different. And we can verify this by going into our container registry here and looking at the repository, and we can see what the latest one is. So let me just refresh in here. I think I have quite a few of the latest ones because I was doing some tests. But the idea here is 1C8A065 and then latest and 1C8A065. So those are the exact same at this point. So if I were to just run it, it would do that. And the other cool thing is now, since I have these tags, if I have older ones that I want to change to, I can just run that same command that we just created, or that we just used, this command right here. I could do this locally and change it to the version I want to have on there. So I can just copy this really quickly and, oops, not that whole thing. I didn't realize it would give me that whole thing. So let's try that again. And we would then just change it to what that image is right there, which is really, really nice if I needed to change it really quickly or on the fly. So that's actually something that's interesting that perhaps we would do as a workflow item as well. At this point, I'm not going to touch that. What I do need to do as a real final step is going back into our deployments is actually adding in those secrets. So what I want to do for that is, before I set this image here or update the deployment, now I want to go ahead and do update deployment secrets, right? And so to do this, we're going to do basically the same thing I did locally. Now the first thing is we're going to create a new file, and this is going to be in web/.env.prod, and then we will have all of our environment variables in there. And then we will actually, so this actually creates the entire file. And then in the same command or the same step, we're going to go ahead and do kubectl delete whatever our environment passwords are, or the actual secrets are, which is this right here. Right? So we delete that, and then kubectl and create secret and generic, the secret itself, and then whatever we put at this path right here. So that might be in a different area. It's completely up to you. I just like keeping them all in the same area so the commands are the same locally and whatnot. Okay, so there we go. And that's it. That's pretty much it. But the thing is, we need to actually add in all of those proper passwords, all the environment variables there. So what I'm going to do is I'm actually going to come in here. I'm going to copy all of these, bring it into build.yaml, and paste them all in. And then we're going to tab them over. So select them all, tab them over into our env file. So you want to make sure that these are on the same line as I do have them here. I'll break this down. And there we go. So these are the only ones I really need. I don't need the Redis stuff. I got rid of that because I don't actually have Redis in here. And so in the future, when you need to update your production environment stuff, the actual environment variables, you'll do it right here. And so what I'm going to do now is I'm going to take the ones that I want to be secure, which is pretty much all of them, and then change them into $secrets dot Django super users, Django super user username, and then go into my repository, into the settings, down into secrets, and not actions, but there we go. So secret actions, or action secrets rather. And then we go in here, we bring that in, and then we add what name we want it to be, right? And then you're going to want to repeat that process for this whole thing. I'm actually not going to do this step by step, but I'll let you do it, finish yours off as well, and make sure the variables are correct. The nice thing about this is the allowed host. So if your allowed host changes for some reason and you need to run this again, you totally can. So you can run this build at any time because of workflow dispatch. And that's when you would actually run it only when you actually have deployment secret changes that you might need. And if for some reason that the GitHub SHA is not changing when you run it, you can add other environment variables such as the GitHub like number. Well, I can't remember what the number is, but the GitHub number that actually runs each time or increments each time. I think it's like the run number each time you actually run any of these workflows. So go ahead and update these now, and we will be right back. Okay, so I have all of my secrets added from here. And of course, like I said, if you need to add new ones, just add it right in here. And the thing is, if you for some reason needed to change them on the fly, you can. You could just log into your GitHub repo, go into your build.yaml, and you can absolutely change what's going to end up happening here. I don't have them yet because I haven't pushed this, but you can totally do that. And the nice thing is it's all in line, and it should actually reboot everything for you. In worst case scenario, you have a whole nother workflow that if you needed to reboot your entire deployment, you could do that, right? So let's see, it is this right here. If you needed to force that out, you totally could create a whole nother workflow that does that, that really just logs you in to your container registry right here. So first off, you log into the DCTL that is, and then you want to log into your Kubernetes environment. So this right here, and then you can run all of the Kubernetes commands as you see fit. Okay, so let's go ahead and add this one in now. So git status, git add, git commit, and added environment variables, and then git push origin main. Okay, and so now of course it's going to go ahead and do all of that building like we've seen before. And looks like I have an error here, a syntax error. Perhaps I have invalid spacing somewhere. Line 42. So we got line 42, and that's this colon here. Don't need a colon there. Let's try that again. So used to writing those colons. Okay, so we push it again, and now looks like we didn't get immediate fail. So looks like it's going to work now. Okay, cool. So in a moment, what we're going to do is actually implement this in this chain with all the changes that we might need to make, so we can actually have our static files working as well through DigitalOcean spaces. So the big thing about that is it's going to actually update this build.yaml to some degree, and maybe some execution commands that we might want to run. So I'm just trying to give you a practical example of something you might do in the future when you need to make some changes to build.yaml. One of the challenges I'll leave you with now, though, is to change your build.yaml to be a little bit more reusable for other kinds of, containers and images, right? So other kinds of deployments, that is, not just this Django deployment, but perhaps that IAC Python. Perhaps you want to add some stuff into that. So I'll give you a hint. It has something to do with this env right here to make the entire build a little bit more based in env. The other thing is you could potentially move out your build and push into different workflows if you really want to get your hands a little bit dirtier as far as getting all this stuff working. So one of the things that I probably don't want to have in the long run is this Django secret key as my environment variable at all, because I don't want it to accidentally get replaced somewhere in here like this Django secret key. Perhaps you accidentally do .env. Nah, that's not good, especially with this. So yeah, that's pretty cool. And if you have any questions on this, let me know. Of course, I think using the code on GitHub as a reference will help solve a lot of the issues that perhaps I didn't show or perhaps I didn't solve. But a lot of it is going to be you testing things out and making sure that you just have certain configurations done correctly. That was another reason why I went through that deployment guide, because if you didn't get that deployment guide, if that was still kind of hard or challenging to get through, this GitHub Action stuff would have been probably close to impossible. But now let's go ahead and take a look at a really practical way to update everything that we just did using our static files. And before we go, I just want to mention it should be kubectl delete secret. I think I just had it as delete, but of course the code on GitHub would reflect the correct one. All right, so let's take a moment to congratulate ourselves because we have our Django project running in production on a Docker container using and utilized by Kubernetes on DigitalOcean, which is fantastic. And on top of that, we have a sustainable way to deploy future versions of that using GitHub Actions, which is also fantastic. This one is all about adding in one more practical aspect to our Django project, and that, of course, is using our static files. Now, this is also going to show us how we're going to continue to update our project and why GitHub Actions is a critical step to ensure that what we're doing on Kubernetes or with Kubernetes is well supported. And also we're not having to manually do things constantly. So go ahead and log into your DigitalOcean account, go into spaces, and we're going to go ahead and create a new space for this project, right? So you're going to come in here and you're going to hit the green button, create and spaces, and then you're just going to make a brand new one. Now, in my case, I'm going to be using NY3, New York 3. You just have to use one that's pretty close to your users. Of course, if you can create, enable a CDN, I highly recommend that you do because you just need a custom domain to do so. Next, of course, I'm going to go ahead and restrict my file listing. I'll handle those things later. We don't need anyone to be able to list these contents in this space. I believe you can change this if you need to at some point in the future. So in my case, I'm going to go ahead and create a unique name for this. This space is also known as a bucket. I'm going to call mine Django-K8s-static. Okay, or maybe just Django K8s because that's been the name of my project. So there we go. And that's it. And then I'm going to go ahead and create this. Okay, so with that in mind, I'm going to go into my Django project now, and I'm going to make a new folder in here, and I'm going to call it just simply static files. And inside of here, I'm going to go ahead and say blank.txt and say blank on purpose. Cool. Next, of course, I'm going to go into my settings, and what I want to have is I want to have that in as my static root. We're going to give a blank as our static root. And I should mention that this will be also linked in the description, but this blog post right here does a lot of these things. And in there is our static root as well. I just want to add this in very first, and this is going to be simply our, oh, that's weird, our base directory and then our static files. Okay. So the base directory is already linked up here as well. And that's this right here. Next in our installed apps, I'm going to go ahead and add in storages. This is Django storages. Now, in my case, I should already have it in my requirements.txt right there. Okay, and I also want to make sure I have Boto 3 in there as well to ensure that this works because I'm going to be using the AWS version of this. AWS is the pioneer of the static file storage that we're using here, which is just object storage. So what we're going to be doing is obviously using this as our primary place to have all of our Django static files. Part of that being our admin static files, all the CSS and JavaScript, but also any of our other static files that we might need. Okay, so with this in mind, let's go ahead and add in all of our configuration. So inside of Django K8s here, I'm going to make a new directory called CDN. Inside of there, we're going to go ahead and create an init file. And inside of the, or next to the init file, we're going to go ahead and create conf.py. This is going to be a few things. We're going to first off import OS. We want to grab our AWS access key ID. We're going to want to grab our AWS secret access key. And these things are also going to be found on the Django storage documentation as well. AWS storage bucket name. Now, you might think this should be an environment variable. I actually don't think it needs to be an environment variable because it's pretty accessible once your project goes into production, but you could totally make it in as an environment variable itself. These two definitely should be. And of course, we're going to need to set these things in a moment. And we'll have to remember where all we're going to want to set them. Okay, so we've got that. Next, we're going to do our AWS S3 endpoint URL. And this is going to be where it's actually located, which is this link right here. It's really that simple. But it's also possible that we might need to get rid of that bucket for a moment. So I'm going to get rid of that bucket just for this one. And then I'll do my AWS S3 object parameters. Now, this one is actually probably pretty critical. First off, our cache control. You can set the age that you want to have on here. I'm going to do my max age being equal to 86,400 seconds. And then my ACL is going to be public read. So by default, I'm going to have it being able to be read publicly. Next up is my AWS location. I'll just set this one in here as well. And that's going to be my actual endpoint here. So I'll go ahead and copy this. That entire endpoint. There we go. And then what I want to do is my default file storage. And then also my static files storage. So this is for, one is for static files, things that I add to my project by default. These are like usually within the third-party packages we might use, or in our case is going to be the admin package. The default file storage is where I'm going to be uploading things to, right? So a user uploads, or my own team member uploads, stuff like that. So inside of here, I also want to create one more thing, and we'll just call this backends.py. And this one, I'm going to go ahead and just copy and paste some stuff. You can do the same, which is really just creating locations to where we want to store things on our bucket. So in other words, everything for all of our uploads is going to be under media by default. Everything for static files will be under static. And then of course I want to just reference these things. And so I'll just go ahead and also copy those to the path. So Django K8s, this right here, CDN, and this should say CDN, not that. So CDN, there we go. And then static files and so on, right? So we got our backend, cool. So now I need to get my access keys. Let's go ahead and do that. So back into Spaces, we want to grab Manage Keys here. And we're going to scroll to the bottom, Space Access Keys. We're going to generate some new keys here. The keys, I'm going to call this Django K8s. Now, I actually am going to do K8s local. I'm going to do two of them. One is going to be my local keys. So let's go ahead and grab these into our .env file. Not our prod file, but our .env file. I'm just going to copy them first. There we go. And then grab the environment variable names that I gave them in just a second ago. And that's those two right there. Great. So now I've got my local ones. I'll also generate some new ones. So Django, K8s, and prod. Now you might be wondering, where do we put these? Well, these are going to go on GitHub. So get into our repo, into settings, into our secrets, actions, and let's go ahead and add these in. So new repository secret. I'm going to go ahead and grab this first one. And again, grabbing the same AWS access key ID. That's going to be that top one. And then the secret is the bottom one. So we'll create a new one with that secret. And there we go. Okay, so now I've got those environment variables. I got everything configured as I think I needed. And then the last thing is, this is actually not what I want my static root to be, but I will change that in a moment. I actually want to go ahead and do from the .cdn.conf import all, and I'll do #no QA for, it's not always best practices to do a big import like that. This allows my VS Code or any code checker that I have to just sort of ignore that import. And I do want to have static files dirs, and this one is actually going to be my base dir here. This one will do -cdn. And again, inside of my web, I'm going to make another one. I'll just duplicate this directory here. And we'll call this one, we'll rename this one to being just -cdn. Okay, and I'm going to actually add in, let's do git status. Okay, everything's looking good so far. So let's go ahead and do a collect static now. I'll do first off source venv bin/activate cd into web, and then python manage.py collect static. Go ahead and say yes. Okay, and so this might take a moment, and while it's running, I'm going to go back into my DigitalOcean space for this and take a look to see if it actually is starting to have files, and notice that there is a folder called static in there now, which is great. So that means that it's actually creating the static files as need be. Notice that it says blank.txt. That is coming directly from this folder right here. I do want to keep that folder in there in case I need to add my own CSS or JavaScript. Static file CDN is meant to be our static root that we actually override with this right here. The static root becomes the actual DigitalOcean space. So now that I've got all of those things in there, that's a really good sign. So it means that at least it's working locally. So now I need to make sure that it's working in production. So first and foremost, my env, my .env, these keys need to go into my GitHub build.yaml. So we're going to come back in here. I'm going to paste those keys in. Of course, I don't want to expose the actual key itself, but instead I need to update my secrets, right? And so that, of course, is a critical step here. And then we're going to go ahead and do $secrets, just like that. Save it. Okay, very good. And then the next thing is I'm going to go ahead and copy this migrate here, and I'm going to make a new one called collect static.sh, paste that in, and instead of migrate, it's just going to be collect static, and then no input as well. And I'll get rid of the super user email. I do not need that. So we save that as well. And our Dockerfile doesn't need to change at all. Migrate.sh shouldn't need to change either. Collect static.sh, I don't believe we'll need to change. We might need to make it executable, but I do not believe we need to change it. So with that in mind, I can actually come down here now and do one more step. Come down here and call collect static.sh, or did we, let's see. Yep, we called it collect static.sh. And now I think I've got everything necessary with all of these changes. Okay, so now we'll go ahead and do git add --all, git commit, added static files for Django storages and do spaces. And we'll do git push origin main. Okay, that's it. So I did collect the static files, and I think that they'll be collected again. So actually what I'm going to do in here in my spaces, I'm going to go ahead and delete these because it should actually collect those static files again, and it should actually bring them back in again on GitHub. And it will have some time before it actually does do that. So if we go into our actions here, first, of course, it's going to test everything, which takes some time. After it tests everything, then it's going to go ahead and build it and run it and do all that good stuff. So that's actually a pretty complete look at what we would need to do if we are changing all of this different stuff. In this case, it's a really practical example because we have a actual third-party application that requires us to update our environment variables as well, locally and in production. So locally, another thing that you could consider testing or at least implementing is your env prod and updating this to be actually the prod variables. I actually think it's not a good idea to have your production environment variables locally anymore. Even if I mentioned it before that I like testing it every once in a while, at this point, there's really no good reason to have these locally and exposed like this to where if anyone gets on my computer, they would just be able to access all this stuff. Whereas if it's on GitHub, in the current form at least, and you go into the secrets here, there's actually no way to review these secrets. You can only change them, which is generally fine, especially if the actions are running and stuff like that. But the thing is, you can't just look at them. you actually would have to go to the source. You'd have to go to, DigitalOcean and find all the different keys and whatnot like that. So that's also another thing that's worth considering in the future for you. But of course, that's just one of those best practices. You don't want to have your keys exposed too often. The local one, this does still give me access to my local keys as well. So you can kind of have both of those things in both places. But just the general idea is in production, you don't want to have those keys exposed in too many places. That's really, really critical. Okay, so now that we've got all this, we just need to verify that the DigitalOcean project is running. So I'm going to let this finish building. So far, it looks okay. The thing that I'm only worried about is this migrate database command, which should probably be changed. The name should probably be something more like, instead of migrate database command, it should be like post build Django commands. Something like that. Post build, not Docker, but Django commands, migrate, collect, static. Cool. So the other thing that's really nice, I think, about how it's currently set up, if you need to make a new admin user for some reason, you can just go into your GitHub Actions, change your super user stuff in here, and then you can actually create a new admin user that way. It has to be a new one. It won't actually reset the admin user password or whatever you put in here. It will actually be a brand new one. And so I get an error here, and I think it's probably because that file is not executable. Let's go ahead and see. I get a Boto Core forbidden option here. So it's not actually allowing me to run this, which is interesting. So what I'm going to do with that then is I'm going to call that command locally. So let's go ahead and do git pods, or kubectl git pods. Sorry, I have that shortcut. So kubectl git pods. And we'll call this pod right here. 110 seconds. This should be the latest version. So kubectl execute it, and then bash app collect static.sh. And yeah, we're getting forbidden. Okay, so let's go ahead and jump into the shell. So we'll come back here and go into bin/bash. And all I'm going to do is the manual version, so source, and that's going to be /otp venv bin activate, and then python manage.py collect static. Oops, python manage.py collect static. Say yes, and still same problem. So we're going to go ahead and run into Python, import OS, and let's take a look at our environment variables. Let's see if the access key is in there. So we'll go ahead and print out os.environ.get AWS access key. That works. And print os.environ.get AWS secret access key also works. So certainly possible that I have the wrong keys. Let's just verify that by going back into our API keys here and scroll down to the bottom. And where is it? There's our prod key. We're going to go ahead and regenerate this. Okay, so now we've got that key again. Should be the same ID. It's not even the same ID. I made a mistake. Clearly. Okay, so going back into GitHub, let's go into our AWS secrets, actions, and secret key. That's the one right there. And our ID. There we go. Okay, so hopefully that actually changes the equation a bit. And I'm going to, luckily though, what I didn't see as far as an error is concerned is when I tried to run this, I didn't see that collect static was not executable. It is trying to execute. It just looks like it maybe had the wrong keys, which is interesting. I thought I put the right ones in, but I guess I didn't. Okay, now that I've changed the keys, let's go ahead and try and run that again. I'll click the workflow and hit run workflow. Okay, so we'll let that run and we'll come back. Okay, so the build failed again, and I know why. The reason being that our actual deployments are the same. So I'm just going to go ahead and roll them out, and we'll look at our pods now. And what this will do, of course, is create brand new ones, new deployments. A big part of the reason is because the build itself, I didn't actually push anything to GitHub. And so it just ran the previous Git SHA. It didn't actually change that part, which is part of the reason why I mentioned that you could put in the environment, the build actual number. So GitHub actions, environment variables. And if we go in there and look for the workflow or the build, let's see here. Let's scroll down a bit. I always forget what this one is. It is going to be down here in our run ID. Okay, so a lot of times you might end up doing that so that you have a really unique item here. This might be a little long, so let's go ahead and put this down to like, I don't know, 5. This, yeah, we'll leave it in as 5. And then we'll come back down a little bit more to where we need to use that again. Right there. Okay. So we do git status. We'll add that in a moment, but I want to just make sure that this is able to work even locally with my new pods. And here's one. So we'll go ahead and do kubectl exe-it, that pod, 2 dashes, and then bash app and collect static.sh. We just want it to work one time. If it works one time locally, it should work in our build process. There it goes. Okay, cool. So clearly I didn't save things correctly or I didn't put things in correctly. But now I updated my build so that it can run at any time. So we'll go ahead and do git status, git add -- all, git commit, and updated build for collect static, and git push origin main. And now it should run again. So we'll actually see it again. And hopefully with this new image, it's going to be a much longer tag, which I think there's probably some sort of limit to the tag name itself, but this is probably not too long, 14 items here, right? So we got, or 13 items, whatever. So we don't have that many actual characters as part of the tag, but we'll see what ends up happening there. It's maybe something worth taking a look at. The other part is actually having this rollout command is now I'm seeing to being a pretty good workflow itself. So let's go ahead and add in rollout.yaml here. And I'll go ahead and grab my build, copy the whole thing, paste it into rollout. What I don't need is this to run every time. I really just need it to run here, maybe on the workflow call. So I'll have it as both. So we'll go ahead and roll out our Django deployment. And really what I need to do is log into doctl. That's this, of course. I shouldn't have to log into the registry. So I'll go ahead and get rid of that. All the way down to, I think, just my Kubernetes login, which is right here. So go ahead and leave that. Let's go ahead and bring this back up to our secret. There we go. I do not need to update this. In fact, I should be able to get rid of everything here. And now name, run, rollout on deployment. And back into our deployment guide. This is the rollout. There we go. We probably, did I use the cluster name? I can't remember. I did. There it is. I do not need to run the tests, although you probably won't ever need to run it. And then we'll just call this rollout. And there we go. The secret is the same, so we're still using that secret again. Git status, git add -- all, git commit, added rollout workflow. And I'll just push it in a moment, but I really just want to see that this is actually working again. Hopefully at this point, we have it all solidified and ready to go. Now, for as much of GitHub Actions is a really great tool to use, things like what we just did can get a little frustrating because there's a lot of back and forth and trying to figure out what exactly happened. Thus, testing locally is often a good idea. I should have actually tested all of this deployment locally to some degree because I made not a major change, but enough of a change to the actual rollout to where it would have made sense to test it locally first, like to actually run the post Django command locally first. But here it goes. It actually did collect those static files as we see fit. And so now we've got everything as is that we needed. And we also have this new cool rollout thing. So if I ever need to just update my images, it's going to do that as I need it to. Pretty cool. So now, of course, would be the next test that we should absolutely do is create actual Django tests to see if that's working properly, because it should be. Now let's go ahead and create a Django app with a test that succeeds and a test that fails, as well as a model. So we'll go ahead and make sure our virtual environment is activated. Of course, we'll cd into web and then python manage.py start app. And we'll just call this posts, like blog posts or any other kind of posts. And inside of here, let's go ahead and create a really, really simple model. And I'll go ahead and just call it class post, and it's models.model. And we'll go ahead and give it a title equals to models.char field, max length being 120. And that's probably all I'll leave. It's incredibly simple, but the main part here is really just to test things out to make sure that future features that we might want to add to Django are working correctly. I'll also add it into the admin. So from.models, we will import post and then admin.site.register that post. Again, we can verify this once we go into production. Next, we're going to go ahead and create a test. So I'll go ahead and do post test case, and it takes in test case. And I just want to do test failure. This will be our initial one. And all we're going to go ahead and do is say self.assert true, false. Okay. So naturally asserting true and false is, well, false. So now that we've got that, let's go ahead and add this into our installed apps as you would. So then this would be like our internal ones. And I'll go ahead and say posts. This is, of course, external. This is typically how I like organizing these whenever I have internal and external applications. So now if I run python manage.py test locally, I should get a failure, right? Actually, first off, we have to run python manage.py make migrations, and then python manage.py migrate. It looks like maybe my database wasn't working correctly. So let's go ahead and run that test again. And we'll go ahead and say yes to delete the other database. And we see that it fails, right? So false is not true. Okay, cool. So now we have a failing test. So let's go ahead and do git status, git add -- all, git commit. And we'll go ahead and say added posts model and test. Okay, so we're going to git push -- all. And the main thing here is we want to test in our workflows that this fails and then it doesn't continue on any longer. Now, this is actually going to be fairly obvious because of other failures we've had, but this failure is a little bit more realistic in the sense of Django's portion in all of this. All of those other failures were not necessarily Django related. They were just other sort of configuration issues that we're coming up against. And so now that we've got this, we can actually see a real failure because of a real test related to Django, which is pretty cool. I'm going to go ahead and let it finish actually running this workflow and we'll take a look. And it finished running. Naturally, our run tests here ended up failing, and it's going to say the same sort of thing, or at least it should. This time it's saying that it does not support SSL, but SSL was required. So we have another error that's now showing up, and it's related to our database and our testing, of course, as well as inside of our workflow. So let's go ahead and do test Django. One of the things that we don't have in here, which I did mention a long time ago that we probably need to add, we now definitely need to add it, and that's db-ignore SSL. So let's go ahead and add this in here, and we'll go ahead and say true. And I believe we have it in as the string of true. And sure enough, we do. So we definitely want to ignore this. So now we'll go ahead and run this again. So that again is not a Django test. That's just a environment variable error that happened there. So we'll go ahead and add that in. Git commit, updated env for testing Django in GitHub workflows. And again, we'll go ahead and push it all. This time, the test that should fail is not that one, not related to the database. So we'll go ahead and take a look at that once it finishes. And the test finish this time we should see the same assertion error that we had locally, false is not true, which of course is a good sign. That is showing me that at least my tests, assuming that they are good tests, which this is not, they are working though. So what we could do is just make this a little bit better. And let's go ahead and do from .models. We're going to import our post model and we'll just define setup here in this method. And we'll do post.objects.create title equaling to hello world. And now I just want to assert that the query set that I have here, so post.objects.all, that qs.exists. That's it. Now running this locally, so python manage.py test, doing that again. This time we should get a OK, and we'll go ahead and do git status, git add -- all, git commit, and updated tests for valid tests, something like that, and then git push -- all, and there we go. Okay, so what we are now wanting to see, number one, of course, is to make sure that the workflow actually is successful, which is going to be true. And then number two is actually making sure that in our production Django project, that not only do we have this post model, but it's also accessible, like we can actually change it. So looking at this locally, if I run the server here, what I should see here is going into the admin. We should be able to log in as the environment variables user. So in this case, it's just simply admin and this password. And then we've got our posts here. And I should be able to add in a post like hello world, save it, and this should actually save it. And of course, if I close out the server and run it again, I shouldn't have to run any migrations or anything like that. It should just be there, should be persistent. Now in production, we're most likely going to see this given what we've done, but there's certainly the possibility that we won't see this. Now the first step already did succeed, so the actual job did complete. But of course, if we did anything wrong, then when we actually do a future deployment, the post will disappear. It won't remain persistent, which is of course what we're trying to avoid. Now, there is another way to ensure that the post does stay persistent and we're not actually using a SQLite database at all, like the default, that is. And that is just getting rid of this setting right here and not having this DB is available. We could quite literally just have this and only this in our settings.py. So then when we run our tests, if none of the database is available, our tests will fail. And that's going to end up being true when we go into production as well, because we run our migration, which will also mean that our tests, or not necessarily our tests are failing, but our database is not connected correctly. And so that's something else that would end up happening. I'm actually going to let this finish building, and then we'll go ahead and take a look at the proper image itself and go into the cluster to make sure that this is actually working. So we'll look at the service IP address in a moment. So it's still deploying and it's almost done. But what I want to do really, hopefully kind of quickly, is go into the admin. And let's see if I'm logged in. I'm not logged in yet. So let's go in here and grab our production super user password. Hopefully I can do this fast enough. But I log in here. I should not, I already see posts. It was too fast for me. Anyways, so it actually ended up working, which is great. So we can also verify that this ended up testing okay. It finished in a little over a minute. Let's say maybe 3 minutes total in pushing this into production. And now I can actually go ahead and do a post and say hello world and hit save. And sure enough, it saves. So what I should be able to do also is if I do kubectl get pods, I should be able to pick any Django project in here and kubectl exe-it, and then -- and bin/bash. I should be able to come into any of these, activate the virtual environment at otp venv bin/activate, and then I should be able to run into python manage.py shell, and then do from post.models import post, and then do qs equals to post.objects.all, and then for I in qs, we can print out I.title, or I think we called it title. And there it is. Okay, so on any of my containers, I should be able to have access to this. And this is just another thing verifying that it's all working and it's working as intended. And also migrate runs, collect static runs, all of that stuff is running, and it's running without me doing anything. It's just going along really, really well. The one thing that I had to do locally was run make migrations, right? That was the one key thing that I have to do locally, which could be solved with using something called pre-commit. But realistically, if you are developing in Django after you create models, you just want to get in the habit of running make migrations. That's just a very common thing to do. Now, if you don't run make migrations and your model file is different, then it's going to give you a warning and potentially an error and potentially come down, which is also pretty interesting to see. Now, one of the things when it does happen, when errors do happen, because they will, what I tend to do is I tend to actually go into a pod just like this and see if I can diagnose the errors in the pod itself. Another thing is, of course, using kubectl itself. So if we do get pods, we can see a specific pod here, and we can do kubectl logs and then that pod name. And that should show us at least some of the errors that potentially could happen. Now, there's other ways of logging in here, but what you might see is actual errors coming through inside of this log. And the last and final thing that I'm not going to set up because we're basically done is actually setting up your email, like the actual transactional email inside of Django, which I do have blog posts for, but you can set up that transactional email so that if there is a 500 server error, it will actually email to your admins what that error is. And if you set it up correctly, that will be a really good thing. So to me, that's one of those production things that you definitely want to have set up. It's just not something I'm going to set up at this time because I have a blog post for it. And also, it's actually fairly straightforward on how you end up doing it. But now we have a really nice workflow for deploying our Django project. And we verified it by adding a third-party package in the last one, which actually had a number of significant things we had to change. And then in this one, which was far less things that we had to change locally and in production, we just had to check and verify one of our workflows, and that's it. I mean, and that workflow change is not always going to be common, right? So this right here, ignore SSL, that only happens on certain databases, and it's not necessarily going to always happen in your production files. Now, this one single environment variable might actually get you into the point where you want to have a different settings module for your different environments, for your different stages. One being your development stage, one being your production stage. So you can actually duplicate or reuse settings modules for those different stages. Now, I have an entire blog post on this called Staging Django for Production, which is all about this, is being able to switch between different settings modules. Now, I'm going to show you how to do it with just Python manage.py. It's not a whole lot different with gunicorn, but the idea here is that if you run Python manage.py, you can actually declare a different settings module. Let's do run server and -- settings. So my default is going to be in settings.py inside of Django K8s. So I can use Django _ K8 dot using dot notation because it's Python, and then simply just settings. I don't need to do .py. And then of course I can change the actual port itself. And what this does is just changing that settings module. That of course is not the only way to do it, right? So if you go into, let's say, WSGI, notice that it's actually setting the default Django settings module in, what do you know, our environment variables right inside of the WSGI file. It also does it in models.py, or not models.py, manage.py rather. It does that same thing, as you probably have already noticed, but it is something that's pretty important to know about. Now, when I see this setting and I run this module setting right here, it actually does change it. So let's go ahead and take a look at that example real quick. I'm not going to keep this. I will actually delete it. But let's go ahead and just rename this to like dev, right? So to actually use dev, it would just be simply Django k8s.dev, and then I run that, and now it's showing me this different settings module. And it's the exact same settings in this case, but it's really just to highlight how you can actually use different environments to your advantage. Now, I actually have solved doing different settings modules myself by using the combination of Docker Compose with environment variables, just as we've seen here. The reason I like doing that is because then my local development environment matches almost identically to what my production environment is. And if I'm testing out new features, I don't have to expose those features to all users, right? I can only expose them to certain users. And that's typically what I'll do when I'm testing out new features. And if there's dramatically new features, I can have them in as environment variables and then just do a custom deployment, whether it's in Kubernetes or not, but having a custom deployment that is directly for those new features, right? And then changing perhaps environment variables right in there. And again, not exposing that to the outside world and not making that my main project. So just a few things to think about when it comes to actually building your Django projects. But of course, the key of all of this is to just get going, build it, get it out there, and use as much of Django and Kubernetes as possible. I really, really like this combination. I think it has a lot going for it. And it's going to be even more valuable if you start using other smaller services throughout your project that are complements to your Django project, but not necessarily running within your Django project. Those are called microservices, but oftentimes it is a good idea. And that's what Kubernetes really excels at, is when you start to add in a lot more services on here. Kubernetes handles the management of all of that really, really well. All right, let's keep going. Hey, thanks so much for watching. Hopefully you got a lot out of this series. I want to leave you with two challenges. One, actually deploy a brand new web application onto your Kubernetes cluster, whether that's a Python application or not. Just deploy a new one, basically taking everything we learned in this series and applying it to something new, and then do that again. And then the next challenge would be to how to communicate across deployments through Kubernetes. Not with an external IP address and not with a domain name, but rather through Kubernetes. I'll give you a hint. It has something to do with services and how we communicate within Docker Compose itself. That's what I'll leave you with. But thanks again for watching, and I look forward to seeing you next time. And thank you to DigitalOcean for helping us out with this one. Thanks again. See ya.